SAP MM ECC to S/4HANA Migration, the complete failure framework.
ECC to S/4HANA migration is not just a technical upgrade in materials management. It is a structural transformation that touches valuation, planning, logistics, compliance, reporting, performance, and governance. Most migration issues are not caused by bugs, they are caused by assumption carryover. This video covers over 100 real-world failure scenarios encountered during Brownfield SAP MM migrations. Each scenario is classified by complexity and phase, so you know when it hits and how dangerous it is. We also identify true ownership versus perceived blame and explain how to fix it properly by role. This is not a checklist, it is a migration survival map.
Master Scenario Template, locked for SAP MM Migration.
Every scenario in this video follows a consistent structure: classification, root cause analysis, migration exclusive explanation, ownership, blame versus ownership reality, correct fix by role, common wrong fixes, follow-ups, and pro tips. This template ensures clarity, accountability, and strategic depth across all categories.
Complete category overview.
Here are 21 categories with 100+ scenarios that we are covering in this video. Category 1, pre-conversion and simplification failures, 6 scenarios. Category 2, core data model simplification, MATDOC, 5 scenarios. Category 3, material ledger mandatory activation, 6 scenarios. Category 4, parallel valuation and transfer pricing, 5 scenarios. Category 5, material master and field extensions, 7 scenarios. Category 6, business partner, vendor to BP conversion, 6 scenarios. Category 7, procurement process behavior changes, 7 scenarios. Category 8, logistics invoice verification, 5 scenarios. Category 9, inventory management and movement types, 7 scenarios. Category 10, WM to Embedded EWM transformation, 5 scenarios. Category 11, MRP live transformation, 6 scenarios. Category 12, international trade replacement, 5 scenarios. Category 13, settlement management replacement, 5 scenarios. Category 14, reporting and analytics breaks, 5 scenarios. Category 15, authorization and control redesign, 5 scenarios. Category 16, cross-module integration failures, 5 scenarios. Category 17, HANA performance and runtime impact, 5 scenarios. Category 18, extensibility and modification surprises, 5 scenarios. Category 19, data migration and historical semantics, 5 scenarios. Category 20, output management full replacement, 5 scenarios. Category 21, Fiori and user adoption revolt, 5 scenarios.
Category 1, pre-conversion and simplification failures.
Before the system even converts, S/4HANA performs a structural audit of your ECC configuration, custom code, and data model. This is where historical shortcuts, deprecated logic, and unfinished cleanups are exposed. Many projects underestimate this phase and pay for it with delayed conversions.
Scenarios covered in Category 1.
1. Simplification item check flags obsolete movement types. 2. Classic credit management active blocks conversion. 3. Incompatible add-on stop SUM midway. 4. Industry solution conflicts with S4 data model. 5. Custom enhancements referencing removed tables. 6. Data archiving not completed conversion runtime explosion.
Scenario 1, simplification item check flags obsolete movement types.
During pre-conversion, the simplification item check flags obsolete or incompatible movement types used across inventory processes. The conversion cannot proceed until these inconsistencies are resolved. What initially appears to be a minor configuration detail often exposes years of accumulated ECC design shortcuts.
Scenario classification.
1. Complexity critical conversion blocking. 2. Phase pre-conversion SUM or simplification item check. 3. Primary ownership MM configuration led. 4. Supporting ABAP code remediation basis SUM execution.
Why this happens, scenario analysis and root cause.
At first glance, this looks like a technical validation error. In reality, it is the system auditing historical configuration discipline. 1. Certain ECC movement types are deprecated or replaced in S/4HANA. 2. Custom Z enhancements reference hard-coded movement values. 3. Old configuration was never rationalized because ECC allowed it. 4. Simplification checks expose design patterns that were never cleaned. This is not a new problem. It is an old problem finally being enforced.
Why this is a migration-exclusive failure.
This issue rarely interrupts daily ECC operations. It appears only when the system is structurally challenged. 1. ECC tolerated legacy configuration inconsistencies. 2. S/4HANA enforces stricter movement validation rules. 3. The simplification item check exists only in conversion projects. 4. Transformation exposes technical debt that steady-state ECC hid. If it blocks conversion, it means the architecture was fragile all along.
Ownership, who actually fixes it.
Although the conversion stops technically, the remediation spans configuration, code, and execution control. 1. MM configuration led maps obsolete movement types to valid S4 alternatives and validates process impact. 2. ABAP code remediation refactors custom logic referencing deprecated movement values. 3. Basis SUM execution reruns simplification item check and manages controlled restart of conversion. 4. Leadership adjusts risk reporting if remediation scope expands.
Who gets blamed versus who owns it.
When conversion halts, reaction is immediate and often misdirected. 1. Blamed basis because SUM stopped. 2. Blamed SAP for removing movement types. 3. Actual owner MM configuration and ABAP custom logic. 4. Root cause historical technical debt surfaced during structural enforcement.
How this is actually fixed, the right way by a role.
Passing the check is not the objective. Stabilizing the configuration architecture is. 1. MM reviews movement type usage across all plants and processes. 2. ABAP scans and corrects hard-coded references in custom programs. 3. Cross-module validation ensures accounting and stock impacts remain consistent. 4. Basis resumes SUM only after controlled regression validation.
What not to do, common wrong fixes.
Under timeline pressure, shortcuts become attractive but dangerous. 1. Deleting movement types without tracing historical usage. 2. Temporarily disabling custom code to pass the check. 3. Restarting SUM without regression validation. 4. Treating simplification flags as minor configuration noise. Quick remediation here creates silent financial inconsistencies later.
Follow-up 1. Why does this issue surface only during conversion?
Answer: because ECC allows configuration inconsistencies as long as transactions execute successfully. The simplification item check performs a structural compliance audit against S/4HANA rules. It identifies legacy dependencies that were technically functional but architecturally outdated.
Follow-up 2. How can teams prevent this before SUM starts?
Answer: by executing simplification item checks early in sandbox environments and conducting structured movement type usage analysis. Custom code remediation and configuration rationalization should be completed well before the production conversion window.
Follow-up 3. Curveball. Why do experienced teams still underestimate movement types?
Answer: because movement types appear operational and procedural. However, they control stock valuation logic, integration triggers, and accounting flows. A small configuration object often governs system-wide financial behavior.
Exclusive pro tip.
If the simplification item check blocks you, it is not stopping progress. It is protecting the integrity of your future S/4HANA landscape.
Scenario 2. Classic credit management active, blocks conversion.
During pre-conversion checks, the system detects that classic credit management is still active in ECC. S/4HANA requires migration to FSCM credit management. Until this transition is completed, conversion cannot proceed. What appears to be a finance configuration issue often becomes a cross-module architectural blocker.
Scenario classification.
1. Complexity high to critical conversion blocking. 2. Phase pre-conversion during SUM or simplification item check. 3. Primary ownership SD and FI configuration led. 4. Supporting ABAP integration adjustments, basis SUM execution.
Why this happens, scenario analysis and root cause.
At first glance, this looks like a simple functional replacement. In reality, it represents a structural redesign of credit exposure logic. 1. Classic ECC credit management is technically incompatible with S/4HANA architecture. 2. FSCM credit management is mandatory in S4. 3. Custom reports and user exits depend on legacy credit tables. 4. Projects delay migration planning until conversion phase. This is not a configuration tweak. It is a functional redesign requirement.
Why this is a migration-exclusive failure.
In steady-state ECC, classic credit management runs without issue. The problem appears only during structural enforcement. 1. ECC supports both classic and FSCM models. 2. S/4HANA removes support for the classic model. 3. Simplification enforcement blocks conversion until redesign is complete. 4. This structural shift exists only in transformation programs. The system is not failing. It is enforcing architectural modernization.
Ownership, who actually fixes it.
Although conversion stops technically, remediation spans functional design, integration, and execution planning. 1. SD and FI configuration-led, design and activate FSCM credit management. 2. ABAP integration adjustments, refactor custom credit checks and reporting logic. 3. Basis SUM execution, manage conversion sequencing after functional migration. 4. Leadership, align business stakeholders on credit exposure redesign.
Who gets blamed versus who owns it.
When conversion halts, the pressure escalates quickly. 1. Blamed basis because SUM cannot continue. 2. Blamed SAP for forcing FSCM migration. 3. Actual owner SD and FI configuration strategy. 4. Root cause functional modernization was postponed until conversion.
How this is actually fixed, the right way by a role.
Enabling FSCM is not enough. The integration and exposure model must be redesigned properly. 1. SD and FI activate FSCM credit management and migrate credit master data. 2. Exposure calculation logic is validated against real business scenarios. 3. ABAP adjusts custom enhancements tied to legacy credit tables. 4. Conversion resumes only after end-to-end credit process validation.
What not to do, common wrong fixes.
Under conversion pressure, teams often attempt shortcuts. 1. Activating FSCM without redesigning credit rules. 2. Migrating credit master data without validating exposure logic. 3. Disabling custom credit checks temporarily. 4. Assuming SD testing alone is sufficient. Credit logic errors surface in production revenue, not in test scripts.
Follow-up 1. Why is FSCM migration more complex than expected?
Answer: because FSCM is not a technical switch. It introduces a new credit data model, exposure calculation logic, and integration with business partners. Simply activating it does not replicate classic behavior. The exposure and risk calculation rules must be validated carefully.
Follow-up 2. Can FSCM be implemented after technical conversion?
Answer: technically yes, but strategically risky. Delaying FSCM migration compresses functional redesign into post-conversion stabilization. This increases operational risk and creates revenue-impacting credit disruptions during hypercare.
Follow-up 3. Curveball. Why do business teams underestimate this migration?
Answer: because credit management appears to be a background control function. In reality, it directly influences order release, delivery, billing, and cash flow. Structural changes in credit exposure can materially impact revenue operations.
Exclusive pro tip.
If classic credit management is still active late in your project, your migration plan is already behind. FSCM redesign should begin long before conversion freeze.
Scenario 3. Incompatible add-ons stop SUM midway.
During technical conversion, Software Update Manager stops because one or more installed add-ons are not compatible with the target S/4HANA release. The system cannot proceed until these components are upgraded, replaced, or removed. What looks like a technical interruption often exposes ungoverned landscape complexity.
Scenario classification.
1. Complexity critical hard conversion stop. 2. Phase conversion during SUM execution. 3. Primary ownership basis landscape governance led. 4. Supporting MM process impact, ABAP custom object dependency review.
Why this happens, scenario analysis and root cause.
At first glance, this appears to be a version mismatch. In reality, it reflects long-term landscape sprawl without upgrade discipline. 1. Third-party or SAP add-ons are not certified for the target S4 release. 2. Component compatibility matrices were not reviewed early in the project. 3. Custom enhancements depend on add-on specific objects. 4. Technical debt accumulated without lifecycle governance. SUM is not failing randomly. It is enforcing release discipline.
Why this is a migration-exclusive failure.
In ECC, incompatible add-ons can remain unnoticed as long as the system runs. 1. ECC landscapes tolerate mixed component states for years. 2. S/4HANA conversion enforces strict component compatibility validation. 3. Add-on lifecycle misalignment surfaces only during structural upgrade. 4. This enforcement occurs specifically during transformation programs. The conversion exposes governance gaps that operations tolerated.
Ownership, who actually fixes it.
Although SUM stops technically, resolution requires both technical and business evaluation. 1. Basis landscape governance-led identifies incompatible components and coordinates upgrade or removal strategy. 2. MM process impact evaluates business dependency on add-on functionality. 3. ABAP custom object review assesses custom code relying on add-on objects. 4. Leadership approves risk decision if functionality must be replaced.
Who gets blamed versus who owns it.
When conversion halts mid-cycle, escalation is immediate. 1. Blamed basis because SUM failed. 2. Blamed SAP for restricting compatibility. 3. Actual owner, landscape governance and release management discipline. 4. Root cause, add-on lifecycle planning was never aligned with transformation roadmap.
How this is actually fixed, the right way by a role.
Resolution requires structured compatibility remediation, not emergency patching. 1. Basis validates add-on compatibility matrix against target S4 release. 2. Vendors are contacted for certified upgrade versions. 3. Custom dependencies are removed or redesigned where required. 4. Conversion resumes only after controlled regression validation.
What not to do, common wrong fixes.
Under pressure, teams often attempt shortcuts that increase risk. 1. Forcing technical bypasses to ignore compatibility checks. 2. Removing add-ons without business validation. 3. Applying emergency patches without lifecycle review. 4. Restarting SUM repeatedly without root cause resolution. Quick technical bypasses create unstable production landscapes.
Follow-up 1. Why are add-on issues often discovered late?
Answer: because many projects focus on custom code remediation and overlook component-level compatibility analysis. Add-on reviews are sometimes treated as administrative tasks rather than structural risk assessments. This oversight surfaces only during technical enforcement in SUM.
Follow-up 2. How should add-on compatibility be managed properly?
Answer: by performing early landscape inventory analysis and mapping each add-on to SAP's official compatibility matrix. Vendor coordination should occur months before conversion freeze. Compatibility should be tracked as a formal risk item, not an afterthought.
Follow-up 3. Curveball. Why do executives underestimate add-on risk?
Answer: because add-ons are often viewed as optional enhancements. In reality, they may support compliance, reporting, or industry-specific processes. Removing or upgrading them without strategic review can materially disrupt operations.
Exclusive pro tip.
If your add-on inventory is not documented and aligned with SAP's compatibility roadmap, your conversion timeline is already exposed to disruption.
Scenario 4. Industry solution conflicts with S4 data model.
During conversion preparation, the project discovers that an active industry solution or industry-specific enhancement conflicts with the simplified S/4HANA data model. Core tables, valuation logic, or process flows behave differently. The system cannot be converted until structural incompatibilities are resolved.
Scenario classification.
1. Complexity high to critical structural redesign required. 2. Phase pre-conversion during system readiness assessment. 3. Primary ownership MM process architecture led. 4. Supporting ABAP code remediation, basis component validation, functional leads.
Why this happens, scenario analysis and root cause.
Industry solutions often extend ECC using assumptions that no longer exist in S/4HANA. 1. Industry add-ons modify or extend core MM tables that are simplified in S/4HANA. 2. Custom logic relies on legacy data model relationships. 3. Valuation or inventory logic is tightly coupled to ECC table structures. 4. Industry-specific enhancements were never evaluated against S4 simplification principles. The conflict is not functional alone, it is structural.
Why this is a migration-exclusive failure?
In ECC, industry solutions coexist comfortably with core modules. 1. ECC allowed industry extensions to modify physical data structures. 2. S4HANA replaces several tables with compatibility views and simplified structures. 3. Structural assumptions embedded in industry code become invalid. 4. This incompatibility surfaces only during transformation enforcement. Transformation exposes design dependencies hidden for years.
Ownership, who actually fixes it?
Although technical validation identifies the issue, remediation is architectural. 1. Process architecture-led evaluates industry process dependency and redesign requirements. 2. ABAP code remediation refactors enhancements incompatible with S4 structures. 3. Basis component validation confirms industry solution compatibility with target release. 4. Leadership approves redesign scope and timeline adjustments.
Who gets blamed versus who owns it?
When structural conflicts appear, escalation often becomes political. 1. Blamed SAP for simplifying the data model. 2. Blamed basis because readiness checks fail. 3. Actual owner historical design choices within industry extensions. 4. Root cause lack of early compatibility and impact analysis.
How this is actually fixed, the right way by a role.
Structural conflicts require controlled redesign, not quick patches. 1. Industry solution compatibility is validated against SAP's S4 roadmap. 2. Process flows are redesigned to align with simplified data structures. 3. ABAP removes or adapts obsolete enhancements tied to legacy tables. 4. Comprehensive regression testing validates valuation and inventory logic.
What not to do, common wrong fixes.
Structural conflicts cannot be resolved with cosmetic adjustments. 1. Assuming compatibility views will preserve all legacy behavior. 2. Copying ECC table logic into custom structures. 3. Postponing industry redesign until after go-live. 4. Treating structural warnings as technical anomalies. Temporary compatibility leads to permanent instability.
Follow-up 1. Why are industry solutions more vulnerable during migration?
Answer: because many industry solutions extend core data structures directly. When S4HANA simplifies or replaces those structures, the extension logic loses its foundation. What worked in ECC becomes semantically misaligned in the new architecture.
Follow-up 2. Can compatibility views solve these conflicts?
Answer: compatibility views allow legacy reads temporarily, but they do not preserve original structural semantics. Complex joins, valuation logic, and enhancements may still break. They are transitional scaffolding, not permanent solutions.
Follow-up 3. Curveball. Why do teams delay industry redesign decisions?
Answer: because industry solutions are often deeply embedded in operations. Redesigning them feels risky and expensive. However, postponing structural alignment increases long-term instability and compliance risk.
Exclusive pro tip.
If your industry solution modifies core tables, assume redesign is mandatory. S4HANA enforces simplification at the structural level.
Scenario 5. Custom enhancements referencing removed tables.
During code remediation or conversion testing, custom programs, user exits, or enhancements fail because they reference tables that no longer exist physically in S4HANA. Some tables are replaced by compatibility views, while others are completely removed. What worked silently in ECC now breaks structurally.
Scenario classification.
1. Complexity, high widespread code remediation required. 2. Phase, code remediation and pre-conversion testing. 3. Primary ownership, ABAP code remediation led. 4. Supporting process validation, basis conversion sequencing.
Why this happens, scenario analysis and root cause.
S4HANA simplifies the data model. Custom code built directly on ECC tables does not automatically adapt. 1. Physical tables such as MSEG are replaced by MATDOC or compatibility views. 2. Custom select statements assume direct table persistence. 3. Hard-coded joins depend on obsolete table relationships. 4. Enhancements were written without abstraction layers. The issue is not syntax, it is structural dependency.
Why this is a migration-exclusive failure.
In ECC, direct table access was standard practice and functioned reliably. 1. ECC allowed unrestricted direct table reads and updates. 2. S/4HANA replaces many physical tables with simplified structures. 3. Compatibility views preserve read access temporarily but not structural semantics. 4. This structural enforcement surfaces only during transformation. S/4HANA punishes tight coupling to legacy data models.
Ownership, who actually fixes it.
Although errors appear in code, remediation requires both technical and functional validation. 1. ABAP code remediation led refactors programs to use released CDS views or APIs. 2. MM process validation confirms that redesigned logic preserves business meaning. 3. Basis conversion sequencing coordinates remediation timeline with conversion freeze. 4. Leadership ensures remediation scope is formally tracked and resourced.
Who gets blamed versus who owns it.
When custom transactions stop working, tension escalates quickly. 1. Blamed ABAP because custom code fails. 2. Blamed SAP for removing tables. 3. Actual owner historical design that bypassed abstraction layers. 4. Root cause tight coupling to physical ECC table structures.
How this is actually fixed, the right way by a role.
Refactoring must align with S4 architectural principles, not replicate ECC behavior. 1. ABAP replaces direct table access with released CDS views or standard APIs. 2. Custom joins are redesigned to reflect MATDOC and simplified structures. 3. Performance validation is conducted to ensure HANA optimization. 4. Regression testing validates stock and valuation accuracy.
What not to do, common wrong fixes.
Under deadline pressure, short-term patches are common and dangerous. 1. Creating Z shadow tables to mimic removed ECC tables. 2. Copying compatibility view logic into custom structures. 3. Commenting out failing logic temporarily. 4. Skipping performance validation after refactoring. Replicating legacy structures defeats the purpose of simplification.
Follow-up 1. Why are compatibility views not a long-term solution?
Answer: compatibility views allow legacy read access but do not preserve original performance characteristics or semantic structure. They are transitional scaffolding. Long-term reliance increases performance risk and technical debt.
Follow-up 2. How can projects reduce remediation effort early?
Answer: by running custom code analysis tools before conversion and prioritizing objects based on usage frequency and business criticality. Early remediation avoids compressed timelines during freeze windows.
Follow-up 3. Curveball. Why is direct table access still common in ECC landscapes?
Answer: because it was historically efficient and flexible. Many enhancements were written before strict API governance existed. What was practical in ECC becomes architectural liability in S/4HANA.
Exclusive pro tip.
If your custom code reads physical ECC tables directly, assume remediation is mandatory. S/4HANA rewards abstraction and penalizes structural shortcuts.
Scenario 6. Data archiving not completed, conversion runtime explosion.
During conversion execution, SUM runtime extends far beyond planned downtime. Table conversion steps take exponentially longer than expected. Investigation reveals that historical MM transactional data was never archived. What was ignored as housekeeping in ECC becomes a downtime crisis in S/4HANA conversion.
Scenario classification.
1. Complexity, critical downtime, and go-live risk. 2. Phase, conversion during SUM execution. 3. Primary ownership basis, technical execution led. 4. Supporting MM data retention governance, data team archiving strategy.
Why this happens, scenario analysis and root cause.
S/4HANA conversion restructures large MM tables. Volume directly impacts runtime. 1. Transactional tables such as MKPF, MSEG, and related history tables contain years of unarchived data. 2. Conversion processes restructure or migrate these records into simplified structures. 3. Archiving was postponed repeatedly in ECC due to operational convenience. 4. Downtime estimation was based on unrealistic data volume assumptions. Conversion runtime is proportional to technical debt in data volume.
Why this is a migration-exclusive failure.
In ECC, excessive historical data rarely causes operational disruption. 1. ECC tolerated large table volumes with acceptable performance. 2. S/4HANA conversion restructures data, multiplying processing impact. 3. Table simplification requires full structural transformation of legacy records. 4. This volume-driven risk surfaces only during system conversion. Steady-state performance hides conversion time vulnerability.
Ownership, who actually fixes it.
Although runtime issues appear technical, the root cause is governance-related. 1. Basis technical execution-led monitors conversion runtime and capacity planning. 2. Data retention governance defines legal and operational archiving rules. 3. Data team archiving strategy executes structured archiving before freeze. 4. Leadership approves downtime extension or phased archiving strategy.
Who gets blamed versus who owns it.
When downtime extends unexpectedly, escalation is immediate. 1. Blamed basis because conversion is running too long. 2. Blamed infrastructure for performance limitations. 3. Actual owner, long-term data retention and archiving governance. 4. Root cause archiving discipline was deprioritized for years.
How this is actually fixed, the right way by a role.
Remediation requires structured archiving, not hardware escalation. 1. defines clear archiving criteria based on legal and business requirements. 2. Data team executes archiving cycles before production freeze. 3. Basis recalculates runtime projections based on reduced volume. 4. Mock conversions validate downtime assumptions realistically.
What not to do, common wrong fixes.
Under pressure, teams often misdiagnose runtime issues. 1. Adding hardware capacity without reducing data volume. 2. Compressing downtime windows without re-estimating runtime. 3. Ignoring archiving until after conversion. 4. Assuming HANA speed compensates for historical volume. Hardware cannot compensate for unmanaged historical growth.
Follow-up 1. Why does HANA not eliminate runtime concerns?
Answer: because conversion involves structural data transformation, not just query execution. Even on HANA, large volumes must be processed, validated, and migrated into new formats. Speed improves runtime, but volume still determines scale.
Follow-up 2. How early should archiving begin in a migration program?
Answer: archiving strategy should begin during initial assessment, not months before conversion. Early volume reduction improves testing accuracy, runtime forecasting, and infrastructure sizing. Waiting compresses risk into the final phase.
Follow-up 3. Curveball. Why do organizations delay archiving decisions?
Answer: because archiving feels operational and low priority. However, during conversion, historical data volume becomes a direct financial and scheduling risk. Deferred governance eventually translates into extended downtime.
Exclusive pro tip.
If your data volume has grown unchecked for a decade, your conversion downtime is already determined. Archiving is not housekeeping, it is risk control.
Category 1 wrap-up. Pre-checks do not guarantee safety.
Passing simplification checks does not mean your migration is safe. It only means the system is structurally eligible for conversion. Real pressure begins when SUM starts and downtime begins ticking.
Transition. The real chaos begins during conversion weekend.
Most project teams focus heavily on preparation. Few are ready for what happens during the actual conversion window. Downtime pressure, table migrations, valuation activation, and lock conflicts can derail even well-prepared programs.
Please check description or comment section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers. Required for your SAP functional modules interviews jobs like SAP MM Consultant jobs, SAP FICO Consultant jobs, SAP SD Consultant jobs. SAP PP Consultant Jobs, SAP Ariba Consultant Jobs, SAP Extended Warehouse Management EWM Consultant Jobs, SAP Plant Maintenance PM Consultant Jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving. Interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Category 1. A. Conversion window panic incidents.
These incidents occur during the technical system conversion itself. They are not post-go-live behavior changes. They are war room failures that happen while SUM is running, inventory is frozen, and the business is waiting for the system to return.
Here are the scenarios covered in conversion window panic.
1. MATDOC conversion runtime exceeds downtime window. Primary owner basis technical lead. Supporting ABAP. 2. Material ledger mandatory activation during conversion. Primary owner FI cross-module. Supporting 3. Inventory freeze window mismanaged during cutover. Primary owner cross-module. Supporting basis. 4. SUM lock conflicts on inventory tables. Primary owner basis technical lead. Supporting ABAP. 5. Migration cockpit data load fails during cutover. Primary owner data lead. Supporting 6. SPDD or SBAU removes critical enhancements mid-conversion. Primary owner ABAP technical lead. Supporting 7. Ledger realignment creates temporary valuation imbalance. Primary owner FI cross-module. Supporting
Scenario 1. MATDOC conversion runtime exceeds downtime window.
During system conversion, SUM begins migrating historical inventory data into the MATDOC structure. Initial estimates suggested acceptable downtime. However, the migration phase runs far longer than projected. Business stakeholders are waiting while the downtime window continues shrinking.
Scenario classification.
1. Complexity, critical downtime overrun risk. 2. Phase during conversion SUM execution. 3. Primary ownership basis technical lead. 4. Supporting ABAP.
Why this happens, scenario analysis and root cause.
MATDOC replaces multiple ECC inventory tables with a unified structure in S/4HANA. 1. Large historical MSEG volumes increase conversion runtime exponentially. 2. Archiving was incomplete prior to migration. 3. Custom append structures increase transformation overhead. 4. Downtime estimation was based on inaccurate volume assumptions. Volume underestimation becomes visible only when SUM executes.
Why this is a migration-exclusive failure.
ECC never required physical restructuring into MATDOC. 1. S/4HANA consolidates inventory history into a single line-item model. 2. System conversion performs physical table restructuring. 3. Downtime is directly proportional to historical volume. 4. This structural shock exists only during transformation. This risk appears only once during conversion.
Ownership, who actually fixes it.
Downtime overruns trigger immediate escalation. 1. Basis team monitors SUM phases and analyzes table conversion logs. 2. team confirms historical inventory relevance and drives archiving decisions. 3. ABAP team reviews custom append structures impacting MATDOC processing. 4. Project leadership manages downtime communication and escalation.
Who gets blamed versus who owns it.
Conversion weekend pressure amplifies tension. 1. Blamed basis because SUM appears slow. 2. Blamed infrastructure for insufficient hardware. 3. Actual owner, incomplete archiving and inaccurate volume estimation. 4. Root cause, underestimating MATDOC structural migration effort in S/4HANA.
How this is actually fixed, the right way by a role.
Sustainable mitigation requires preparation before conversion weekend. 1. Basis team executes full-scale test conversions using production-sized data copies. 2. team performs aggressive archiving of obsolete inventory history. 3. ABAP team minimizes custom append structures impacting conversion performance. 4. Architecture team validates downtime simulations before committing to S/4HANA production cutover.
What not to do, common wrong fixes.
Panic decisions during downtime worsen the situation. 1. Adding hardware mid-conversion without root cause validation. 2. Skipping sandbox full volume rehearsal. 3. Ignoring archiving recommendations to save time. 4. Blaming SUM without analyzing data footprint. Downtime risk is predictable if analyzed early.
Follow-up 1. How can teams accurately estimate MATDOC conversion runtime?
Answer: teams must execute full volume rehearsal conversions using production database copies. SUM logs provide realistic runtime indicators. Estimations based on partial data almost always underestimate conversion duration.
Follow-up 2. Does powerful HANA hardware eliminate this risk?
Answer: no. Hardware improves processing speed but does not eliminate structural transformation requirements. Table migration, indexing, and data consolidation still require significant runtime regardless of hardware strength.
Follow-up 3. Curveball. Why do executives underestimate downtime risk?
Answer: because conversion activity is invisible until it fails. Planning is often based on optimistic projections rather than realistic stress testing. Downtime overrun becomes a surprise only when pressure peaks.
Exclusive pro tip.
If your MATDOC conversion estimate feels comfortable, it is likely optimistic. Always simulate worst-case historical volume before promising downtime commitments.
Scenario 2. Material ledger mandatory activation during conversion.
During ECC to S/4HANA conversion, the project realizes that material ledger must be activated because it is mandatory in S/4HANA. In ECC, material ledger was inactive. Now, valuation logic, currencies, and inventory price history must align during the technical conversion window itself.
Scenario classification.
1. Complexity, critical valuation, and accounting risk. 2. Phase during conversion, system conversion execution. 3. Primary ownership, FI cross-module. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
Material ledger is technically optional in ECC but mandatory in S/4HANA. 1. ECC systems often operated without actual costing activation. 2. S/4HANA requires material ledger for valuation consistency. 3. Multiple currency handling must align during conversion. 4. Historical stock valuation must be reconciled before activation. What was optional in ECC becomes enforced in S/4HANA.
Why this is a migration-exclusive failure.
ECC allowed simplified valuation logic. 1. S/4HANA enforces unified valuation architecture. 2. System conversion activates material ledger structurally. 3. Valuation inconsistencies surface only during transformation. 4. Currency and ledger realignment is triggered by conversion logic. The enforcement happens only once during migration.
Ownership, who actually fixes it.
This is not a technical toggle. It is a financial architecture shift. 1. FI team validates valuation configuration and currency alignment. 2. team reviews material price control and stock valuation impact. 3. Basis team ensures proper activation sequencing during conversion. 4. Project leadership aligns financial reconciliation checkpoints.
Who gets blamed versus who owns it.
Valuation issues create immediate financial tension. 1. Blamed FI because inventory values change. 2. Blamed because material prices appear inconsistent. 3. Actual owner, incomplete material ledger preparation before conversion. 4. Root cause, underestimating mandatory valuation alignment in S/4HANA.
How this is actually fixed, the right way by a role.
Preparation before activation determines stability. 1. FI team aligns valuation areas and currency configuration before conversion. 2. MM team cleans material price control inconsistencies and stock anomalies. 3. Basis team executes activation in controlled test cycles before production. 4. Architecture team validates reconciliation between MM and FI prior to go live.
What not to do, common wrong fixes.
Rushed activation creates long-term accounting instability. 1. Activating material ledger without full reconciliation testing. 2. Ignoring currency misalignment during migration. 3. Assuming price differences will stabilize automatically post-go live. 4. Treating material ledger activation as a technical checkbox. Valuation misalignment compounds over time.
Follow-up 1. Why is material ledger mandatory in S/4HANA?
Answer: S/4HANA relies on unified valuation logic to ensure consistency across currencies and ledgers. Material ledger enables actual costing and multiple valuation views, which are embedded into the new architecture.
Follow-up 2. Can projects postpone material ledger activation?
Answer: no. In S/4HANA, material ledger is technically mandatory. The question is not whether to activate it, but whether it is properly prepared before system conversion.
Follow-up 3. Curveball. Why do valuation issues often appear months after conversion?
Answer: because actual costing cycles and currency effects accumulate over time. Misalignment during activation may not surface immediately, but becomes visible during financial closing cycles.
Exclusive pro tip.
Material ledger activation is not a configuration step. It is a financial architecture decision that must be validated before conversion weekend begins.
Scenario 3. Inventory freeze window mismanaged during cutover.
During conversion weekend, the business agrees to freeze inventory movements to protect data consistency. However, communication gaps and operational pressure cause movements to continue in satellite systems. When S/4HANA goes live, stock balances no longer match expectations.
Scenario classification.
1. Complexity, high operational and financial misalignment. 2. Phase during conversion cutover execution. 3. Primary ownership MM cross-module. 4. Supporting basis.
Why this happens, scenario analysis and root cause.
Inventory freeze requires strict operational discipline. 1. Business users continue goods movements in external or decentralized systems. 2. Interfaces are not fully paused before technical conversion begins. 3. Communication about freeze timing is unclear across regions. 4. Reconciliation checkpoints are not formally defined. Cutover discipline failure creates post-go-live imbalance.
Why this is a migration-exclusive failure.
Daily operations rarely require full system freeze. 1. Conversion demands a synchronized inventory stop. 2. Legacy satellite systems may not align with freeze timing. 3. Data extracted for conversion becomes outdated within hours. 4. This coordination risk exists only during transformation. Steady-state operations do not require global inventory lockdown.
Ownership, who actually fixes it.
Operational failures surface as financial discrepancies. 1. MM team defines freeze governance and validates stock reconciliation. 2. Basis team ensures interfaces and background jobs are technically paused. 3. Integration team confirms no inbound or outbound movements occur during freeze. 4. Project leadership enforces regional communication discipline.
Who gets blamed versus who owns it.
When stock mismatches appear, tension escalates quickly. 1. Blamed IT for incorrect migration. 2. Blamed basis for data extraction timing. 3. Actual owner, weak operational freeze governance. 4. Root cause, incomplete cross-system synchronization during cutover.
How this is actually fixed. The right way by a role.
Prevention requires governance, not heroics. 1. MM team establishes documented freeze start and end checkpoints. 2. Basis team implements hard interface locks during conversion window. 3. Integration team validates inbound queues are fully cleared before data extraction. 4. PMO team conducts final reconciliation sign-off before releasing S/4HANA.
What not to do, common wrong fixes.
Quick corrections worsen audit risk. 1. Posting manual stock adjustments without root cause validation. 2. Ignoring minor mismatches assuming they will balance later. 3. Reopening interfaces prematurely to resume operations. 4. Skipping formal reconciliation sign-off. Uncontrolled adjustments compound financial discrepancies.
Follow-up 1. Why do freeze violations often go unnoticed until after go live?
Answer: because freeze violations may occur in decentralized systems or external interfaces that are not centrally monitored. The imbalance becomes visible only when reconciliation compares legacy extraction data with live S/4HANA stock.
Follow-up 2. Can technical locks alone prevent freeze violations?
Answer: no. Technical controls help, but operational discipline is equally critical. Without clear communication and accountability, users may find alternative ways to process movements.
Follow-up 3. Curveball. Why is freeze governance more critical in global organizations?
Answer: because time zones, regional warehouses, and third-party logistics partners operate independently. Coordinating a synchronized freeze across regions multiplies communication complexity.
Exclusive pro tip.
The most dangerous inventory imbalance is the one created during conversion weekend. Freeze governance must be treated as a financial control, not just an operational pause.
Scenario 4. SUM lock conflicts on inventory tables.
During system conversion, SUM attempts to process core inventory tables while background jobs or user sessions still hold locks. Conversion phases stall unexpectedly. Downtime extends as lock conflicts prevent structural migration steps from completing.
Scenario classification.
1. Complexity, high technical downtime escalation. 2. Phase during conversion, SUM execution. 3. Primary ownership basis, technical lead. 4. Supporting ABAP MM.
Why this happens, scenario analysis and root cause.
System conversion assumes full technical control of the system. 1. Background jobs were not fully canceled before downtime. 2. Custom programs left open database locks. 3. Interfaces were not fully stopped prior to SUM execution. 4. Long-running update tasks were still active during conversion start. Even a single open lock can halt structural migration.
Why this is a migration-exclusive failure.
Daily operations tolerate short-lived locks. 1. SUM requires exclusive access to core tables. 2. Structural table changes cannot proceed under lock. 3. Conversion phases enforce strict table control. 4. This requirement exists only during transformation downtime. Steady-state systems rarely demand full table exclusivity.
Ownership, who actually fixes it.
Lock conflicts are technical symptoms of preparation gaps. 1. Basis team monitors lock entries and enforces full user shutdown. 2. ABAP team identifies custom programs holding persistent locks. 3. MM team confirms no operational sessions remain active. 4. Project leadership ensures downtime checklist compliance.
Who gets blamed versus who owns it.
Downtime stress amplifies finger pointing. 1. Blamed basis because conversion appears stuck. 2. Blamed SAP for SUM instability. 3. Actual owner incomplete pre-downtime shutdown validation. 4. Root cause weak cutover execution discipline.
How this is actually fixed, the right way by a role.
Prevention is procedural, not reactive. 1. Basis team implements strict downtime lock validation before SUM start. 2. ABAP team reviews and disables custom background jobs pre-conversion. 3. MM team confirms operational users are fully logged off. 4. Cutover team executes final lock audit before technical phase initiation.
What not to do, common wrong fixes.
Shortcuts increase downtime risk. 1. Forcefully deleting lock entries without root cause review. 2. Restarting SUM without confirming lock resolution. 3. Allowing background jobs to continue during downtime. 4. Ignoring lock warnings assuming they will clear automatically. Reactive lock deletion may corrupt migration integrity.
Follow-up 1. Why can a single lock delay an entire conversion phase?
Answer: because SUM performs structural table modifications that require exclusive access. Even one open transaction can block schema updates, forcing the conversion to pause until the lock is cleared.
Follow-up 2. How can teams proactively prevent lock conflicts?
Answer: by executing a strict cutover checklist that includes job cancellation, interface shutdown, and final lock monitoring before SUM start. Technical discipline during the final hour is critical.
Follow-up 3, curveball. Why do lock issues escalate in highly customized systems?
Answer: because custom programs often include long-running update logic or manual commits. These design patterns increase the probability of persistent locks during conversion.
Exclusive pro tip.
Before starting SUM, treat lock validation as a formal go or no-go checkpoint. Downtime failures are rarely caused by SAP. They are caused by preparation gaps.
Scenario 5. Migration cockpit data load fails during cut.
During conversion weekend, legacy data that was planned to be loaded using the migration cockpit fails validation in S/4HANA. Error logs show inconsistent master data, missing mandatory fields, or valuation mismatches. Downtime pressure increases as data load retries begin.
Scenario classification.
1. Complexity high data integrity risk. 2. Phase during conversion cutover data load. 3. Primary ownership data-led. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
Migration cockpit enforces S/4HANA validation logic strictly. 1. Legacy ECC data contained inconsistencies tolerated in daily operations. 2. Mandatory fields in S/4HANA were not populated in legacy records. 3. Test loads were performed with incomplete data samples. 4. Data reconciliation was not finalized before conversion freeze. S/4HANA rejects what ECC silently accepted.
Why this is a migration-exclusive failure.
Daily ECC processing often masks structural data issues. 1. S/4HANA enforces stricter master and transactional validation. 2. Conversion window forces immediate data correctness. 3. No manual workaround exists during structured migration load. 4. This validation shock appears only during transformation. Legacy inconsistencies surface under enforced architecture.
Ownership, who actually fixes it.
Data load failures are governance failures, not tool failures. 1. Data team validates and cleans legacy datasets before final load. 2. MM team reviews business rule compliance for mandatory fields. 3. Basis team monitors load performance and error logs. 4. Project leadership controls cutover retry decisions under downtime pressure.
Who gets blamed versus who owns it.
Cutover stress amplifies escalation. 1. Blamed migration cockpit because load fails. 2. Blamed SAP for strict validation. 3. Actual owner incomplete legacy data cleansing. 4. Root cause weak pre-conversion data governance.
How this is actually fixed, the right way by a role.
Resolution requires preemptive data discipline. 1. Data team conducts full-volume mock migrations before production cutover. 2. MM team validates mandatory field completeness and business rule alignment. 3. ABAP team develops data validation utilities to detect inconsistencies early. 4. Cutover team defines go or no-go criteria based on load success thresholds.
What not to do, common wrong fixes.
Panic-driven reload attempts increase downtime risk. 1. Retrying failed loads without root cause correction. 2. Manually adjusting production data during downtime. 3. Ignoring error logs to save time. 4. Skipping reconciliation before opening the system. Unvalidated reloads compound systemic data corruption.
Follow-up 1. Why do migration cockpit errors appear only during final load?
Answer: because final loads use complete production datasets. Earlier testing often uses smaller or cleaned samples. Production-level data exposes edge case inconsistencies that were never validated during sandbox cycles.
Follow-up 2. Can validation rules be relaxed to speed up migration?
Answer: relaxing validation compromises data integrity in S/4HANA. While temporary workarounds may seem helpful under pressure, they create long-term reconciliation and audit risks.
Follow-up 3. Curveball. Why do experienced teams still face cut-over data failures?
Answer: because organizational data ownership is often fragmented. Without a single accountable data governance structure, inconsistencies accumulate quietly until the final enforced validation stage.
Exclusive pro tip.
Never trust a successful sample migration. Only full-volume rehearsal loads validate real cut-over readiness in S/4HANA.
Scenario 6. SPDD or SBAU removes critical MM enhancements mid-conversion.
During the technical conversion phase, SPDD and SBAU adjustment activities identify conflicts between SAP standard changes and custom MM enhancements. In the rush to complete the upgrade, certain custom logic is reset or overwritten. After go-live, core procurement or inventory processes behave unexpectedly.
Scenario classification.
1. Complexity, high functional regression risk. 2. Phase during conversion, SPDD and SBAU adjustment. 3. Primary ownership, ABAP technical lead. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
System conversion replaces or modifies core SAP objects. 1. Custom enhancements were embedded in standard SAP objects. 2. SPDD or SBAU adjustments were rushed due to downtime pressure. 3. Functional review of impacted enhancements was incomplete. 4. Regression testing focused on technical completion, not behavioral validation. Technical adjustment without functional validation creates silent regression.
Why this is a migration-exclusive failure.
SPDD and SBAU are triggered specifically by system upgrades. 1. S/4HANA introduces structural changes to core MM objects. 2. Custom code conflicts surface only during upgrade reconciliation. 3. Enhancement logic may be overwritten if not properly merged. 4. This risk exists only during technical transformation. Steady-state systems do not trigger large-scale object adjustment.
Ownership, who actually fixes it.
Regression is a joint technical and functional responsibility. 1. ABAP team reviews all SPDD and SBAU objects and merges custom logic carefully. 2. MM team validates business process impact of each adjusted object. 3. QA team executes full regression scenarios before production release. 4. Project leadership enforces dual sign-off on adjusted objects.
Who gets blamed versus who owns it.
Unexpected functional behavior triggers political tension. 1. Blamed SAP for changing standard objects. 2. Blamed ABAP for missing code merge logic. 3. Actual owner incomplete SPDD or SBAU functional review process. 4. Root cause treating upgrade adjustments as purely technical work.
How this is actually fixed, the right way by a role.
Adjustment requires structured governance. 1. ABAP team documents all impacted objects and performs structured merge comparisons. 2. MM team reviews each enhancement against new S/4HANA standard behavior. 3. QA team executes scenario-based regression for procurement and inventory flows. 4. Architecture team defines future extensibility strategy using clean core principles.
What not to do, common wrong fixes.
Speed-focused adjustments create post-go-live instability. 1. Accepting SAP standard blindly without functional validation. 2. Reapplying old code without analyzing S/4HANA behavioral changes. 3. Skipping regression testing due to downtime fatigue. 4. Postponing enhancement validation until after go-live. Quick merges create long-term behavioral drift.
Follow-up 1. Why are SPDD and SBAU risks underestimated in MM projects?
Answer: because they are often treated as purely technical activities. However, many custom enhancements embed business logic directly into standard objects, making functional validation critical.
Follow-up 2. How can teams reduce enhancement regression risk?
Answer: by inventorying all custom objects early and mapping them to affected SAP objects before conversion. Structured code comparison and mandatory functional sign-off reduce post-migration surprises.
Follow-up 3. Curveball. Why do some regressions appear weeks after go-live?
Answer: because certain enhancement logic triggers only under specific operational scenarios. If regression testing does not cover edge case transactions, behavioral drift may remain hidden initially.
Exclusive pro tip.
Every SPDD or SBAU object should have dual ownership, technical merge by ABAP, and functional validation by MM. Clean core discipline starts during upgrade adjustment.
Scenario 7. Ledger realignment creates temporary valuation imbalance.
During conversion to S/4HANA, ledger structures are realigned to support parallel valuation and universal journal architecture. Immediately after activation, inventory values and accounting balances show temporary inconsistencies. Finance teams panic as reports appear misaligned.
Scenario classification.
1. Complexity, critical financial reporting risk. 2. Phase during conversion, ledger realignment. 3. Primary ownership, FI cross-module. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
S/4HANA introduces the Universal Journal with harmonized ledger architecture. 1. Parallel valuation is activated or realigned during migration. 2. Historical postings require reconciliation to new ledger structure. 3. Currency types and valuation views shift under new configuration. 4. Temporary balances appear before full reconciliation completes. Structural ledger alignment may momentarily distort reporting.
Why this is a migration-exclusive failure.
ECC did not enforce Universal Journal harmonization. 1. S/4HANA consolidates accounting data into a unified structure. 2. Ledger realignment occurs during technical conversion. 3. Valuation views are recalculated under new architecture. 4. This temporary imbalance occurs only during transformation. Steady-state operations do not trigger structural ledger shifts.
Ownership, who actually fixes it.
Financial imbalance requires structured reconciliation. 1. FI team validates ledger configuration and reconciliation logic. 2. MM team confirms inventory valuation consistency across valuation areas. 3. Basis team ensures conversion phases complete without technical interruption. 4. Finance leadership approves reconciliation sign-off before system release.
Who gets blamed versus who owns it.
Reporting misalignment creates immediate concern. 1. Blamed S/4HANA for altering accounting logic. 2. Blamed MM for incorrect inventory values. 3. Actual owner, ledger realignment executed without complete reconciliation planning. 4. Root cause, underestimating Universal Journal transition complexity.
How this is actually fixed, the right way by a role.
Resolution depends on structured financial validation. 1. FI team executes detailed ledger-to-ledger reconciliation before go live. 2. MM team validates material valuation and price differences post-alignment. 3. ABAP team supports reconciliation reporting utilities where required. 4. Architecture team defines validation checkpoints for future transformations.
What not to do, common wrong fixes.
Reactive accounting adjustments create audit risk. 1. Posting manual adjustment entries without reconciliation proof. 2. Ignoring temporary imbalances assuming they will correct automatically. 3. Opening the system to users before reconciliation completion. 4. Blaming Universal Journal without validating configuration. Premature corrections create deeper financial inconsistencies.
Follow-up 1. Why do valuation imbalances appear immediately after conversion?
Answer: because the Universal Journal consolidates previously separated accounting views. Initial reconciliation recalculates balances under new ledger rules, which may temporarily display differences until alignment is finalized.
Follow-up 2. Are temporary valuation differences normal during migration?
Answer: short-term reporting shifts may occur during ledger realignment, but they must be fully reconciled before go-live sign-off. Unreconciled differences represent structural configuration gaps.
Follow-up 3. Curveball. Why is Universal Journal transition often underestimated?
Answer: because it appears as a technical data consolidation. In reality, it reshapes how valuation and currency logic operate across modules, requiring deep financial validation.
Exclusive pro tip.
Universal Journal alignment is not just a technical migration task. Treat ledger reconciliation as a formal financial audit checkpoint before declaring S/4HANA ready.
Category 1. A wrap-up. The conversion window is where architecture is tested.
Pre-checks prepare you, but conversion weekend exposes you. Downtime overruns, valuation misalignment, lock conflicts, and data load failures do not appear randomly. They surface when preparation meets real structural enforcement in S/4HANA.
Transition from conversion panic to structural simplification shock.
Once the system is technically converted, a new category of problems begins. The system is up, users log in, transactions run, but underneath, the data model has changed fundamentally. What worked in ECC no longer behaves the same way in S/4HANA.
Category 1 wrap-up. Structural debt surfaces first.
Pre-conversion failures are not random blockers. They are structural audits of your ECC landscape. Simplification checks, add-on incompatibilities, custom table dependencies, and unarchived data all expose architectural shortcuts that accumulated over years. S/4HANA does not introduce these problems, it reveals them.
Transition from structural cleanup to data model shock.
Once the system passes structural readiness, the next shock appears inside the data model itself. The replacement of MKPF and MSEG with MATDOC is not a cosmetic change. It fundamentally alters how inventory data is stored, accessed, and interpreted. This is where many technical assumptions collapse.
Category 2. MATDOC simplification.
S/4HANA replaces the traditional inventory document structure with a single line-item table called MATDOC. While compatibility views exist, the physical persistence layer has changed completely. Custom reports, direct table reads, and performance assumptions built on MKPF and MSEG often break silently under this new model.
Scenarios covered in Category 2.
1. MSEG disappears primary owner, ABAP technical lead, supporting MM2. MKPF and MSEG join produces duplicate records primary owner, ABAP technical lead, supporting MM3. MATDOC volume causes performance panic primary owner basis technical lead, supporting ABAP. 4. Legacy select all slows inventory reporting primary owner, ABAP technical lead, supporting basis. 5. Direct table updates fail after migration primary owner, ABAP technical lead, supporting MM.
Scenario 7. MSEG disappears, custom reports fail.
After conversion to S/4HANA, custom reports and enhancements that directly read table MSEG begin failing or returning unexpected results. While compatibility views may allow limited reads, the physical persistence of inventory data has shifted to MATDOC. What appears to be a missing table issue is actually a data model transformation shock.
Scenario classification.
1. Complexity, high widespread code refactoring. 2. Phase code remediation and post-conversion testing. 3. Primary ownership, ABAP technical lead. 4. Supporting MM process validation.
Why this happens, scenario analysis and root cause.
MSEG does not vanish entirely, but its role changes fundamentally in S/4HANA. 1. MSEG is no longer the primary physical persistence table for inventory documents. 2. MATDOC consolidates line-item inventory storage into a simplified structure. 3. Custom programs assume physical persistence and direct table relationships. 4. Compatibility views cannot fully replicate legacy structural behavior. The failure is not missing data, it is misplaced assumptions.
Why this is a migration-exclusive failure.
In ECC, direct MSEG reads were technically correct and performant. 1. ECC stored inventory line items physically in MSEG. 2. S/4HANA consolidates and simplifies inventory persistence. 3. Legacy select statements rely on obsolete physical storage logic. 4. This structural shift occurs only during transformation. S/4HANA enforces abstraction over physical table dependency.
Ownership, who actually fixes it.
Although errors surface in custom programs, remediation requires semantic validation. 1. ABAP technical lead refactors programs to use released CDS views or MATDOC-aligned access. 2. MM process validation confirms inventory quantities and valuation logic remain accurate. 3. Performance testing team validates HANA-optimized execution. 4. Leadership ensures code remediation is prioritized before go-live.
Who gets blamed versus who owns it.
When reports fail after go-live, accountability conversations begin quickly. 1. Blamed ABAP because custom code fails. 2. Blamed SAP for removing MSEG. 3. Actual owner, legacy design tightly coupled to physical table storage. 4. Root cause, no abstraction layer between business logic and persistence.
How this is actually fixed, the right way by a role.
Refactoring must embrace S/4 architectural principles rather than emulate ECC. 1. ABAP replaces direct MSEG access with released CDS views or MATDOC-based structures. 2. Joins are redesigned to reflect simplified data relationships. 3. Inventory and valuation reconciliation is performed after refactoring. 4. Performance tests validate HANA optimization benefits.
What not to do, common wrong fixes.
Shortcuts here introduce long-term technical instability. 1. Creating Z-shadow tables to replicate MSEG physically. 2. Copying compatibility view logic into custom storage. 3. Ignoring performance testing after refactoring. 4. Assuming MATDOC volume automatically guarantees performance. Rebuilding legacy persistence defeats simplification goals.
Follow-up 1. Why does compatibility view access sometimes still work?
Answer: compatibility views simulate legacy structures to support transition. However, they do not replicate original physical storage behavior or performance characteristics. Complex joins or update logic may still break or degrade under heavy load.
Follow-up 2. How can projects proactively detect MSEG dependencies?
Answer: by running custom code analysis tools focused on direct table access patterns. Prioritizing high-usage programs and valuation-related logic helps prevent post-conversion surprises. Early scanning reduces compressed remediation windows.
Follow-up 3. Curveball. Why do some reports appear correct but totals are wrong?
Answer: because compatibility views may return data with altered semantics. Legacy joins may duplicate or omit certain dimensions under MATDOC. What looks numerically similar may differ structurally in financial meaning.
Exclusive pro tip.
If your custom logic depends on physical table persistence, treat S/4HANA as a data model redesign, not a database upgrade.
Scenario 8. MKPF and MSEG join produces duplicate records.
After migration to S/4HANA, custom reports that join MKPF and MSEG begin returning duplicate inventory records or inflated totals. The program executes without syntax errors, but reconciliation fails. What worked reliably in ECC now produces structurally incorrect results under the MATDOC model.
Scenario classification.
1. Complexity, high semantic and reporting risk. 2. Phase, post-conversion testing and reporting validation. 3. Primary ownership, ABAP technical lead. 4. Supporting data validation.
Why this happens, scenario analysis and root cause.
Join logic itself is not broken. The data model underneath it has changed. 1. MKPF and MSEG no longer represent the physical header and item relationship as in ECC. 2. MATDOC consolidates inventory line items into a unified structure. 3. Compatibility views simulate legacy behavior but introduce semantic shifts. 4. Legacy join assumptions no longer match simplified persistence logic. The join is syntactically correct, but semantically outdated.
Why this is a migration-exclusive failure.
In ECC, MKPF and MSEG maintained a stable physical relationship. 1. ECC stored header data in MKPF and line items in MSEG physically. 2. S/4HANA stores line items primarily in MATDOC. 3. Compatibility layers introduce derived relationships rather than physical ones. 4. This semantic drift surfaces only after transformation. Transformation preserves access but alters meaning.
Ownership, who actually fixes it.
Although duplication appears technical, validation must be cross-functional. 1. ABAP technical lead redesigns join logic using MATDOC-aligned CDS views. 2. data validation confirms correct stock and valuation totals. 3. Reporting team revalidates dependent dashboards and analytics. 4. Leadership ensures reporting corrections are prioritized before financial close.
Who gets blamed versus who owns it.
When totals inflate unexpectedly, accountability discussions escalate quickly. 1. Blamed ABAP because the report shows duplicates. 2. Blamed SAP for changing the data model. 3. Actual owner legacy join assumptions built on physical table logic. 4. Root cause failure to realign reporting logic with simplified persistence.
How this is actually fixed, the right way by a role.
Fixing duplication requires semantic redesign, not additional filters. 1. ABAP replaces MKPF and MSEG joins with MATDOC-based CDS views. 2. Header information is derived through proper associations rather than legacy joins. 3. Inventory and valuation reconciliation is performed before sign-off. 4. Performance optimization is validated on HANA.
What not to do, common wrong fixes.
Filtering duplicates without understanding semantics creates hidden risk. 1. Adding distinct clauses to hide duplication. 2. Applying manual aggregation to force totals. 3. Copying compatibility view logic into custom tables. 4. Ignoring reconciliation differences during testing. Suppressing duplicates does not correct semantic misalignment.
Follow-up 1. Why does duplication appear only in certain documents?
Answer: documents with additional dimensions such as valuation splits or ledger variations generate multiple line entries in MATDOC. Legacy join logic interprets these as duplicates instead of distinct semantic records, causing inflated totals.
Follow-up 2. How can duplication be detected early?
Answer: by reconciling document counts and inventory totals between ECC baseline and S4 results. Comparing MATDOC-based queries against legacy join outputs highlights structural mismatches before go live.
Follow-up 3. Curveball. Why do some projects not notice duplication until audit?
Answer: because operational testing often focuses on transaction success rather than aggregate reconciliation. Period-end financial validation exposes mismatches that daily operational checks miss.
Exclusive pro tip.
If your reporting logic depends on physical header and item joins, assume semantic redesign is mandatory in S4 HANA.
Scenario 9. MATDOC volume causes performance panic.
After conversion, technical teams observe that MATDOC contains an extremely large number of records. Reports that previously ran quickly now appear slower, and system monitoring shows heavy table access. Panic spreads that S4 HANA is underperforming despite running on HANA. In reality, the issue is often design, not database speed.
Scenario classification.
1. Complexity, medium to high performance and perception risk. 2. Phase, post-conversion stabilization. 3. Primary ownership basis technical lead. 4. Supporting ABAP query optimization.
Why this happens, scenario analysis and root cause.
MATDOC consolidates what were previously multiple tables into one unified structure. 1. MATDOC stores all inventory line items in a single high-volume table. 2. Custom reports use broad selection criteria without proper filtering. 3. Legacy select logic was written for smaller distributed tables. 4. HANA optimization principles are not applied in custom programs. Volume is not the problem. Unoptimized access is.
Why this is a migration-exclusive failure.
In ECC, data was distributed across multiple physical tables. 1. ECC separated header and item storage physically. 2. S4 HANA consolidates persistence into MATDOC. 3. Legacy performance assumptions do not apply under simplified architecture. 4. Performance perception issues surface only after structural consolidation. Simplification centralizes volume and exposes inefficient design.
Ownership, who actually fixes it.
Although performance complaints target infrastructure, optimization is architectural. 1. Basis technical lead monitors database load and validates HANA configuration. 2. ABAP query optimization refactors inefficient select logic and adds proper filters. 3. MM usage review defines realistic reporting scope and selection criteria. 4. Performance team executes SQL trace and workload analysis.
Who gets blamed versus who owns it.
When performance slows, hardware is often the first suspect. 1. Blamed infrastructure for insufficient sizing. 2. Blamed HANA for underperforming. 3. Actual owner inefficient legacy select logic. 4. Root cause code written without HANA-aware optimization principles.
How this is actually fixed, the right way by a role.
Performance stabilization requires structured optimization, not panic scaling. 1. ABAP rewrites queries using proper key fields and selective filters. 2. CDS views with appropriate associations replace legacy table reads. 3. Database indexes and HANA performance tools are validated. 4. Load testing confirms stabilization under realistic usage.
What not to do, common wrong fixes.
Scaling hardware without analyzing code hides the real issue. 1. Adding memory without optimizing queries. 2. Running full table scans in production reports. 3. Disabling performance checks to speed up execution temporarily. 4. Assuming HANA automatically compensates for poor query design. Hardware upgrades cannot compensate for inefficient logic.
Follow-up 1. Why does MATDOC look overwhelmingly large after migration?
Answer: because it consolidates historical and current inventory data into a single persistence layer. What was previously distributed across multiple tables is now centralized. The perceived growth is structural visibility, not uncontrolled expansion.
Follow-up 2. How can teams proactively prevent MATDOC performance issues?
Answer: by enforcing HANA-optimized coding standards before conversion and running SQL trace analysis during testing. High-volume reports should be redesigned using CDS views and filtered selections rather than legacy open-ended queries.
Follow-up 3. Curveball. Why does performance panic spread quickly in S4 projects?
Answer: because expectations of HANA speed are extremely high. When reports slow down, teams assume platform failure. In reality, most performance issues originate from design assumptions carried forward from ECC.
Exclusive pro tip.
If MATDOC performance is slow, review your select logic before reviewing your hardware budget.
Scenario 10. Legacy select all slows inventory reporting.
After migration, inventory reports that previously performed acceptably begin consuming excessive runtime and database resources. Investigation reveals widespread use of select all field patterns without restrictive conditions. In S/4HANA's consolidated MATDOC structure, this legacy habit becomes a performance liability.
Scenario classification.
1. Complexity, medium to high performance degradation risk. 2. Phase, post-conversion stabilization and optimization. 3. Primary ownership, ABAP technical lead. 4. Supporting basis performance monitoring.
Why this happens, scenario analysis and root cause.
Select all was convenient in ECC, but consolidation amplifies its cost in S/4HANA. 1. Legacy programs retrieve all columns instead of required fields. 2. MATDOC contains significantly more dimensions than legacy tables. 3. Broad selections trigger full table scans under high volume. 4. Old performance assumptions ignored HANA-specific optimization practices. Convenience coding becomes expensive at scale.
Why this is a migration-exclusive failure.
In ECC, distributed tables reduce the visible impact of inefficient selections. 1. ECC separated header and item storage physically. 2. S/4HANA centralizes inventory persistence in MATDOC. 3. Selecting unnecessary fields increases memory and processing load dramatically. 4. This amplification effect appears only after structural consolidation. Simplification magnifies inefficient design patterns.
Ownership, who actually fixes it.
Although performance complaints surface at infrastructure level, correction is coding discipline. 1. ABAP technical lead, refactors select logic to retrieve only necessary fields. 2. Basis performance monitoring, analyzes workload through SQL trace and runtime metrics. 3. functional scope validation, defines minimal data requirements for reporting. 4. Performance team validates improvement through controlled load testing.
Who gets blamed versus who owns it.
When reports slow down, hardware often becomes the first suspect. 1. Blamed HANA assumed underperformance. 2. Blamed infrastructure for insufficient sizing. 3. Actual owner legacy select patterns written without volume awareness. 4. Root cause, lack of HANA-oriented coding standards.
How this is actually fixed, the right way by a role.
Optimization requires discipline, not reactive scaling. 1. ABAP replaces select all with selective field retrieval. 2. Proper key-based filtering is enforced in where conditions. 3. CDS views with performance annotations are implemented where applicable. 4. Performance benchmarks confirm runtime stabilization.
What not to do, common wrong fixes.
Quick scaling solutions mask inefficient logic. 1. Increasing hardware resources without refactoring code. 2. Adding temporary buffering layers. 3. Ignoring SQL trace analysis findings. 4. Assuming HANA automatically optimizes inefficient patterns. Performance is engineered, not purchased.
Follow-up 1. Why does select all hurt more in S/4HANA?
Answer: because MATDOC centralizes and expands the data structure. Retrieving unnecessary columns increases memory consumption and CPU processing under high volume. What was negligible in ECC becomes measurable in S/4HANA.
Follow-up 2. How can coding standards prevent this issue?
Answer: by enforcing strict field-level selection, peer code reviews, and HANA-specific performance guidelines. Automated code analysis tools can flag broad selection patterns before they reach production.
Follow-up 3. Curveball. Why do experienced developers still use Select All?
Answer: because it simplifies development and reduces perceived maintenance effort. However, under consolidated high-volume tables, this convenience introduces measurable runtime cost and scalability limitations.
Exclusive pro tip.
If you see Select All in a MATDOC-based report, treat it as a performance risk, not a coding style preference.
Scenario 11. Direct table updates fail after migration.
After conversion to S/4HANA, certain custom programs that previously performed direct updates on inventory tables begin failing or producing inconsistent data. Update statements that worked in ECC are now blocked or ignored. What was once a shortcut now violates S/4HANA's architectural enforcement principles.
Scenario classification.
1. Complexity, high data integrity and compliance risk. 2. Phase, post-conversion testing and stabilization. 3. Primary ownership, ABAP technical lead. 4. Supporting MM process integrity validation.
Why this happens, scenario analysis and root cause.
S/4HANA enforces strict data consistency rules that ECC did not. 1. Legacy programs perform direct updates on inventory-related tables. 2. S/4HANA centralizes persistence and enforces update logic through application layers. 3. Direct updates bypass validation and business rule enforcement. 4. Compatibility views do not support update semantics. Shortcuts tolerated in ECC are structurally blocked in S/4HANA.
Why this is a migration-exclusive failure.
Direct table manipulation was technically possible in ECC. 1. ECC allowed updates on certain physical tables without strict API enforcement. 2. S/4HANA consolidates inventory logic into controlled persistence layers. 3. Application-level validations prevent direct manipulation of core tables. 4. This enforcement appears only after architectural simplification. S/4HANA replaces technical flexibility with integrity enforcement.
Ownership, who actually fixes it.
Although update failures appear technical, correction requires functional validation. 1. ABAP technical lead replaces direct updates with released APIs or BAPI calls. 2. MM process integrity validation confirms correct inventory and valuation behavior. 3. Audit team validates compliance with data governance standards. 4. Leadership ensures architectural compliance becomes a coding standard.
Who gets blamed versus who owns it.
When data inconsistencies appear, reactions are immediate. 1. Blamed ABAP because custom logic fails. 2. Blamed SAP for restricting table updates. 3. Actual owner historical shortcuts that bypass standard APIs. 4. Root cause weak governance over direct table manipulation.
How this is actually fixed, the right way by a role.
Correction requires architectural compliance, not workarounds. 1. ABAP replaces direct update statements with standard APIs or BAPI. 2. Business logic validations are executed through supported application layers. 3. Regression testing confirms inventory and accounting accuracy. 4. Coding standards are updated to prohibit direct persistence manipulation.
What not to do, common wrong fixes.
Workarounds here introduce audit and compliance exposure. 1. Creating custom shadow tables to simulate updates. 2. Disabling validation checks temporarily. 3. Using database-level scripts to force updates. 4. Skipping reconciliation after refactoring. Data integrity violations surface during audits, not during testing.
Follow-up 1. Why does S/4HANA block direct table updates?
Answer: because S/4HANA centralizes business rules and validation logic within application layers. Direct table updates bypass these validations and risk corrupting financial and inventory consistency. Architectural enforcement replaces technical flexibility.
Follow-up 2. Are there any scenarios where direct updates are acceptable?
Answer: in production landscapes, direct updates to core tables are strongly discouraged and often technically restricted. Supported APIs and BAPI ensure that validation logic and integration dependencies are respected.
Follow-up 3, curveball. Why do some legacy systems still depend on direct updates?
Answer: because they were designed during periods when rapid customization was prioritized over governance. Over time, these shortcuts became embedded into operations, creating hidden structural risk during transformation.
Exclusive pro tip.
If your solution requires direct table updates to function, redesign it. S/4HANA is engineered to enforce application layer integrity.
Category 2 wrap-up. Simplification is structural, not cosmetic.
MATDOC simplification is not just a database redesign. It rewrites how inventory persistence works. Projects that treat it as a table rename exercise suffer reporting drift, performance panic, and architectural instability. S/4HANA rewards abstraction and punishes physical table dependency.
Transition from data model simplification to valuation shock.
If MATDOC restructures quantity persistence, Material Ledger restructures value persistence. In S/4HANA, Material Ledger is mandatory. That single fact changes pricing logic, currency handling, valuation behavior, and FI reconciliation across the entire enterprise.
Please check description or comment section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP functional modules interviews jobs like SAP MM Consultant jobs, SAP FICO Consultant jobs, SAP SD Consultant jobs, SAP PP Consultant jobs, SAP Ariba Consultant jobs, SAP Extended Warehouse Management EWM Consultant jobs, SAP Plant Maintenance PM Consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Category 3, Material Ledger, mandatory in S/4HANA.
Material Ledger is no longer optional in S/4HANA. Even if actual costing is not used actively, valuation logic changes fundamentally. Price differences, currency types, and reconciliation behavior shift in ways that impact both MM and FI. Most projects underestimate this category until financial discrepancies appear.
Scenarios covered in Category 3.
Scenario 12, Material Ledger not active in ECC conversion complexity. Primary owner, FI cross-module, supporting MM. Scenario 13, price difference logic behaves differently. Primary owner, FI cross-module, supporting MM. Scenario 14, standard price versus moving average confusion. Primary owner, MM led, supporting FI. Scenario 15, inventory value does not match FI after migration. Primary owner, FI cross-module, supporting MM. Scenario 16, actual costing activated without understanding impact. Primary owner, FI cross-module, supporting MM and company. Scenario 17, subcontracting valuation behaves differently under Material Ledger. Primary owner, MM cross-module, supporting FI.
Scenario 12, Material Ledger not active in ECC conversion complexity.
During preparation for S/4HANA conversion, the project discovers that Material Ledger was never activated in ECC. Since Material Ledger is mandatory in S/4HANA, activation must occur during migration. What appears to be a technical activation step quickly evolves into a cross-module valuation redesign exercise.
Scenario classification.
1. Complexity, critical financial valuation impact. 2. Phase, pre-conversion and data migration. 3. Primary ownership, FI cross-module. 4. Supporting MM valuation alignment.
Why this happens, scenario analysis and root cause.
Material ledger was optional in ECC, but is structurally embedded in S/4HANA. 1. ECC allowed inventory valuation without activating material ledger. 2. S/4HANA requires material ledger for multi-currency and valuation consistency. 3. Historical price differences and inventory values must be migrated correctly. 4. Activation impacts currency types, valuation areas, and accounting integration. This is not a feature toggle. It is a valuation framework shift.
Why this is a migration-exclusive failure.
Only transformation projects force material ledger activation in previously inactive systems. 1. ECC systems could operate without material ledger for decades. 2. S/4HANA embeds material ledger into core valuation architecture. 3. Conversion requires historical value consistency at migration cutover. 4. Financial exposure surfaces only when activation becomes mandatory. Mandatory architecture changes create migration-specific risk.
Ownership, who actually fixes it.
Although activation appears technical, valuation control is financial. 1. FI cross-module lead defines valuation strategy and currency settings. 2. MM valuation alignment confirms material price control and valuation areas. 3. Data migration team validates inventory balances and price differences. 4. Leadership approves valuation impact and financial exposure strategy.
Who gets blamed versus who owns it.
When valuation discrepancies appear, tension escalates quickly. 1. Blamed technical team for migration complexity. 2. Blamed SAP for mandatory activation. 3. Actual owner historical decision not to activate material ledger. 4. Root cause underestimation of valuation impact during ECC design.
How this is actually fixed, the right way by a role.
Activation must be treated as a financial transformation, not a checkbox. 1. FI defines currency types and valuation approach before activation. 2. MM aligns material master price control settings. 3. Data migration performs reconciliation between stock value and FI balances. 4. Parallel valuation simulation is executed before cutover.
What not to do, common wrong fixes.
Shortcuts in valuation configuration create long-term instability. 1. Activating material ledger without financial simulation. 2. Ignoring currency configuration alignment. 3. Skipping historical price difference reconciliation. 4. Treating activation as a purely technical step. Valuation errors surface during financial close, not during technical testing.
Follow-up 1. Why does material ledger activation affect currencies?
Answer: material ledger manages parallel valuation and multiple currency types. When activated, inventory values must reconcile across local, group, and hard currencies. Incorrect configuration leads to mismatches between MM and FI balances.
Follow-up 2. Can activation be performed without financial impact?
Answer: no. Even if actual costing is not used, material ledger changes how price differences are stored and reconciled. Activation affects reporting and closing behavior. Financial validation is mandatory before proceeding.
Follow-up 3. Curveball. Why do some teams delay discussing material ledger until late in the project?
Answer: because it appears as a technical requirement rather than a financial transformation. Projects focus on inventory quantity migration and underestimate valuation complexity. The real impact surfaces only during financial reconciliation.
Exclusive pro tip.
If material ledger was inactive in ECC, treat its activation as a finance-led mini-project inside your conversion program.
Scenario 13. Price difference logic behaves differently after migration.
After S/4HANA conversion, finance teams notice that price differences are posted differently compared to ECC. Variances that previously hit specific accounts now distribute differently or remain visible in inventory valuation. What appears to be an accounting configuration issue is often a material ledger behavioral shift.
Scenario classification.
1. Complexity, high financial posting impact. 2. Phase, post-conversion financial validation. 3. Primary ownership, FI cross-module. 4. Supporting MM price control validation.
Why this happens, scenario analysis and root cause.
Material ledger changes how price differences are calculated and stored. 1. S/4HANA stores price differences within material ledger structures. 2. Parallel currency valuation influences variance calculation. 3. Standard price and moving average behaviors interact differently. 4. Closing processes distribute differences across valuation layers. Price differences are no longer simple postings. They are valuation events.
Why this is a migration-exclusive failure.
In ECC without material ledger, variance logic was simpler and more predictable. 1. ECC posted price differences directly to defined variance accounts. 2. S/4HANA integrates price differences into material ledger valuation logic. 3. Parallel currency and valuation layers amplify variance complexity. 4. This behavioral shift occurs only after mandatory material ledger activation. Mandatory architecture creates mandatory behavioral change.
Ownership, who actually fixes it.
Although MM observes price impact, reconciliation authority sits with finance. 1. FI cross-module lead validates variance account determination and closing behavior. 2. MM price control validation confirms material master settings and valuation classes. 3. CO reviews cost component impact where applicable. 4. Data team reconciles inventory valuation against FI balances.
Who gets blamed versus who owns it.
When variances look different, panic often follows. 1. Blamed MM for incorrect price control. 2. Blamed migration team for data issues. 3. Actual owner, new material ledger valuation logic. 4. Root cause, failure to simulate price difference behavior before cutover.
How this is actually fixed, the right way by a role.
Correction requires financial modeling, not account reconfiguration guessing. 1. FI simulates period-end closing under material ledger. 2. MM validates price control and procurement process alignment. 3. Variance account determination is reviewed and adjusted if necessary. 4. Parallel currency postings are reconciled before final sign-off.
What not to do, common wrong fixes.
Superficial adjustments hide valuation logic gaps. 1. Changing variance accounts without root cause analysis. 2. Manually adjusting inventory values to force reconciliation. 3. Ignoring currency layer impact. 4. Skipping period-end simulation during testing. Variance confusion during close damages financial credibility.
Follow-up 1. Why do price differences sometimes remain in inventory instead of posting out?
Answer: material ledger integrates differences into multi-level valuation. Depending on price control and period closing configuration, variances may adjust inventory value rather than immediately expensing. This reflects a valuation philosophy change.
Follow-up 2. How can teams prepare for variance behavior changes?
Answer: by running simulation closes in quality systems before migration. Reviewing price control distribution and reconciliation scenarios under multiple currencies prevents unexpected posting surprises after go-live.
Follow-up 3. Curveball. Why does variance confusion escalate during the first S4 close?
Answer: because stakeholders expect identical behavior to ECC. When postings shift slightly due to valuation logic, confidence drops quickly. Clear pre-go-live communication and simulation are critical.
Exclusive pro tip.
Before go-live, simulate one full financial close under material ledger. If variances surprise you in testing, they will shock you in production.
Scenario 14. Standard price versus moving average confusion after migration.
After migrating to S/4HANA with material ledger active, business users begin noticing unexpected inventory value fluctuations. Materials previously managed smoothly under standard price or moving average now behave differently during goods movements and invoice postings. What appears to be a master data issue is often a valuation logic misunderstanding.
Scenario classification.
1. Complexity, medium to high valuation interpretation risk. 2. Phase, post-conversion stabilization and financial close. 3. Primary ownership MMM-led. 4. Supporting FI financial reconciliation.
Why this happens, scenario analysis and root cause.
Material ledger influences how both price controls behave during postings. 1. Standard price materials now accumulate variances differently under material ledger. 2. Moving average materials are recalculated across parallel currencies. 3. Actual costing layers affect valuation visibility at period close. 4. Legacy expectations from ECC no longer match S4 behavior. Price control is not removed, but its impact is amplified.
Why this is a migration-exclusive failure.
In ECC without material ledger, price control behavior was more isolated. 1. ECC handled standard and moving average largely within MM scope. 2. S4HANA integrates valuation into mandatory material ledger logic. 3. Parallel currency valuation influences recalculation behavior. 4. Behavioral shifts occur only after transformation and ML activation. Mandatory ML changes how price control feels operationally.
Ownership, who actually fixes it.
Although inventory fluctuations appear operational, financial validation is critical. 1. MM-led reviews material master price control settings and procurement flows. 2. FI financial reconciliation validates valuation postings and account impact. 3. CO reviews cost component and variance allocation where applicable. 4. Data team reconciles material valuation before and after close.
Who gets blamed versus who owns it.
When inventory value fluctuates, accountability conversations intensify. 1. Blamed MM for incorrect price control selection. 2. Blamed migration team for data inconsistency. 3. Actual owner combined ML valuation configuration and expectations gap. 4. Root cause insufficient communication about behavioral differences post-ML.
How this is actually fixed, the right way by a role.
Correction requires clarity of valuation strategy rather than reactive changes. 1. MM validates which materials require standard versus moving average pricing. 2. FI reviews valuation class mapping and variance account impact. 3. Period end simulations confirm acceptable inventory value behavior. 4. Training is conducted to reset user expectations post-migration.
What not to do, common wrong fixes.
Frequent price control changes create further instability. 1. Switching price control mid-period without impact analysis. 2. Manually adjusting material master values to mask variance. 3. Ignoring currency layer implications. 4. Overriding closing results without reconciliation. Price control changes without strategy amplify volatility.
Follow-up 1. Why does moving average look more volatile after migration?
Answer: because material ledger recalculates valuation across multiple currency layers. Small price differences accumulate and become more visible. The volatility is not new, but its transparency increases.
Follow-up 2. Can standard price eliminate ML variance impact?
Answer: no. Standard price materials still accumulate variances under material ledger. The difference lies in how and when those variances are settled during closing. Both price controls require reconciliation discipline.
Follow-up 3. Curveball. Why do users often think valuation is wrong when it is technically correct?
Answer: because expectations are anchored in ECC behavior. When posting flows look different, perception shifts quickly. Transparent communication and simulation are critical to maintain trust.
Exclusive pro tip.
Do not migrate price control assumptions. Revalidate them under material ledger before go live.
Scenario 15. Inventory value does not match FI after migration.
After go live on S4HANA, finance teams discover that total inventory value in MM does not reconcile with the general ledger. The quantities appear correct, but valuation totals differ. What initially looks like a migration data issue often traces back to material ledger behavior and parallel currency handling.
Scenario classification.
1. Complexity, critical financial reconciliation risk. 2. Phase, post-conversion financial close. 3. Primary ownership FI cross-module. 4. Supporting MM valuation review.
Why this happens, scenario analysis and root cause.
Reconciliation gaps are rarely quantity related. They are valuation layer related. 1. Material ledger introduces parallel valuation and currency layers. 2. Price differences may remain within ML until period-end settlement. 3. Migration mapping between MM valuation and FI accounts may be misaligned. 4. Currency conversion settings amplify minor valuation inconsistencies. If quantities match but values differ, the issue is valuation semantics.
Why this is a migration-exclusive failure.
ECC systems without material ledger had simpler reconciliation paths. 1. ECC posted inventory values directly to FI with fewer valuation layers. 2. S/4HANA embeds material ledger into mandatory valuation flow. 3. Parallel currency reconciliation becomes mandatory post-migration. 4. These reconciliation complexities surface only after transformation. Mandatory ML integration introduces multi-layer reconciliation exposure.
Ownership, who actually fixes it.
Although MM holds quantity responsibility, valuation control lies with finance. 1. FI cross-module lead performs GL reconciliation and account mapping validation. 2. MM valuation review confirms material price control and valuation classes. 3. CO validates cost component allocation where relevant. 4. Data migration team reviews opening balance mapping.
Who gets blamed versus who owns it.
When inventory does not reconcile, confidence drops rapidly. 1. Blamed MM for incorrect material valuation. 2. Blamed migration team for flawed data load. 3. Actual owner valuation configuration and ML currency alignment. 4. Root cause insufficient reconciliation simulation before go live.
How this is actually fixed, the right way by a role.
Reconciliation must be systematic and layered. 1. FI reconciles inventory accounts against ML valuation layers. 2. MM validates price control and movement type valuation impact. 3. Parallel currency differences are analyzed separately. 4. Period-end close is simulated to ensure variance settlement correctness.
What not to do, common wrong fixes.
Manual adjustments without analysis create audit exposure. 1. Posting manual journal entries to force reconciliation. 2. Ignoring parallel currency differences. 3. Blaming quantity discrepancies without reviewing valuation layers. 4. Skipping detailed ML closing simulation. Forced reconciliation hides systemic valuation misalignment.
Follow-up 1. Why can quantities reconcile while values do not?
Answer: because valuation layers operate independently of quantity storage. Material ledger introduces multi-currency and variance settlement logic that affects value without altering physical stock. The mismatch is financial, not logistical.
Follow-up 2. How can reconciliation risk be minimized before go live?
Answer: by performing full period-end simulations in quality systems and reconciling inventory valuation across all currencies. Opening balances should be validated against both MM and FI reports prior to cutover.
Follow-up 3. Curveball. Why do reconciliation issues often surface during the first close?
Answer: because initial transactions may look correct individually. The true valuation impact appears only when period-end settlement distributes variances across accounts and currencies. Close processes reveal structural misalignment.
Exclusive pro tip.
Never sign off migration based only on quantity validation. Value reconciliation under material ledger is the real test of stability.
Scenario 16. Actual costing activated without understanding impact.
During or after S/4HANA migration, the project activates actual costing within material ledger without fully assessing its impact. Initially, everything appears stable. However, at period close, unexpected revaluations, cost component shifts, and profitability swings begin to surface. What seemed like a strategic enhancement becomes a financial shock.
Scenario classification.
1. Complexity, critical period-end financial risk. 2. Phase, configuration, and post-go-live financial close. 3. Primary ownership, FI cross-module. 4. Supporting MM and CO.
Why this happens, scenario analysis and root cause.
Actual costing fundamentally changes how inventory variances are treated. 1. Actual costing performs multi-level price determination at period close. 2. Purchase price differences and production variances are redistributed. 3. Cost components flow through valuation layers affecting profitability. 4. Teams activate functionality without running simulation closes. Actual costing is not a reporting feature. It is a valuation engine.
Why this is a migration-exclusive failure.
Actual costing was optional in ECC and often avoided due to complexity. 1. S/4HANA makes material ledger mandatory and simplifies activation. 2. Projects sometimes activate actual costing to leverage S/4 capabilities. 3. Activation introduces revaluation logic not previously experienced. 4. Transformation programs encourage feature activation without impact modeling. New capabilities introduce new financial behavior.
Ownership, who actually fixes it.
Although MM sees inventory impact, financial modeling ownership lies with finance. 1. FI cross-module lead defines actual costing strategy and valuation approach. 2. CO validates cost component split and profitability impact. 3. MM confirms procurement and production process alignment. 4. Controlling team simulates period-end cost roll-ups before activation.
Who gets blamed versus who owns it.
When closing results fluctuate, blame spreads quickly. 1. Blamed CO for profitability volatility. 2. Blamed migration team for incorrect configuration. 3. Actual owner strategic decision to activate actual costing without simulation. 4. Root cause inadequate financial impact assessment before go live.
How this is actually fixed, the right way by a role.
Stabilization requires controlled financial simulation and governance. 1. FI and CO conduct controlled simulation closes in quality systems. 2. Variance allocation rules are reviewed and adjusted. 3. Cost component splits are validated against profitability expectations. 4. Governance is established for phased activation if required.
What not to do, common wrong fixes.
Financial revaluation should never be treated as technical noise. 1. Deactivating actual costing abruptly without reconciliation. 2. Posting manual journals to suppress valuation shifts. 3. Ignoring cost component distribution changes. 4. Skipping multi-period simulation before production use. Revaluation surprises erode executive confidence quickly.
Follow-up 1. Why does actual costing cause profitability swings?
Answer: because it reallocates variances across materials and production levels at period close. Costs previously expensed immediately may now be absorbed into inventory or distributed differently, affecting margin analysis.
Follow-up 2. Can actual costing be reversed easily after activation?
Answer: reversal is technically complex and financially sensitive. Once valuation flows change and postings occur, rollback requires reconciliation across multiple periods. Governance must precede activation.
Follow-up 3. Curveball. Why do teams activate actual costing during migration?
Answer: because S/4HANA promotes advanced costing capabilities, and projects want to maximize value from transformation. However, feature activation without financial maturity often leads to instability.
Exclusive pro tip.
Never activate actual costing during migration, unless your finance team can explain its closing impact in detail before go live.
Scenario 17. Subcontracting valuation behaves differently under material ledger.
After S/4HANA migration, subcontracting processes begin showing unexpected valuation behavior. Component consumption, goods receipt valuation, and price difference allocation no longer mirror ECC expectations. Inventory values fluctuate, and FI postings appear redistributed. The issue is not subcontracting logic itself, but how material ledger processes valuation layers.
Scenario classification.
1. Complexity, high cross-module valuation sensitivity. 2. Phase, post-conversion stabilization and first financial close. 3. Primary ownership MM cross-module. 4. Supporting FI.
Why this happens, scenario analysis and root cause.
Subcontracting involves layered valuation flows that are amplified under material ledger. 1. Material ledger captures variances across component and finished material layers. 2. Parallel currency valuation recalculates subcontracting price differences. 3. Actual costing may redistribute component variances during closing. 4. ECC subcontracting logic did not involve mandatory ML revaluation. Layered valuation becomes more visible, and more sensitive under ML.
Why this is a migration-exclusive failure.
In ECC without material ledger, subcontracting valuation followed simpler flows. 1. ECC process subcontracting without mandatory multi-layer valuation. 2. S/4HANA enforces ML integration for all inventory movements. 3. Parallel currency and variance allocation change financial outcomes. 4. This shift appears only after ML activation during migration. Mandatory ML integration alters subcontracting economics.
Ownership, who actually fixes it.
Although subcontracting is MM-driven operationally, valuation impact sits with finance. 1. MM cross-module lead reviews subcontracting configuration and BOM alignment. 2. FI validates valuation class and account determination impact. 3. CO reviews cost distribution and margin implications. 4. Data team performs reconciliation across component and finished goods valuation.
Who gets blamed versus who owns it.
When subcontracting values fluctuate, operational teams feel immediate pressure. 1. Blamed MM for incorrect subcontracting configuration. 2. Blamed FI for valuation account issues. 3. Actual owner material ledger valuation layer integration. 4. Root cause lack of subcontracting simulation under ML before go live.
How this is actually fixed, the right way by a role.
Correction requires full process simulation, not parameter tweaking. 1. MM simulates subcontracting cycles including component issue and receipt. 2. FI validates account determination across valuation layers. 3. Actual costing impact is reviewed at period close. 4. Parallel currency reconciliation is performed before financial sign-off.
What not to do, common wrong fixes.
Quick adjustments without valuation analysis create audit exposure. 1. Changing valuation classes without reviewing ML impact. 2. Posting manual adjustments to mask valuation swings. 3. Ignoring currency layer discrepancies. 4. Skipping full subcontracting lifecycle testing. Subcontracting valuation errors propagate silently into margin reporting.
Follow-up 1. Why does subcontracting feel more volatile under material ledger?
Answer: because component consumption and finished material valuation are recalculated across multiple valuation layers. Variances that were previously absorbed immediately now flow through structured ML settlement logic, increasing transparency and sensitivity.
Follow-up 2. How can teams reduce subcontracting valuation risk?
Answer: by running end-to-end subcontracting simulations in quality systems, including goods issue, receipt, invoice, and period close. Validating currency layer postings before cutover prevents reconciliation shocks.
Follow-up 3. Curveball. Why do subcontracting issues often appear only at first close?
Answer: because operational transactions look normal during daily posting. The true valuation impact becomes visible when ML settlement and actual costing redistribute differences across materials and currencies.
Exclusive pro tip.
If subcontracting is core to your business, treat material ledger testing as a financial stress test before go live.
Category 3 wrap-up. Valuation is no longer optional.
Material ledger forces every organization to confront valuation discipline. Inventory is no longer just quantity multiplied by price. It becomes a structured financial object across currencies and layers. Projects that underestimate this shift face reconciliation shock during their first close.
Transition from single valuation to parallel reality.
If material ledger introduces structured valuation, parallel valuation multiplies it. Legal view, group view, profit center view, and transfer pricing now coexist simultaneously. In S/4HANA, these layers must reconcile in real time. That is where complexity escalates.
Category 4. Parallel valuation and transfer pricing.
S/4HANA supports multiple valuation views across legal entities, group consolidation, and profit centers. While ECC allowed simpler valuation logic, S4 embeds multi-ledger and multi-currency valuation deeply into financial architecture. Misalignment between these views results in reporting drift, consolidation discrepancies, and audit risk.
Scenarios covered in Category 4.
Scenario 18. Legal versus group valuation mismatch. Primary owner FI cross-module, supporting MM. Scenario 19. Profit center revaluation differences. Primary owner CO cross-module supporting FI and MM. Scenario 20 multiple currency valuation confusion. Primary owner FI cross-module supporting MM. Scenario 21 transfer pricing logic shifts after migration. Primary owner CO cross-module supporting MM and FI. Scenario 22 ledger-specific valuation drift. Primary owner FI cross-module supporting MM.
Scenario 18. Legal versus group valuation mismatch after migration.
After migrating to S/4HANA with parallel valuation active, finance teams notice that inventory values differ between legal view and group view. Consolidated reports do not align with local statutory reporting. What appears to be a posting error is often a valuation configuration misalignment across ledgers.
Scenario classification.
1. Complexity, critical consolidation and audit risk. 2. Phase, post-conversion financial close and group reporting. 3. Primary ownership FI cross-module. 4. Supporting MM valuation logic validation.
Why this happens, scenario analysis and root cause.
Parallel valuation introduces multiple financial realities for the same inventory. 1. Legal valuation follows statutory accounting principles. 2. Group valuation eliminates intercompany profit layers. 3. Material ledger stores valuation differences across currency and ledger layers. 4. Configuration inconsistencies amplify valuation gaps. One material can have multiple financially correct values simultaneously.
Why this is a migration-exclusive failure.
ECC systems often operated with simplified or single valuation logic. 1. ECC rarely implemented full parallel valuation in standard deployments. 2. S/4HANA integrates ledger-based valuation deeply into accounting architecture. 3. Transformation programs activate multi-ledger reporting. 4. Reconciliation exposure appears only after parallel views coexist. Transformation multiplies valuation complexity.
Ownership, who actually fixes it.
Although MM provides quantity foundation, reconciliation authority sits with finance. 1. FI cross-module lead validates ledger configuration and valuation views. 2. MM valuation logic validation confirms material master settings. 3. Group reporting team reviews consolidation elimination logic. 4. Data team reconciles ledger balances across valuation views.
Who gets blamed versus who owns it.
When consolidation numbers drift, executive pressure increases rapidly. 1. Blamed group reporting for consolidation mismatch. 2. Blamed MM for incorrect material valuation. 3. Actual owner parallel valuation configuration misalignment. 4. Root cause insufficient reconciliation simulation before go live.
How this is actually fixed, the right way by a role.
Correction requires structured reconciliation across valuation layers. 1. FI reviews ledger-specific configuration and valuation areas. 2. Group elimination logic is validated against transfer pricing rules. 3. Material ledger valuation layers are reconciled across currencies. 4. Parallel close simulation is executed before reporting sign-off.
What not to do, common wrong fixes.
Quick manual adjustments create long-term audit exposure. 1. Posting manual consolidation journals to force alignment. 2. Ignoring valuation differences between ledgers. 3. Disabling elimination logic temporarily. 4. Skipping group-level close simulation. Forced alignment masks systemic configuration errors.
Follow-up 1. Why can both legal and group values be correct yet different?
Answer: because legal valuation follows statutory accounting, while group valuation removes internal profit margins and aligns consolidated reporting. Both reflect valid accounting perspectives, but configuration must ensure controlled reconciliation.
Follow-up 2. How can reconciliation be stabilized before go live?
Answer: by running full legal and group ledger simulations in parallel during testing. Reconciliation between valuation views should be validated before first production close to avoid executive-level escalations.
Follow-up 3. Curveball. Why do executives panic when parallel valuation differences appear?
Answer: because multiple values for the same inventory feel like inconsistency. Without proper communication, stakeholders assume errors. Education and simulation are critical to building confidence.
Exclusive pro tip.
Parallel valuation is not optional reporting complexity. It is a governance discipline that must be validated before financial sign-off.
Scenario 19. Profit Center Revaluation Differences After Migration.
After S/4HANA migration, profitability reports show unexpected valuation shifts between profit centers. Inventory transfers that were previously neutral now create visible margin fluctuations. What appears to be a transfer pricing issue is often rooted in profit center valuation logic under parallel valuation.
Scenario classification.
1. Complexity, high profitability and management reporting risk. 2. Phase, post-conversion reporting and first close. 3. Primary ownership, CO cross-module. 4. Supporting FI and MM.
Why this happens, scenario analysis and root cause.
Profit center valuation introduces an additional internal view of inventory value. 1. S/4HANA supports profit center valuation as a separate reporting perspective. 2. Interprofit center transfers may include internal markups. 3. Material ledger distributes valuation differences across profit centers. 4. Configuration gaps amplify perceived margin shifts. Management view and legal view can diverge if not aligned.
Why this is a migration-exclusive failure.
ECC environments often simplified profit center valuation logic. 1. Many ECC systems did not activate full profit center valuation. 2. S/4HANA integrates valuation deeply into multi-ledger architecture. 3. Parallel valuation views expose internal margin layers. 4. Transformation activates reporting layers that previously remained dormant. Migration activates reporting dimensions that were historically unused.
Ownership, who actually fixes it.
Although operational flows originate in MM, profitability integrity sits with controlling. 1. CO cross-module lead defines profit center valuation rules and internal pricing. 2. FI validates ledger alignment and financial reporting impact. 3. MM confirms stock transfer process configuration. 4. Data team reconciles interprofit center inventory postings.
Who gets blamed versus who owns it.
When internal margins fluctuate, business leaders escalate quickly. 1. Blamed CO for incorrect profitability setup. 2. Blamed MM for transfer configuration. 3. Actual owner profit center valuation design under parallel valuation. 4. Root cause, lack of simulation of internal transfers before go live.
How this is actually fixed, the right way by a role.
Stabilization requires cross-functional alignment of valuation strategy. 1. CO reviews internal pricing logic and valuation layers. 2. FI validates ledger postings and elimination impact. 3. MM confirms transfer movement types and valuation behavior. 4. Full-cycle internal transfer simulation is executed in quality systems.
What not to do, common wrong fixes.
Reactive changes without analysis create cascading inconsistencies. 1. Adjusting profit center assignment mid-period. 2. Posting manual margin corrections. 3. Ignoring ledger-level reconciliation. 4. Skipping simulation of intercompany and internal transfers. Internal margin instability damages management reporting credibility.
Follow-up 1. Why do interprofit center transfers create margin shifts?
Answer: because profit center valuation can include internal markups or cost reallocation. Under parallel valuation, these internal differences become visible and affect management reporting even if legal valuation remains unchanged.
Follow-up 2. How can profit center revaluation risk be minimized?
Answer: by running controlled simulations of internal stock transfers and validating profitability impact across reporting views. Cross-functional alignment between CO and FI before cutover prevents surprises.
Follow-up 3. Curveball. Why does this issue rarely appear during technical testing?
Answer: because functional testing often validates transaction flow rather than margin interpretation. The true impact surfaces when management reporting is reviewed after financial close.
Exclusive pro tip.
If profit center valuation is active, simulate internal transfers before go live. Management trust depends on margin stability.
Scenario 20. Multiple currency valuation confusion after migration.
After S/4HANA migration, Finance teams observe that inventory values differ across company code currency, group currency, and hard currency views. Reports appear inconsistent depending on which currency column is analyzed. What seems like exchange rate error is often a misunderstanding of parallel currency valuation under material ledger.
Scenario classification.
1. Complexity, high multi-currency reconciliation risk. 2. Phase, post-conversion financial close and reporting. 3. Primary ownership, FI cross-module. 4. Supporting MM valuation review.
Why this happens, scenario analysis and root cause.
S/4HANA calculates inventory value simultaneously across multiple currency types. 1. Material ledger stores values in local, group, and additional currencies. 2. Exchange rate timing differences influence valuation outcomes. 3. Parallel currency settings are embedded at ledger and company code level. 4. Users compare currencies without understanding valuation timing logic. Currency differences are structured outcomes, not random errors.
Why this is a migration-exclusive failure.
ECC systems often used simpler currency handling structures. 1. Many ECC deployments maintained limited parallel currency views. 2. S/4HANA enforces multi-currency storage in material ledger. 3. Transformation activates additional reporting currency layers. 4. Currency reconciliation exposure increases significantly after migration. Transformation multiplies currency transparency.
Ownership, who actually fixes it.
Although valuation is operationally triggered by MM, currency governance belongs to finance. 1. FI cross-module lead validates currency type configuration and exchange rate logic. 2. MM valuation review confirms material master currency settings. 3. CO reviews impact on margin and cost reporting. 4. Data team performs reconciliation across currency layers.
Who gets blamed versus who owns it.
When currency columns do not match expectations, confusion escalates quickly. 1. Blamed exchange rate configuration. 2. Blamed MM for incorrect price control. 3. Actual owner parallel currency configuration and ML valuation logic. 4. Root cause, inadequate training and reconciliation simulation.
How this is actually fixed, the right way by a role.
Stabilization requires structured currency reconciliation discipline. 1. FI reviews currency type assignment and exchange rate settings. 2. Parallel ledger postings are reconciled systematically. 3. Period end simulation validates valuation across currencies. 4. Reporting templates are aligned to clearly distinguish currency views.
What not to do, common wrong fixes.
Manual exchange rate adjustments rarely solve structural issues. 1. Posting manual adjustments to align currency values. 2. Changing exchange rate types without impact analysis. 3. Ignoring ledger-level currency settings. 4. Suppressing reporting columns to hide differences. Currency confusion is governance failure, not technical defect.
Follow-up 1. Why can inventory values differ across currencies even on the same day?
Answer: because different currency types may use distinct exchange rate types or posting date logic. Material ledger calculates values per currency layer, which may not always align exactly due to rate timing and valuation sequence.
Follow-up 2. How can teams build confidence in multi-currency valuation?
Answer: by documenting currency type configuration clearly and running structured reconciliation reports during testing. Transparent reporting that separates local, group, and additional currency views reduces confusion.
Follow-up 3. Curveball. Why does multi-currency transparency feel like inconsistency?
Answer: because ECC often concealed complexity within simplified reporting. S/4HANA exposes valuation layers more explicitly. Transparency can feel like instability when expectations are not reset.
Exclusive pro tip.
If multiple currency columns exist in your report, ensure stakeholders understand which one drives decision-making before go live.
Scenario 21. Transfer pricing logic shifts after migration.
After S/4HANA migration, intercompany stock transfers and internal sales begin producing unexpected margin behavior. Transfer prices that were stable in ECC now behave differently across valuation views. Consolidation reports show timing differences and internal profit elimination mismatches. The issue is rarely a pricing error. It is a structural shift in transfer pricing logic under parallel valuation.
Scenario classification.
1. Complexity, critical intercompany and consolidation risk. 2. Phase, post-conversion intercompany reconciliation. 3. Primary ownership, CO cross-module. 4. Supporting MM and FI.
Why this happens, scenario analysis and root cause.
Transfer pricing under S/4HANA is tightly integrated with parallel valuation and material ledger. 1. Parallel valuation introduces legal and group valuation perspectives. 2. Intercompany markups are treated differently across ledger views. 3. Material ledger distributes variances across valuation layers. 4. Transfer price determination interacts with actual costing logic. Transfer pricing becomes multidimensional under S/4HANA.
Why this is a migration-exclusive failure.
ECC transfer pricing often operated under simplified or partially implemented valuation models. 1. Many ECC systems lacked full parallel valuation integration. 2. S/4HANA enforces structured ledger-based valuation separation. 3. Transformation activates valuation layers previously unused. 4. Intercompany reconciliation becomes more transparent and more sensitive. Migration exposes transfer pricing design weaknesses.
Ownership, who actually fixes it.
Although MM executes stock transfers, transfer pricing governance sits with controlling and finance. 1. CO cross-module lead reviews transfer pricing strategy and markup logic. 2. FI validates ledger-level elimination and reconciliation impact. 3. MM confirms intercompany movement type configuration. 4. Group reporting team tests elimination postings and consolidation alignment.
Who gets blamed versus who owns it.
When internal margins fluctuate, escalation moves quickly to executive level. 1. Blamed MM for incorrect intercompany setup. 2. Blamed FI for elimination logic errors. 3. Actual owner transfer pricing design under parallel valuation architecture. 4. Root cause, inadequate simulation of multi-ledger transfer flows.
How this is actually fixed, the right way by a role.
Stabilization requires structured intercompany simulation and ledger reconciliation. 1. CO validates markup logic across valuation views. 2. FI reviews elimination configuration in group ledger. 3. MM tests end-to-end intercompany stock movements. 4. Parallel close simulations are executed before reporting sign-off.
What not to do, common wrong fixes.
Reactive pricing changes create cascading valuation errors. 1. Adjusting markup percentages without valuation analysis. 2. Posting manual elimination entries to force alignment. 3. Ignoring ledger-specific transfer differences. 4. Skipping multi-company close simulations. Transfer pricing instability directly impacts consolidation credibility.
Follow-up 1. Why does transfer pricing behave differently after migration?
Answer: because S/4HANA integrates transfer pricing with parallel valuation and material ledger. Variances and markups are processed across multiple ledger layers, making margin flows more visible and sometimes more volatile.
Follow-up 2. How can teams prevent transfer pricing shock at go-live?
Answer: by simulating full intercompany scenarios across legal and group valuation views during testing. Transfer pricing should be validated in both operational and consolidation contexts before production deployment.
Follow-up 3. Curveball. Why is transfer pricing one of the most sensitive migration risks?
Answer: because it directly impacts reported margin and executive-level performance metrics. Even small configuration shifts can materially alter profitability perception across business units.
Exclusive pro tip.
Never activate parallel valuation and transfer pricing without running a simulated consolidated close first.
Scenario 22. Ledger-specific valuation drift after migration.
After S/4HANA migration, finance discovers that inventory values differ across ledgers even when quantities remain identical. Reports extracted from different ledger views show subtle but material deviations. The issue is not transaction failure. It is ledger-specific valuation drift caused by configuration misalignment.
Scenario classification.
1. Complexity, high multi-ledger reconciliation risk. 2. Phase, post-conversion financial close and audit preparation. 3. Primary ownership, FI cross-module. 4. Supporting MM valuation review.
Why this happens, scenario analysis and root cause.
S/4HANA allows ledger-specific configuration for valuation and accounting logic. 1. Different ledgers may use different accounting principles. 2. Currency type and valuation area settings vary by ledger. 3. Material ledger distributes variances per ledger view. 4. Configuration inconsistencies amplify valuation gaps. Ledger views represent distinct accounting perspectives.
Why this is a migration-exclusive failure.
ECC systems often relied on a single leading ledger with limited separation. 1. Many ECC landscapes operated without complex ledger separation. 2. S/4HANA embeds ledger-specific valuation deeply into Universal Journal. 3. Transformation activates additional ledgers for reporting. 4. Multi-ledger reconciliation exposure increases after migration. Migration multiplies ledger accountability.
Ownership, who actually fixes it.
Ledger governance sits primarily within finance architecture. 1. FI cross-module lead reviews ledger configuration and accounting principles. 2. MM confirms valuation class and material master alignment. 3. CO validates impact on profitability reporting. 4. Data team reconciles ledger-specific balances systematically.
Who gets blamed versus who owns it.
When ledger values diverge, audit concerns escalate quickly. 1. Blamed FI for accounting misconfiguration. 2. Blamed MM for valuation errors. 3. Actual owner ledger-specific configuration misalignment. 4. Root cause insufficient multi-ledger simulation before go live.
How this is actually fixed. The right way by a role.
Correction requires structured multi-ledger reconciliation discipline. 1. FI reviews accounting principles and ledger settings. 2. Parallel ledger postings are reconciled across valuation areas. 3. Material ledger currency and valuation views are validated. 4. Multi-ledger close simulation is executed before audit review.
What not to do, common wrong fixes.
Manual reconciliation masks structural weaknesses. 1. Posting manual ledger adjustments without configuration review. 2. Disabling secondary ledger reporting. 3. Ignoring small valuation gaps across ledgers. 4. Treating drift as rounding error without root cause analysis. Ledger drift erodes audit confidence over time.
Follow-up 1. Why can the same material show different values in different ledgers?
Answer: because each ledger may represent a different accounting principle or valuation view. S/4HANA allows ledger-specific postings and currency logic, meaning financial representation can legitimately differ across reporting perspectives.
Follow-up 2. How can ledger drift be prevented before go live?
Answer: by executing parallel multi-ledger close simulations and validating valuation alignment across ledgers. Structured reconciliation reporting must be part of the cut-over checklist.
Follow-up 3. Curveball. Why is ledger-specific drift more dangerous than obvious posting errors?
Answer: because transactions succeed technically, while financial interpretation diverges silently. Audit exposure grows gradually without triggering immediate system alerts.
Exclusive pro tip.
If multiple ledgers are active, validate reconciliation discipline before first audit cycle, not after discrepancies appear.
Category 4 wrap-up. Parallel valuation is financial architecture.
Parallel valuation multiplies financial reality. Legal, group, and profit center views must coexist without contradiction. S/4HANA enforces transparency across ledgers and currencies. Organizations that fail to simulate multi-ledger behavior before go-live face reconciliation shock at the executive level.
Transition from valuation layers to master data foundations.
If valuation defines financial meaning, material master defines operational behavior. Field length extensions, batch logic shifts, and purchasing view gaps can quietly destabilize procurement, inventory, and integration. Migration often exposes weaknesses in material governance that ECC tolerated for years.
Please check description or comment section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem solving, generally most asked system design. Most asked implementation project-related interview questions and answers. Most asked support project-related interview questions and answers. Required for your SAP functional modules interviews jobs like SAP MM Consultant jobs, SAP FICO Consultant jobs, SAP SD Consultant jobs, SAP PP Consultant jobs, SAP Ariba Consultant jobs, SAP Extended Warehouse Management EWM Consultant jobs, SAP Plant Maintenance PM Consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving. Interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Category 5. Material Master and Field Extensions.
S/4HANA enforces structural consistency in material master data. Field extensions such as MATNR 18-40, mandatory view governance, and cross-module dependencies introduce new risk during migration. What appears to be simple master data often becomes a cross-module stability challenge.
Scenarios covered in Category 5.
Scenario 23, MATNR 18-40 extension breaks interfaces. Primary owner MM cross-module, supporting integration and ABAP. Scenario 24, custom Z tables not adjusted for S4 structure. Primary owner ABAP technical lead, supporting MM. Scenario 25, batch management logic changes after migration. Primary owner MM led, supporting QM. Scenario 26, material status blocks procurement unexpectedly. Primary owner MM led, supporting procurement. Scenario 27, purchasing views missing after migration. Primary owner data led, supporting data team. Scenario 28, source determination behaves differently. Primary owner cross-module, supporting SD. Scenario 29, batch determination strategy shifts. Primary owner cross-module, supporting SD and PP.
Scenario 23. MATNR 18-40 extension breaks interfaces.
After S/4HANA migration, material numbers expand from 18 to 40 characters. Interfaces that previously exchanged material data begin failing, truncating values, or misaligning fields. Some transactions succeed, while downstream systems receive corrupted identifiers. What appears to be a small field extension becomes an enterprise-wide integration risk.
Scenario classification.
1. Complexity critical cross-system identifier risk. 2. Phase code remediation and data migration. 3. Primary ownership cross-module. 4. Supporting integration and ABAP.
Why this happens, scenario analysis and root cause.
Material number length extension changes both persistence and interface structure. 1. S/4HANA expands MATNR domain from 18 to 40 characters. 2. Custom programs and interfaces assume fixed 18-character length. 3. Flat files and middleware mappings truncate longer values. 4. External systems often hardcode material length validation. Identifier expansion cascades across every integration touchpoint.
Why this is a migration-exclusive failure.
ECC systems operated under a fixed 18-character material structure. 1. Legacy interfaces were built around fixed-length assumptions. 2. S/4HANA enforces extended domain length system-wide. 3. Migration activates longer identifiers in productive data. 4. Mismatch appears only when real extended values flow across systems. Transformation exposes integration rigidity.
Ownership, who actually fixes it.
Material governance is functional, but remediation is technical and integrational. 1. MM cross-module lead validates material master consistency. 2. Integration reviews and updates interface contracts. 3. ABAP refactors custom code to support 40-character MATDOC. 4. External system owners adjust field definitions and validation rules.
Who gets blamed versus who owns it?
When identifiers fail, escalation spreads quickly across teams. 1. Blamed integration for broken interfaces. 2. Blamed ABAP for truncation logic. 3. Actual owner, enterprise readiness for domain extension. 4. Root cause, failure to inventory all MATDOC dependencies before migration.
How this is actually fixed, the right way by a role.
Stabilization requires enterprise-wide identifier alignment. 1. MM validates extended material numbers across master data. 2. ABAP updates domain references and removes hard-coded lengths. 3. Integration teams adjust mappings and message formats. 4. Cross-system regression testing ensures identifier integrity.
What not to do, common wrong fixes.
Shortcuts create irreversible identifier corruption. 1. Truncating material numbers to 18 characters. 2. Hard-coding conversion exits without redesign. 3. Updating only inbound interfaces but ignoring outbound flows. 4. Assuming external systems will adapt automatically. Identifier integrity must be protected at all costs.
Follow-up 1. Why do some interfaces work while others fail?
Answer: interfaces that only process legacy 18-character materials appear stable. Failures occur when newly created 40-character materials flow through systems that still enforce old validation logic.
Follow-up 2. How can teams prepare for MATDOC extension early?
Answer: by performing a full dependency inventory of all material references across custom code, interfaces, and external systems. Field length impact analysis should be part of pre-conversion readiness.
Follow-up 3. Curveball. Why is MATDOC extension more dangerous than it appears?
Answer: because material numbers are foundational identifiers used in procurement, logistics, finance, and analytics. Corrupting or truncating them breaks traceability and undermines system trust.
Exclusive pro tip.
Treat MATDOC extension as an enterprise identifier transformation, not a simple field length increase.
Scenario 24. Custom Z tables not adjusted for S4 structure.
After S/4HANA migration, custom Z tables that store material or inventory-related data begin producing inconsistent results. Some reports fail, others return incomplete data, and custom transactions behave unpredictably. The issue is not with standard S4 tables, but with legacy Z structures never redesigned for the new data model.
Scenario classification.
1. Complexity, high custom code structural risk. 2. Phase code remediation and post-conversion stabilization. 3. Primary ownership, ABAP technical-led. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
Custom tables often replicate legacy ECC persistence logic. 1. Z tables were designed around ECC table structures such as MSEG and MKPF. 2. MATDOC domain and key structures change in S/4HANA. 3. Compatibility views do not automatically adjust custom schemas. 4. Hard-coded joins and assumptions no longer reflect universal journal logic. Custom persistence built for ECC rarely survives structural simplification.
Why this is a migration-exclusive failure.
ECC allowed custom shadow structures to operate alongside standard tables. 1. Legacy systems tolerated redundant custom persistence. 2. S/4HANA simplifies physical data storage such as MATDOC and ACDOCA. 3. Transformation removes structural guarantees relied upon by Z logic. 4. Migration activates extended domains and new key structures. Simplification punishes architectural duplication.
Ownership, who actually fixes it.
Although MM relies on these tables functionally, remediation is technical. 1. ABAP technical lead refactors Z tables and adjusts domain references. 2. MM validates functional correctness after redesign. 3. Data team performs data consistency checks and migration validation. 4. Basis supports transport sequencing and runtime validation.
Who gets blamed versus who owns it.
When custom transactions fail, accountability becomes blurred. 1. Blamed SAP for structural changes. 2. Blamed basis for post-conversion instability. 3. Actual owner custom code architecture that mirrored ECC tables. 4. Root cause failure to refactor Z persistence during remediation phase.
How this is actually fixed, the right way by a role.
Refactoring must align custom logic to S4 abstraction principles. 1. ABAP redesigns Z tables to consume released CDS views or APIs. 2. Deprecated direct table dependencies are removed. 3. Data migration scripts are adjusted for extended keys. 4. Regression testing validates end-to-end material flows.
What not to do, common wrong fixes.
Temporary compatibility patches create deeper technical debt. 1. Recreating ECC-style shadow tables in S4. 2. Hard-coding compatibility view reads permanently. 3. Ignoring domain extension warnings. 4. Postponing Z table redesign until after go-live. Custom architecture must evolve with core architecture.
Follow-up 1. Why do compatibility views not protect Z tables automatically?
Answer: compatibility views provide read access to legacy structures, but do not modify custom schemas or logic. Z tables built around old persistence models require explicit redesign to align with S/4HANA data architecture.
Follow-up 2. How can teams detect Z table risk early?
Answer: by running custom code scans and identifying references to deprecated tables and domains. Early remediation reduces post-conversion instability significantly.
Follow-up 3. Curveball. Why are Z tables often more dangerous than standard simplification items?
Answer: because they bypass SAP's structured compatibility safeguards. Custom persistence can silently diverge from core data models, creating reconciliation risk that is harder to detect.
Exclusive pro tip.
Every Z table referencing inventory or material data should be treated as high risk during migration.
Scenario 25. Batch management logic changes after migration.
After migrating to S/4HANA, batch-managed materials begin behaving differently during goods movements and quality inspections. Batch derivation, classification, or shelf life validation may not trigger as expected. Transactions technically post, but downstream traceability and compliance reporting start drifting.
Scenario classification.
1. Complexity, high compliance and traceability risk. 2. Phase, configuration validation and post-go-live stabilization. 3. Primary ownership, MM led. 4. Supporting QM.
Why this happens, scenario analysis and root cause.
Batch management logic interacts deeply with material master, classification, and quality management. 1. S/4HANA enforces stricter batch status and classification integration. 2. Legacy enhancements tied to ECC batch tables may no longer trigger. 3. Batch determination logic interacts differently with material ledger. 4. Configuration gaps surface during goods receipt and inspection processes. Batch control in S/4HANA is structurally integrated, not isolated.
Why this is a migration-exclusive failure.
ECC allowed flexible batch behavior with loosely coupled validation. 1. Legacy systems tolerated incomplete classification linkage. 2. S/4HANA integrates batch logic more tightly with core tables. 3. Migration activates stricter validation sequences. 4. Differences appear only when real batch-controlled processes execute. Transformation strengthens compliance enforcement.
Ownership, who actually fixes it.
Batch governance is primarily functional but requires technical validation. 1. MM led reviews batch management configuration and material settings. 2. QM validates inspection lot and quality integration. 3. ABAP refactors legacy batch enhancements if required. 4. Data team validates batch classification completeness.
Who gets blamed versus who owns it.
When traceability reports fail, compliance anxiety rises immediately. 1. Blamed QM for inspection integration gaps. 2. Blamed MM for incorrect batch settings. 3. Actual owner batch configuration and enhancement alignment under S4 architecture. 4. Root cause insufficient end-to-end batch scenario testing.
How this is actually fixed, the right way by a role.
Resolution requires simulation of real-world batch scenarios. 1. MM reviews batch-level activation and classification integration. 2. QM validates inspection type configuration. 3. ABAP adjusts custom exits tied to legacy batch tables. 4. Full traceability reporting is tested before production stabilization.
What not to do, common wrong fixes.
Compliance shortcuts create regulatory exposure. 1. Disabling batch status checks temporarily. 2. Bypassing classification requirements. 3. Skipping inspection integration validation. 4. Assuming ECC batch logic transfers unchanged. Traceability gaps become audit findings quickly.
Follow-up 1. Why do batch issues appear only after real production transactions?
Answer: because batch logic often depends on real goods movements, inspections, and valuation postings. Controlled test data rarely replicates the full life cycle of regulated or serialized materials.
Follow-up 2. How can teams reduce batch migration risk?
Answer: by executing full traceability simulations including goods receipt, quality inspection, stock transfer, and consumption scenarios. Batch reporting validation must be part of cut-over readiness.
Follow-up 3. Curveball. Why are batch issues more critical in regulated industries?
Answer: because pharmaceuticals, chemicals, and food industries rely on precise batch traceability. Even minor configuration shifts can lead to compliance violations and operational shutdown risk.
Exclusive pro tip.
If batch management is business critical, simulate regulatory audit scenarios before go live.
Scenario 26. Material status blocks procurement unexpectedly.
After migration to S/4HANA, purchase requisitions or purchase orders for certain materials are suddenly blocked. Buyers receive system errors indicating material status restrictions, even though the materials were fully operational in ECC. What appears to be a procurement issue is often a stricter enforcement of material status governance.
Scenario classification.
1. Complexity, medium operational disruption risk. 2. Phase, post-conversion stabilization and early procurement cycles. 3. Primary ownership, MM-MM-led. 4. Supporting procurement.
Why this happens, scenario analysis and root cause.
Material status controls transactional permissions across processes. 1. S/4HANA enforces material status more strictly at transactional level. 2. Legacy materials migrated with outdated or restrictive status codes. 3. Custom logic previously bypassed certain status validations. 4. View-level inconsistencies create hidden blocking conditions. Status governance becomes operationally visible under S/4HANA.
Why this is a migration-exclusive failure.
ECC systems often tolerated loosely controlled material status configuration. 1. Status inconsistencies existed without strict enforcement. 2. S/4HANA integrates material status across more processes. 3. Migration exposes dormant restrictions embedded in master data. 4. Blocked transactions surface only after real procurement cycles resume. Transformation enforces discipline that ECC allowed teams to ignore.
Ownership, who actually fixes it.
Procurement experiences the symptom, but master governance drives resolution. 1. MM-MM-led reviews material status configuration and business rules. 2. Procurement validates operational requirements and purchasing blocks. 3. Data team cleanses and aligns migrated material status values. 4. ABAP reviews custom enhancements interfering with status logic.
Who gets blamed versus who owns it.
When purchase orders fail, escalation is immediate. 1. Blamed procurement for incorrect PO creation. 2. Blamed MM for master data errors. 3. Actual owner, material status governance and data cleansing oversight. 4. Root cause, legacy status values migrated without rationalization.
How this is actually fixed, the right way by a role.
Resolution requires structured master data review. 1. MM reviews and rationalizes material status definitions. 2. Data team corrects inconsistent migrated status values. 3. Procurement validates transactional requirements. 4. Regression testing confirms no unintended blocking remains.
What not to do, common wrong fixes.
Removing control mechanisms without analysis creates compliance risk. 1. Blanket removal of material status restrictions. 2. Granting excessive authorizations to bypass errors. 3. Manual PO creation via workaround transactions. 4. Ignoring systemic status inconsistencies. Operational speed must not override governance integrity.
Follow-up 1. Why were these materials not blocked in ECC?
Answer: because ECC enforcement of material status was often less integrated across modules. Some processes tolerated inconsistent status values that S/4HANA now validates strictly at transaction level.
Follow-up 2. How can teams prevent procurement disruption?
Answer: by running status validation reports before cutover and simulating procurement cycles with real migrated data. Master data cleansing should precede production activation.
Follow-up 3. Curveball. Why are status issues considered governance failures?
Answer: because material status defines operational control boundaries. If those controls are inconsistent or outdated, it reflects weak master data governance rather than system defect.
Exclusive pro tip.
Treat material status review as part of risk mitigation, not just master data cleanup.
Scenario 27. Purchasing views missing after migration.
After S/4HANA migration, buyers attempt to create purchase orders but receive errors indicating that purchasing views are missing in the material master. Materials that were previously procured without issue now appear incomplete. The problem is not transactional. It is master data view governance that was never fully enforced in ECC.
Scenario classification.
1. Complexity medium data completeness risk. 2. Phase data migration and early procurement cycles. 3. Primary ownership data-led. 4. Supporting data team.
Why this happens, scenario analysis and root cause.
Material master views define which processes a material can participate in. 1. Some materials in ECC lacked fully maintained purchasing views. 2. Legacy processes bypass strict view validation. 3. Migration enforces tighter integration across organizational levels. 4. Data migration templates failed to populate all required fields. View completeness becomes operationally mandatory in S/4HANA.
Why this is a migration-exclusive failure.
ECC systems often allowed partial master data maintenance. 1. Incomplete views did not always block procurement in ECC. 2. S/4HANA integrates material views more tightly with transaction logic. 3. Transformation activates stricter validation sequences. 4. Data gaps surface immediately once real POs are created. Migration exposes hidden master data incompleteness.
Ownership, who actually fixes it.
Although procurement experiences the block, resolution is master data-driven. 1. data-led reviews and maintains missing purchasing views. 2. Data team validates migration completeness and field mapping. 3. Procurement confirms operational requirements per plant and purchasing organization. 4. ABAP adjusts custom validation logic if misaligned.
Who gets blamed versus who owns it.
When buyers are blocked, pressure escalates quickly. 1. Blamed procurement for incorrect PO creation. 2. Blamed data migration team for incomplete loads. 3. Actual owner material master governance and view maintenance discipline. 4. Root cause historical tolerance of incomplete views in ECC.
How this is actually fixed, the right way by a role.
Resolution requires structured master data validation. 1. Performs view completeness analysis per plant and purchasing organization. 2. Data team corrects migration templates and reloads missing fields. 3. Procurement validates operational configuration alignment. 4. Regression testing confirms successful PO creation across scenarios.
What not to do, common wrong fixes.
Temporary overrides create long-term inconsistency. 1. Granting emergency authorizations to bypass validation. 2. Manually creating views without governance review. 3. Ignoring plant-specific configuration differences. 4. Treating missing views as isolated incidents. Master data completeness must be systemic, not reactive.
Follow-up 1. Why were these materials usable in ECC?
Answer: because ECC often allowed partial view maintenance depending on transaction context. S/4HANA enforces stricter cross-view integration, making incomplete materials immediately visible.
Follow-up 2. How can teams detect missing views before go live?
Answer: by running material completeness reports across all plants and purchasing organizations. Data validation scripts should confirm mandatory view presence before cut-over approval.
Follow-up 3. Curveball. Why is missing view governance a systemic risk?
Answer: because incomplete master data signals weak control over procurement lifecycle. What begins as a missing view can cascade into pricing errors, valuation gaps, and reporting inconsistencies.
Exclusive pro tip.
Before go live, validate that every active material supports every required business process view.
Scenario 28. Source determination behaves differently after migration.
After S/4HANA migration, automatic source determination during purchase requisition or purchase order creation behaves inconsistently. The system selects unexpected vendors, ignores valid source list entries, or fails to propose contracts. What appears to be a configuration defect is often a shift in how S/4HANA prioritizes source determination logic.
Scenario classification.
1. Complexity, high procurement governance risk. 2. Phase, configuration validation and post-go-live procurement cycles. 3. Primary ownership, cross-module. 4. Supporting SD.
Why this happens, scenario analysis and root cause.
Source determination integrates source lists, quota arrangements, contracts, and info records. 1. S/4HANA optimizes source determination logic and prioritization rules. 2. Legacy source lists were inconsistently maintained in ECC. 3. Quota arrangements and validity periods may overlap incorrectly. 4. Business partner conversion impacts vendor source linkage. Procurement logic becomes stricter and more transparent under S/4HANA.
Why this is a migration-exclusive failure.
ECC allowed loosely governed source determination configurations. 1. Overlapping or expired source lists often remained unnoticed. 2. Business partner migration modifies vendor identification logic. 3. S/4HANA enforces tighter integration between master data and sourcing rules. 4. Inconsistencies surface when automatic sourcing is executed in production. Migration exposes procurement rule fragmentation.
Ownership, who actually fixes it.
Although sourcing feels operational, resolution requires structured governance review. 1. cross-module lead reviews source list, quota, and contract configuration. 2. SD validates intercompany sourcing dependencies. 3. Data team cleanses vendor and source master inconsistencies. 4. ABAP reviews custom source determination exits if implemented.
Who gets blamed versus who owns it.
When wrong vendors are selected, procurement frustration rises quickly. 1. Blamed buyers for incorrect manual override. 2. Blamed SD for contract misalignment. 3. Actual owner source determination configuration discipline. 4. Root cause legacy inconsistencies exposed by stricter logic enforcement.
How this is actually fixed, the right way by a role.
Stabilization requires rationalization of sourcing governance. 1. Audits and rationalizes source lists and quota arrangements. 2. Vendor BP alignment is validated post-conversion. 3. Contract validity and priority logic are reviewed. 4. End-to-end PR to PO automation testing is executed.
What not to do, common wrong fixes.
Temporary overrides create sourcing chaos. 1. Disabling source determination logic entirely. 2. Manually overriding vendors without root cause analysis. 3. Ignoring quota and validity conflicts. 4. Creating duplicate info records to bypass logic. Source determination must be predictable and governed.
Follow-up 1. Why are expired source lists suddenly causing issues?
Answer: because S/4HANA enforces validity periods more consistently across sourcing logic. Legacy entries that were never cleaned in ECC now conflict with automatic determination rules.
Follow-up 2. How can teams prevent sourcing instability?
Answer: by running source list consistency checks and quota validation before go live. Automated sourcing scenarios should be tested under real business volumes.
Follow-up 3. Curveball. Why do sourcing issues impact financial performance indirectly?
Answer: because incorrect vendor selection can affect pricing, delivery reliability, and margin performance. Sourcing governance has direct financial implications beyond operational inconvenience.
Exclusive pro tip.
If automatic source determination is critical, validate sourcing discipline before activating full automation in production.
Scenario 29. Batch determination strategy shifts after migration.
After S/4HANA migration, batch determination during sales delivery production order confirmation, or goods issue behaves differently. The system selects unexpected batches or fails to propose any batch at all. Transactions complete technically, but operational planning and fulfillment stability begin to erode.
Scenario classification.
1. Complexity, high fulfillment and production risk. 2. Phase, post-conversion execution and cross-module validation. 3. Primary ownership, cross-module. 4. Supporting SD and PP.
Why this happens, scenario analysis and root cause.
Batch determination integrates classification, strategy types, and movement logic. 1. S/4HANA enforces tighter integration between batch classification and strategy records. 2. Legacy batch determination sequences relied on outdated condition techniques. 3. Material ledger and valuation integration influence batch prioritization. 4. Custom exits tied to ECC batch tables may not trigger correctly. Batch selection logic becomes more structured and less forgiving under S/4HANA.
Why this is a migration-exclusive failure.
ECC often tolerated loosely maintained batch strategy conditions. 1. Batch search strategies were inconsistently maintained in legacy systems. 2. S/4HANA integrates batch determination across modules more tightly. 3. Migration activates stricter classification and dependency validation. 4. Differences appear only during real cross-module execution scenarios. Transformation exposes weak batch governance discipline.
Ownership, who actually fixes it.
Batch determination spans logistics, sales, and production integration. 1. cross-module lead reviews batch search strategy and classification. 2. SD validates delivery-level batch determination logic. 3. PP confirms production order batch assignment rules. 4. ABAP reviews custom batch exits and enhancements.
Who gets blamed versus who owns it.
When wrong batches are selected, operational friction escalates quickly. 1. Blamed warehouse for incorrect picking. 2. Blamed SD for delivery misalignment. 3. Actual owner batch strategy configuration and classification governance. 4. Root cause insufficient cross-module batch scenario testing.
How this is actually fixed, the right way by a role.
Stabilization requires end-to-end batch scenario validation. 1. Reviews and rationalizes batch search strategies. 2. Classification characteristics are validated across plants. 3. SD and PP execute integrated fulfillment simulations. 4. Batch determination logs are analyzed for selection logic transparency.
What not to do, common wrong fixes.
Operational workarounds create hidden traceability risks. 1. Manually overriding batch selection repeatedly. 2. Disabling automatic batch determination entirely. 3. Adjusting strategy types without cross-module review. 4. Ignoring classification completeness issues. Batch determination instability directly impacts service level and compliance.
Follow-up 1. Why does batch determination fail only in certain plants?
Answer: because batch strategy records and classification characteristics may vary by plant. Inconsistent configuration across organizational units becomes visible only when integrated transactions execute.
Follow-up 2. How can teams stabilize batch determination before go live?
Answer: by running integrated sales, production, and warehouse simulations using real migrated batch data. Batch selection logs should be analyzed to confirm strategy execution order.
Follow-up 3. Curveball. Why are batch strategy issues often underestimated?
Answer: because batch logic feels operational and tactical. In reality, it directly affects customer delivery reliability, production scheduling, and regulatory traceability.
Exclusive pro tip.
If batch determination is active, validate cross-module scenarios, not just configuration, before declaring migration complete.
Category 5 wrap-up. Master data is architectural control.
Material master is not operational detail, it is structural governance. Field extensions, sourcing logic, and batch strategy shifts reveal how deeply master data influences financial and operational stability. Migration forces organizations to confront master data discipline that ECC quietly tolerated.
Transition from material governance to identity transformation.
If material master defines what you buy and produce, business partner defines who you transact with. Vendor-to-business partner conversion is not a technical table migration. It is identity restructuring across procurement, finance, and integration.
Category 6, Business Partner Conversion, Vendor to BP.
S/4HANA replaces classic vendor master with the unified business partner model. Purchasing roles, company code roles, partner functions, and output logic now depend on BP completeness. Migration exposes inconsistencies that ECC's vendor model allowed to persist.
Scenarios covered in Category 6.
Scenario 30, vendor mapping mismatch during BP conversion. Primary owner MM data-led supporting data team. Scenario 31, purchasing role missing in business partner. Primary owner MM-led supporting FI. Scenario 32, partner functions missing after conversion. Primary owner MM cross-module supporting SD. Scenario 33, output determination fails due to BP role issues. Primary owner MM cross-module supporting basis. Scenario 34, open purchase orders reference obsolete vendor numbers. Primary owner MM data-led supporting data team. Scenario 35, vendor evaluation data not migrated. Primary owner MM data-led supporting data team.
Scenario 30, Vendor mapping mismatch during BP conversion.
During business partner conversion, vendor numbers are mapped to BP numbers using CVI synchronization. After migration, certain vendors appear duplicated, misaligned, or incorrectly linked to company codes. Procurement transactions fail, and finance reports inconsistent balances. What appears to be a synchronization glitch is often a data mapping governance failure.
Scenario classification.
1. Complexity, critical identity, and financial reconciliation risk. 2. Phase, data migration and CVI synchronization. 3. Primary ownership, MM data-led. 4. Supporting data team.
Why this happens, scenario analysis and root cause.
Vendor-to-business partner conversion relies on customer-vendor integration synchronization. 1. Legacy vendor records contain inconsistent number ranges. 2. Duplicate vendor master data exists across company codes. 3. CVI mapping tables are misconfigured or partially maintained. 4. Data cleansing was incomplete before synchronization execution. Identity conflicts surface only when vendor and BP objects merge.
Why this is a migration-exclusive failure.
ECC maintained vendor identity separately from customer or contact structures. 1. Vendor master allowed fragmented records across company codes. 2. S/4HANA unifies identity into a single business partner object. 3. Migration forces one-to-one identity consolidation. 4. Historical duplication becomes structurally incompatible. Transformation converts fragmented identities into unified governance objects.
Ownership, who actually fixes it.
Although CVI is technical, data integrity ownership sits with master governance. 1. MM data-led reviews vendor master consistency and mapping alignment. 2. Data team cleanses duplicates and validates number range mapping. 3. FI confirms company code and reconciliation account linkage. 4. ABAP validates CVI configuration tables if required.
Who gets blamed versus who owns it.
When vendor identity fails, tension rises immediately. 1. Blame data migration team for incorrect loads. 2. Blamed basis for CVI execution instability. 3. Actual owner, vendor master governance and pre-conversion cleansing discipline. 4. Root cause, historical duplication tolerated in ECC.
How this is actually fixed, the right way by a role.
Stabilization requires identity rationalization before synchronization. 1. MM performs vendor master deduplication across company codes. 2. Data team aligns number ranges and mapping rules. 3. CVI is rerun in controlled test environments. 4. Financial reconciliation validates vendor to BP alignment.
What not to do, common wrong fixes.
Identity shortcuts create long-term structural instability. 1. Manually merging BP records in production. 2. Ignoring duplicate vendor warnings. 3. Altering number ranges without cross-checking finance impact. 4. Bypassing CVI validation logs. Identity integrity must be established before synchronization.
Follow-up 1. Why do duplicate vendors become critical only during BP conversion?
Answer: because ECC allowed multiple vendor records with minimal structural consolidation. S/4HANA requires unified identity under business partner, forcing duplicates to conflict at object level.
Follow-up 2. How can teams detect mapping risks early?
Answer: by running vendor consistency reports and analyzing number range overlaps months before conversion. Early CV/I test cycles significantly reduce production risk.
Follow-up 3. Curveball. Why is BP conversion considered an identity transformation rather than a master data migration?
Answer: because it restructures how business relationships are represented system-wide. Vendors, customers, and contacts merge into a unified governance object, altering both technical and organizational accountability.
Exclusive pro tip.
Run at least 2 full CV/I simulation cycles before final cutover to eliminate identity surprises.
Scenario 31. Purchasing role missing in business partner.
After conversion, purchase order creation fails with errors indicating that the vendor is not assigned to the purchasing organization. The business partner exists and finance postings may work, but procurement transactions are blocked. The root issue is incomplete BP role assignment during conversion.
Scenario classification.
1. Complexity, high procurement blocking risk. 2. Phase, data migration and early procurement execution. 3. Primary ownership, MM configuration led. 4. Supporting FI.
Why this happens, scenario analysis and root cause.
Business partner roles define which transactions an entity can participate in. 1. Vendor to BP conversion did not activate the FLVN01 purchasing role. 2. Purchasing organization assignments were not migrated correctly. 3. CV/I synchronization completed technically but role data was incomplete. 4. Legacy vendor records had inconsistent organizational assignments. A BP without the correct role is structurally incomplete.
Why this is a migration-exclusive failure.
ECC vendor master stored purchasing and finance data separately but less rigidly. 1. ECC allowed partial organizational views without strict enforcement. 2. S/4HANA centralizes vendor identity under business partner roles. 3. Role-based architecture enforces transactional eligibility. 4. Incomplete role migration blocks operational processes immediately. Migration transforms vendor eligibility into explicit role governance.
Ownership, who actually fixes it.
Although procurement experiences the failure, resolution is master role configuration driven. 1. MM configuration led, reviews BP role configuration and purchasing assignments. 2. FI validates company code role alignment and reconciliation accounts. 3. Data team ensures migration templates populate purchasing views correctly. 4. ABAP reviews custom validation logic if roles are not recognized.
Who gets blamed versus who owns it.
When buyers are blocked, operational frustration escalates quickly. 1. Blamed procurement for incorrect PO setup. 2. Blamed data migration team for incomplete loads. 3. Actual owner BP role configuration and migration completeness validation. 4. Root cause, organizational view governance gaps in ECC.
How this is actually fixed, the right way by a role.
Stabilization requires structural role validation across all vendors. 1. MM activates and assigns required purchasing roles in BP configuration. 2. Purchasing organization assignments are validated for all active vendors. 3. Data team reloads incomplete organizational views if necessary. 4. End-to-end procurement testing confirms transactional eligibility.
What not to do, common wrong fixes.
Temporary overrides hide structural incompleteness. 1. Manually editing BP roles in production without governance review. 2. Granting emergency authorizations to bypass checks. 3. Ignoring purchasing organization inconsistencies. 4. Fixing only the vendor that triggered the error. Role completeness must be systemic, not reactive.
Follow-up 1. Why can finance postings still work if purchasing role is missing?
Answer: because business partner roles are modular. The company code role may be active, allowing FI transactions, while the purchasing role is missing. Each role governs different transactional capabilities.
Follow-up 2. How can teams detect missing roles before go live?
Answer: by running BP role completeness reports and validating purchasing organization assignments across all active vendors. Role simulation tests should be executed before production cut over.
Follow-up 3. Curveball. Why is role governance more critical in S/4HANA than ECC?
Answer: because S/4HANA's architecture is role-based and object-centric. Transaction eligibility depends on structured role assignments, not loosely connected master views.
Exclusive pro tip.
Before go live, validate that every active vendor has both finance and purchasing BP roles assigned and tested end-to-end.
Scenario 32. Partner functions missing after conversion.
After S/4HANA migration, purchase orders fail validation or default incorrect partner functions. In some cases, goods receipt or invoice verification processes reference incomplete partner assignments. The business partner exists, but critical partner functions such as ordering address or invoicing party are missing or misaligned.
Scenario classification.
1. Complexity, high transaction integrity risk. 2. Phase, data migration and procurement execution. 3. Primary ownership, MM cross-module. 4. Supporting SD.
Why this happens, scenario analysis and root cause.
Partner functions define transactional responsibility and communication flow. 1. Legacy vendor partner functions were inconsistently maintained. 2. CVI conversion did not fully map partner functions to BP roles. 3. Organizational assignments differ between company code and purchasing views. 4. Custom logic referenced obsolete partner function tables. Partner functions are identity extensions, not optional fields.
Why this is a migration-exclusive failure.
ECC tolerated incomplete or redundant partner assignments. 1. Vendor partner functions were stored separately in ECC. 2. S/4HANA consolidates relationships under the BP framework. 3. Role-based processing enforces stricter partner validation. 4. Conversion exposes inconsistencies across organizational levels. Transformation turns loosely defined relationships into governed structures.
Ownership, who actually fixes it.
Although procurement feels the impact, resolution requires relationship governance review. 1. MM cross-module lead reviews and configures partner determination procedures. 2. SD validates cross-functional partner function consistency. 3. Data team ensures migration completeness for partner assignments. 4. ABAP reviews custom enhancements tied to partner function tables.
Who gets blamed versus who owns it.
When transactional partners fail, operational trust declines rapidly. 1. Blamed buyers for incorrect partner selection. 2. Blamed SD for partner determination misconfiguration. 3. Actual owner master partner function governance during conversion. 4. Root cause historical inconsistency in vendor relationship maintenance.
How this is actually fixed, the right way by a role.
Stabilization requires harmonizing partner governance rules. 1. MM reviews and standardizes partner determination procedures. 2. Data team reloads or corrects missing partner assignments. 3. Cross-module validation confirms procurement and SD consistency. 4. Integrated PO to invoice simulations verify partner flows.
What not to do, common wrong fixes.
Ad hoc adjustments create relationship chaos. 1. Manually inserting partner functions in production without governance. 2. Ignoring mismatched organizational levels. 3. Disabling partner validation checks. 4. Fixing only transactional symptoms instead of master data. Partner governance must be systematic and consistent.
Follow-up 1. Why do partner function errors appear only in certain POs?
Answer: because partner determination can vary by purchasing organization, company code, or document type. Inconsistent migration across these dimensions exposes errors only under specific transactional conditions.
Follow-up 2. How can teams validate partner consistency before go live?
Answer: by running partner completeness checks across all vendor records and executing integrated test cases that simulate procurement, goods receipt, and invoice verification.
Follow-up 3. Curveball. Why are partner functions considered high governance objects?
Answer: because they define who is legally and operationally responsible for transactions. Incorrect partner assignments can affect compliance, tax reporting, and contractual obligations.
Exclusive pro tip.
Before go live, execute at least one end-to-end procurement cycle per vendor category to validate partner determination accuracy.
Scenario 33. Output determination fails due to business partner role issues.
After migration, purchase orders are created successfully, but output such as email or EDI transmission fails. The document appears correct in the system, yet no message is triggered. The issue is not output configuration alone. It is often incomplete or misaligned business partner communication role data.
Scenario classification.
1. Complexity, high communication and compliance risk. 2. Phase, configuration validation and post-go-live monitoring. 3. Primary ownership cross-module. 4. Supporting basis.
Why this happens, scenario analysis and root cause.
Output determination in S/4HANA depends on business partner communication data and roles. 1. BP communication roles were not fully migrated. 2. Email or EDI details are stored under BP relationship layers. 3. BRF plus output determination requires correct BP master completeness. 4. Legacy and ST-based logic assumptions were not redesigned. Output is governed by identity and communication structure, not just configuration.
Why this is a migration-exclusive failure.
ECC stored communication data more loosely within vendor master. 1. ST-based output tolerated incomplete communication records. 2. S/4HANA integrates output with BP roles and BRF plus logic. 3. Role-based communication must be structurally complete. 4. Transformation enforces stricter communication validation. Migration turns messaging from procedural to governed logic.
Ownership, who actually fixes it.
Although output failure feels technical, identity data is often the root cause. 1. Cross-module lead reviews BP communication role assignments. 2. Basis validates output channels, email configuration, and connectivity. 3. Data team ensures communication data completeness. 4. ABAP reviews BRF plus or custom output enhancements if implemented.
Who gets blamed versus who owns it.
When vendors do not receive documents, escalation is immediate. 1. Blamed basis for email or EDI failure. 2. Blamed SAP for new output framework complexity. 3. Actual owner, BP communication role governance and migration completeness. 4. Root cause, incomplete identity communication restructuring.
How this is actually fixed, the right way by a role.
Stabilization requires harmonizing communication governance with output configuration. 1. Validates BP communication roles and contact assignments. 2. Basis confirms technical output channel configuration. 3. BRF plus rules are tested with real BP data. 4. End-to-end PO output simulation confirms delivery.
What not to do, common wrong fixes.
Workarounds create messaging inconsistency. 1. Hard-coding email addresses in output configuration. 2. Disabling BRF plus validation checks. 3. Manually sending documents outside the system. 4. Ignoring missing BP communication role warnings. Output integrity depends on identity integrity.
Follow-up 1. Why does the PO save successfully but output fails?
Answer: because transactional validation and communication validation are separate layers. The PO structure may be complete, but output determination depends on BP communication roles and BRF plus rules.
Follow-up 2. How can teams proactively detect communication gaps?
Answer: by executing output simulation tests across vendor categories and validating BP contact role completeness before go live.
Follow-up 3. Curveball. Why is output governance considered a compliance risk?
Answer: because missing or incorrect communication can impact contractual obligations, legal documentation, and audit traceability.
Exclusive pro tip.
Never validate output configuration without validating business partner communication roles simultaneously.
Scenario 34. Open purchase orders reference obsolete vendor numbers.
After migration, open purchase orders created in ECC reference vendor numbers that no longer align cleanly with the new business partner structure. Some POs cannot be changed. Others fail during goods receipt or invoice posting. The issue is not transactional logic. It is historical document identity dependency.
Scenario classification.
1. Complexity, critical open transaction integrity risk. 2. Phase, cutover and early post-go-live stabilization. 3. Primary ownership data-led. 4. Supporting data team.
Why this happens, scenario analysis and root cause.
Open documents carry historical master data references. 1. Open POs were created using legacy vendor numbers in ECC. 2. BP conversion changed identity mapping or number ranges. 3. CV synchronization did not fully align historical document references. 4. Some vendors were merged or deactivated during cleansing. Historical documents bind tightly to original identity keys.
Why this is a migration-exclusive failure.
ECC did not require identity consolidation across objects. 1. Vendor numbers were primary keys in legacy documents. 2. S/4HANA unifies identity under business partner. 3. Migration may alter number range assignments. 4. Historical transactions expose mapping inconsistencies. Transformation changes identity structure, not historical dependency logic.
Ownership, who actually fixes it.
Open document remediation requires structured cut-over governance. 1. MM Data-led reviews open PO vendor references and mapping alignment. 2. Data team validates CV synchronization for active documents. 3. FI confirms reconciliation impact for open commitments. 4. ABAP supports correction programs if required.
Who gets blamed versus who owns it.
When open POs fail, escalation is immediate. 1. Blamed procurement for document creation timing. 2. Blamed data team for incorrect migration mapping. 3. Actual owner cutover planning and identity alignment strategy. 4. Root cause insufficient open document reconciliation before go live.
How this is actually fixed, the right way by a role.
Stabilization requires structured open document validation. 1. MM performs open PO reconciliation before and after conversion. 2. Data team validates vendor to BP mapping for active transactions. 3. Correction programs are executed in controlled environments. 4. Cutover plans include freeze windows for vendor master changes.
What not to do, common wrong fixes.
Quick manual adjustments create financial exposure. 1. Manually editing open PO vendor numbers in production. 2. Deleting and recreating large volumes of open POs without analysis. 3. Ignoring reconciliation mismatches between MM and FI. 4. Assuming CV automatically resolves historical references. Open documents must be reconciled before identity restructuring.
Follow-up 1. Why do some open POs work while others fail?
Answer: because vendor identity alignment may vary across company codes or purchasing organizations. Some documents map correctly through CVI, while others expose inconsistencies in historical vendor governance.
Follow-up 2. How can teams reduce open document risk during cutover?
Answer: by minimizing open procurement transactions before migration and performing detailed vendor reconciliation audits during dress rehearsal cycles.
Follow-up 3. Curveball. Why are open POs more sensitive than closed documents?
Answer: because open documents participate in future goods receipts and financial postings. Identity mismatches directly impact accounting commitments and vendor balances.
Exclusive pro tip.
Before go live, reconcile every open purchase order against business partner mapping to eliminate post-conversion surprises.
Scenario 35. Vendor evaluation data not migrated correctly.
After migration, procurement reports show that vendor evaluation scores are missing, reset, or inconsistent. Buyers lose historical performance metrics, and sourcing decisions lack transparency. The issue is not transactional. It is the loss or misalignment of historical evaluation data during conversion.
Scenario classification.
1. Complexity, medium strategic procurement risk. 2. Phase, data migration and post-go-live analytics validation. 3. Primary ownership, MM data-led. 4. Supporting data team.
Why this happens, scenario analysis and root cause.
Vendor evaluation data depends on historical purchasing transactions and configuration parameters. 1. Evaluation scores were stored in ECC-specific structures. 2. Data migration templates did not include evaluation history. 3. BP conversion altered vendor identification references. 4. Custom evaluation enhancements were not adapted to S4 data model. Historical performance metrics require explicit migration planning.
Why this is a migration-exclusive failure.
ECC stored evaluation data independently of BP identity structure. 1. Vendor evaluation relied on classic vendor master keys. 2. S/4HANA restructures vendor identity under business partner. 3. Historical evaluation data may not map automatically. 4. Transformation changes how identity-linked analytics behave. Migration can silently disconnect historical analytics from current identity.
Ownership, who actually fixes it.
Although it feels analytical, evaluation integrity depends on master data governance. 1. Data-led defines required evaluation history scope. 2. Data team validates migration inclusion of evaluation tables. 3. FI confirms impact on financial performance metrics if linked. 4. ABAP adjusts custom evaluation logic to S4 structure.
Who gets blamed versus who owns it.
When historical performance disappears, trust erodes quickly. 1. Blamed data team for incomplete migration. 2. Blamed SAP for structural redesign. 3. Actual owner, migration scope definition and analytics preservation strategy. 4. Root cause, underestimating historical data dependencies.
How this is actually fixed. The right way by a role.
Recovery requires controlled historical data alignment. 1. Defines evaluation criteria and historical retention requirements. 2. Data team reloads or reconstructs evaluation records if feasible. 3. Custom enhancements are adapted to BP-based identity. 4. Analytics reconciliation confirms restored performance metrics.
What not to do, common wrong fixes.
Short-term fixes distort procurement analytics. 1. Manually resetting evaluation scores without traceability. 2. Ignoring missing history and starting fresh without stakeholder approval. 3. Rebuilding metrics using inconsistent calculation logic. 4. Assuming evaluation is low priority compared to transactions. Historical analytics shape strategic sourcing decisions.
Follow-up 1. Why does vendor evaluation loss matter if transactions still work?
Answer: because procurement decisions rely on historical performance indicators. Losing evaluation history weakens sourcing governance and supplier risk assessment.
Follow-up 2. How can teams protect evaluation data during migration?
Answer: by explicitly including evaluation tables in migration scope and validating post-conversion analytics against ECC historical benchmarks.
Follow-up 3. Curveball. Why is vendor evaluation considered a governance control rather than a reporting feature?
Answer: because it influences supplier selection, contract negotiation, and compliance oversight. Inaccurate evaluation data affects long-term procurement strategy.
Exclusive pro tip.
Treat vendor evaluation history as strategic capital, not optional reporting data, during migration planning.
Category 6 wrap-up. Identity is structural power.
Business partner conversion is not a technical checkbox. It restructures vendor identity, roles, communication, and governance across procurement and finance. Organizations that underestimate BP transformation face operational friction long after go-live.
Transition from identity to process behavior.
Once vendors are structurally aligned, the next shock appears inside procurement processes themselves. Release approvals, pricing logic, output behavior, and settlement flows can behave differently in S/4HANA, even if configuration appears identical.
Please check description or comment section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP functional modules interviews jobs like SAP MM Consultant jobs, SAP FICO Consultant jobs, SAP SD Consultant jobs, SAP PP Consultant jobs, SAP Ariba Consultant jobs, SAP Extended Warehouse Management EWM Consultant jobs, SAP Plant Maintenance PM Consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving. Interview questions and answers where almost 80% of the people are failing to answer. System design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Category 7. Procurement Process Behavior Changes.
S/4HANA introduces subtle but critical changes in procurement execution. Release strategies, pricing determination, message control, BRF plus output, and scheduling agreements may operate differently from ECC. These shifts often trigger user resistance because the system no longer behaves as expected.
Scenarios covered in Category 7.
Scenario 36, Release Strategy Logic Changes. Primary owner MM led, supporting workflow. Scenario 37, Pricing conditions behave differently. Primary owner cross-module, supporting SD. Scenario 38, Message types not triggering. Primary owner technical led, supporting ABAP. Scenario 39, Output determination via BRF plus behaves differently. Primary owner cross-module, supporting basis. Scenario 40, Purchase order history behavior changes. Primary owner cross-module, supporting FI. Scenario 41, Consignment settlement logic shifts. Primary owner cross-module, supporting FI. Scenario 42, Scheduling agreement processing shifts. Primary owner cross-module, supporting SD.
Scenario 36. Release strategy logic changes after migration.
After S/4HANA migration, purchase requisitions or purchase orders follow unexpected approval paths. Some documents skip required approvals, while others are blocked unnecessarily. The configuration appears unchanged, yet workflow behavior differs from ECC.
Scenario classification.
1. Complexity, high governance and compliance risk. 2. Phase, configuration validation and early post-go-live execution. 3. Primary ownership led. 4. Supporting workflow.
Why this happens, scenario analysis and root cause.
Release strategies depend on classification, workflow, and field-level triggers. 1. S/4HANA introduces flexible workflow replacing classic release strategies in many cases. 2. Field catalog or classification values differ from ECC. 3. Business partner or organizational changes alter release triggers. 4. Workflow configuration was transported but not fully validated. Approval logic is sensitive to structural and field-level changes.
Why this is a migration-exclusive failure.
ECC relied on classic release strategy framework. 1. S/4HANA promotes flexible workflow for approval processing. 2. Release triggers depend on updated data structures. 3. Migration alters classification and organizational mappings. 4. Behavior shifts appear only when real approval chains execute. Transformation changes approval architecture, not just configuration values.
Ownership, who actually fixes it.
Approval failures are governance critical and require structured validation. 1. led, reviews release strategy or flexible workflow configuration. 2. Workflow team validates approval routing logic. 3. ABAP reviews custom release exits if implemented. 4. FI confirms approval thresholds linked to financial limits.
Who gets blamed versus who owns it.
When approvals misfire, escalation reaches management immediately. 1. Blamed workflow for routing failures. 2. Blamed buyers for incorrect document values. 3. Actual owner, release strategy design alignment with S/4 architecture. 4. Root cause, approval framework shift not fully simulated before go live.
How this is actually fixed. The right way by a role.
Stabilization requires controlled workflow simulation and threshold validation. 1. reviews release classification and field triggers. 2. Workflow team tests flexible workflow routing across scenarios. 3. Approval thresholds are validated against financial governance policies. 4. End-to-end simulation confirms approval predictability.
What not to do, common wrong fixes.
Quick fixes undermine approval governance. 1. Disabling approval checks to unblock transactions. 2. Raising thresholds temporarily without analysis. 3. Hard-coding workflow routing logic. 4. Ignoring classification inconsistencies. Approval integrity protects financial control.
Follow-up 1. Why do approvals skip certain levels after migration?
Answer: because field triggers or classification values may differ in S/4HANA. Even small structural differences can change how approval conditions are evaluated.
Follow-up 2. How can teams prevent approval surprises?
Answer: by running parallel approval simulations in test environments and validating threshold behavior against real procurement scenarios.
Follow-up 3. Curveball. Why is release strategy redesign often underestimated?
Answer: because approvals appear procedural. In reality, they encode financial governance and risk tolerance policies that must align with updated architecture.
Exclusive pro tip.
If your organization is adopting flexible workflow, treat approval simulation as a separate project workstream.
Scenario 37. Pricing conditions behave differently after migration.
After S/4HANA migration, purchase orders calculate prices differently than in ECC. Discounts are missing, freight conditions are not applied, or net price values differ unexpectedly. Configuration appears identical, yet pricing behavior produces reconciliation disputes.
Scenario classification.
1. Complexity, high financial and contractual risk. 2. Phase, configuration validation and procurement execution. 3. Primary ownership, MM cross-module. 4. Supporting SD.
Why this happens, scenario analysis and root cause.
Pricing determination depends on condition technique, master data, and document context. 1. Condition records were not fully migrated or validated. 2. Access sequences behave differently due to field structure changes. 3. Business partner conversion altered vendor pricing keys. 4. Custom pricing exits were not adapted to S/4 data structures. Pricing logic is highly sensitive to structural and master data changes.
Why this is a migration-exclusive failure.
ECC pricing relied on legacy condition access paths and vendor keys. 1. S/4HANA modifies certain data fields used in condition determination. 2. Business partner restructuring impacts pricing key combinations. 3. Migration may exclude historical condition records. 4. Transformation changes evaluation order subtly but critically. Small structural shifts create large financial discrepancies.
Ownership, who actually fixes it.
Pricing integrity spans procurement and financial governance. 1. MM cross-module lead reviews pricing schema and access sequences. 2. SD validates cross-module condition logic consistency. 3. FI confirms accounting impact of pricing differences. 4. ABAP reviews custom pricing routines or user exits.
Who gets blamed versus who owns it.
When prices change unexpectedly, escalation is immediate. 1. Blamed buyers for incorrect condition entry. 2. Blamed SAP for pricing engine differences. 3. Actual owner pricing configuration alignment and master data validation. 4. Root cause, incomplete condition migration and key mapping review.
How this is actually fixed, the right way by a role.
Stabilization requires pricing simulation under real business conditions. 1. MM validates pricing schema and condition records post-migration. 2. Access sequence behavior is tested across vendor categories. 3. FI confirms valuation and tax impact. 4. Custom pricing routines are adapted to S/4 structures.
What not to do, common wrong fixes.
Temporary overrides distort financial transparency. 1. Manually adjusting PO prices without root cause analysis. 2. Disabling pricing conditions to simplify behavior. 3. Copying condition records blindly from ECC. 4. Ignoring cross-module pricing dependencies. Pricing integrity directly impacts financial accuracy.
Follow-up 1. Why do pricing differences appear only for certain vendors?
Answer: because condition records and access keys may vary by vendor group, purchasing organization, or material type. Incomplete migration affects only specific key combinations.
Follow-up 2. How can teams validate pricing stability before go live?
Answer: by executing controlled pricing simulations using real contract data and comparing ECC versus S4 calculation outputs.
Follow-up 3, curveball. Why are pricing discrepancies often discovered late?
Answer: because testing focuses on transactional flow, not financial reconciliation depth. Subtle condition differences may surface only during invoice verification or audit review.
Exclusive pro tip.
Always compare net price and condition breakdown between ECC and S4 for high-volume vendors before approving go live.
Scenario 38. Message types not triggering after migration.
After migration, purchase orders are created successfully, but expected message types are not triggered. Emails are not sent, EDI is not initiated, and print outputs remain pending. Configuration appears identical to ECC, yet message determination behaves differently in S/4HANA.
Scenario classification.
1. Complexity, medium to high communication and operational risk. 2. Phase, configuration validation and post-go-live stabilization. 3. Primary ownership, MM technical-led. 4. Supporting ABAP.
Why this happens, scenario analysis and root cause.
Message determination depends on condition technique and output control. 1. In a ST-based output logic behaves differently under S/4HANA architecture. 2. Condition records were not migrated or revalidated correctly. 3. Business partner conversion altered communication keys. 4. Custom message determination exits were not adapted. Message triggering depends on structural and master data alignment.
Why this is a migration-exclusive failure.
ECC tolerated loosely structured output logic. 1. S/4HANA gradually replaces classic output with BRF plus framework. 2. Data model adjustments impact condition access paths. 3. Transformation changes evaluation sequence subtly. 4. Message logic differences appear only in real execution. Migration exposes fragile message determination design.
Ownership, who actually fixes it.
Although output seems technical, governance and configuration are central. 1. MM technical-led reviews message condition records and schema. 2. ABAP validates custom message determination logic. 3. Basis confirms output channels and communication setup. 4. Data team ensures communication master data completeness.
Who gets blamed versus who owns it.
When suppliers do not receive POs, pressure escalates immediately. 1. Blamed basis for email or EDI configuration issues. 2. Blamed SAP for output framework redesign. 3. Actual owner message determination configuration validation. 4. Root cause, condition, and key alignment gaps post-migration.
How this is actually fixed, the right way by a role.
Stabilization requires controlled output simulation. 1. MM validates message schema and condition records. 2. Output determination is tested across document types. 3. ABAP reviews custom enhancements tied to message control. 4. End-to-end communication testing confirms delivery.
What not to do, common wrong fixes.
Temporary overrides hide structural weaknesses. 1. Hard-coding output recipients. 2. Manually triggering messages outside standard logic. 3. Copying condition records without key review. 4. Ignoring incomplete communication master data. Output reliability depends on disciplined configuration.
Follow-up 1. Why do some message types trigger while others do not?
Answer: because message determination depends on specific key combinations such as document type, vendor, and purchasing organization. Missing or mismatched condition records impact only certain scenarios.
Follow-up 2. How can teams proactively detect output gaps?
Answer: by executing structured output simulations for each purchasing document type and validating communication logs before go live.
Exclusive pro tip.
Treat output simulation as mandatory validation during procurement migration testing.
Scenario 39. Output determination via BRF Plus behaves differently.
After migration, organizations that activate BRF Plus for procurement output notice different behavior compared to classic message control. Certain document types do not trigger output, rule evaluation seems inconsistent, and fallback logic behaves unpredictably. The issue is not configuration alone, It is a framework shift.
Scenario classification.
1. Complexity, high framework and governance shift. 2. Phase, configuration, redesign, and post-go-live monitoring. 3. Primary ownership, MM cross-module. 4. Supporting basis.
Why this happens, scenario analysis and root cause.
BRF Plus replaces procedural message control with rule-based evaluation. 1. Classic NAST logic differs fundamentally from BRF Plus decision tables. 2. BRF Plus rule sets were not fully aligned with legacy condition logic. 3. Master data fields used in rules changed during migration. 4. Fallback or default rules were not properly defined. Rule-based frameworks require explicit governance design.
Why this is a migration-exclusive failure.
ECC relied primarily on classic output determination mechanisms. 1. S/4HANA promotes BRF Plus as the strategic output framework. 2. Rule-based processing changes evaluation transparency. 3. Migration may combine legacy and new logic unintentionally. 4. Framework shifts create behavior differences without visible errors. Transformation replaces procedural logic with decision governance.
Ownership, who actually fixes it.
BRF Plus output governance spans configuration and rule design. 1. MM cross-module lead designs and validates BRF Plus decision tables. 2. Basis confirms technical activation and transport consistency. 3. ABAP reviews custom enhancements or rule exits. 4. Data team ensures rule key fields are consistently populated.
Who gets blamed versus who owns it.
When output behaves unpredictably, confusion escalates quickly. 1. Blamed SAP for new framework complexity. 2. Blamed basis for activation inconsistencies. 3. Actual owner, BRF Plus rule design and validation governance. 4. Root cause, incomplete translation of legacy message logic into rule tables.
How this is actually fixed, the right way by a role.
Stabilization requires structured rule simulation and validation. 1. MM reviews and simplifies BRF Plus decision tables. 2. Rule conditions are aligned with real master data fields. 3. Fallback logic is explicitly defined. 4. Comprehensive document type simulations validate rule behavior.
What not to do, common wrong fixes.
Framework confusion invites risky shortcuts. 1. Reactivating classic message control without impact analysis. 2. Duplicating logic across BRF Plus and legacy output. 3. Hard-coding rule exceptions. 4. Ignoring decision table documentation. Rule governance must be deliberate and documented.
Follow-up 1. Why does BRF Plus produce different output results compared to NAST?
Answer: because BRF Plus evaluates rule tables based on defined decision logic, not procedural condition records. Even slight differences in key fields or rule order can alter outcomes significantly.
Follow-up 2. How can teams validate BRF Plus stability before production?
Answer: by executing comprehensive decision table simulations using real document scenarios and comparing outputs against ECC benchmarks.
Follow-up 3. Curveball. Why is BRF Plus governance often underestimated?
Answer: because it appears as configuration rather than architecture. In reality, rule design encodes communication and compliance policy logic.
Exclusive pro tip.
Treat BRF Plus design as decision governance architecture, not just output configuration.
Scenario 40. Purchase order history behavior changes after migration.
After S/4HANA migration, users notice differences in purchase order history. Goods receipts, invoice postings, and subsequent adjustments appear differently or do not reconcile as expected. The PO History tab looks familiar, but financial totals and document flows feel inconsistent compared to ECC.
Scenario classification.
1. Complexity, high financial reconciliation risk. 2. Phase, post-go-live execution and period-end review. 3. Primary ownership, MM cross-module. 4. Supporting FI.
Why this happens, scenario analysis and root cause.
PO History integrates logistics and accounting document flows. 1. S/4HANA uses MATDOC and ACDOC integration for document representation. 2. Historical documents migrated from ECC may reference legacy structures. 3. Subsequent debit and credit postings are represented differently. 4. Material ledger integration influences valuation display. Document flow representation evolves under unified data models.
Why this is a migration-exclusive failure.
ECC stored logistics and accounting history across separate tables. 1. S/4HANA unifies line items under MATDOC and ACDOCA. 2. Compatibility views mask structural changes. 3. Transformation alters how totals are aggregated and displayed. 4. Differences appear during real reconciliation activities. Migration reshapes history visualization without altering transaction validity.
Ownership, who actually fixes it.
Although history appears transactional, reconciliation governance drives resolution. 1. MM cross-module lead reviews document flow and PO history logic. 2. FI validates accounting document alignment and valuation impact. 3. ABAP refactors custom reports reading legacy tables. 4. Data team confirms historical document completeness.
Who gets blamed versus who owns it.
When totals do not align, finance pressure intensifies quickly. 1. Blamed MM for incorrect goods receipt processing. 2. Blamed FI for accounting misalignment. 3. Actual owner, cross-module reconciliation and reporting alignment. 4. Root cause, unified data model interpretation differences.
How this is actually fixed, the right way by a role.
Stabilization requires reconciliation under new semantic structures. 1. MM validates PO history against MATDOC representation. 2. FI reconciles accounting impact via ACDOC comparison. 3. Custom legacy reports are redesigned for S4 structures. 4. Period-end simulation confirms financial alignment.
What not to do, common wrong fixes.
Short-term adjustments undermine reporting trust. 1. Manually adjusting reconciliation totals. 2. Filtering out history entries to match expected numbers. 3. Ignoring material ledger valuation effects. 4. Assuming compatibility views reflect identical semantics. History interpretation must align with unified journal logic.
Follow-up 1. Why do PO history totals differ from ECC even if transactions are correct?
Answer: because S/4HANA aggregates and represents document flows differently using unified journal logic. Structural consolidation changes how totals are calculated and displayed.
Follow-up 2. How can teams validate PO history accuracy?
Answer: by reconciling goods receipts and invoice postings at document level against ACDOCA and MATDOC entries during period-end simulation.
Follow-up 3. Curveball. Why are history display differences dangerous even without financial errors?
Answer: because perception drives trust. If users believe totals are inconsistent, confidence in the system erodes even when accounting is technically correct.
Exclusive pro tip.
Before go live, compare PO history views between ECC and S4 under real GR and IR scenarios.
Scenario 41. Consignment settlement logic shifts after migration.
After S/4HANA migration, consignment settlement behaves differently. Liability postings do not align with goods issue timing, valuation appears inconsistent, or settlement documents reflect unexpected amounts. Transactions complete technically, but financial reconciliation between MM and FI becomes unstable.
Scenario classification.
1. Complexity, high financial and valuation risk. 2. Phase, post-go-live execution and period-end settlement. 3. Primary ownership, MM cross-module. 4. Supporting FI.
Why this happens, scenario analysis and root cause.
Consignment integrates stock ownership, valuation, and settlement posting logic. 1. Material ledger is mandatory in S/4HANA and affects valuation. 2. Settlement timing interacts differently with unified journal postings. 3. Custom valuation logic from ECC was not adapted. 4. Open consignment balances were not reconciled before migration. Settlement accuracy depends on valuation and timing alignment.
Why this is a migration-exclusive failure.
ECC allowed optional material ledger and simpler valuation flows. 1. S/4HANA enforces material ledger activation. 2. Unified journal logic alters valuation posting sequences. 3. Transformation changes timing visibility of liability recognition. 4. Legacy settlement assumptions may no longer hold. Migration introduces valuation transparency and stricter posting integration.
Ownership, who actually fixes it?
Consignment settlement requires coordinated MM and FI validation. 1. MM cross-module lead reviews consignment configuration and settlement parameters. 2. FI validates liability recognition and account determination. 3. CO confirms cost object impact if applicable. 4. Data team reconciles open consignment balances pre-conversion.
Who gets blamed versus who owns it?
When settlement values drift, financial trust is impacted. 1. Blamed MM for incorrect goods movement logic. 2. Blamed FI for accounting misalignment. 3. Actual owner cross-module valuation and settlement configuration alignment. 4. Root cause, material ledger and timing integration not fully simulated.
How this is actually fixed, the right way by a role.
Stabilization requires end-to-end valuation simulation. 1. MM validates consignment stock flows and settlement triggers. 2. FI reconciles liability and inventory postings in ACDOCA. 3. Material ledger configuration is reviewed for valuation impact. 4. Integrated settlement simulation confirms timing accuracy.
What not to do, common wrong fixes.
Financial shortcuts create audit exposure. 1. Manually adjusting settlement postings. 2. Ignoring material ledger influence on valuation. 3. Closing consignment balances without reconciliation. 4. Disabling valuation checks to simplify processing. Consignment valuation must align with unified journal logic.
Follow-up 1. Why does consignment valuation appear different even if stock quantity is correct?
Answer: because S/4HANA integrates valuation through material ledger and unified journal logic. Quantity and value may reconcile differently than in ECC due to posting sequence changes.
Follow-up 2. How can teams prevent settlement surprises?
Answer: by executing controlled consignment lifecycle simulations including goods issue, settlement, and period-end valuation before production cut over.
Follow-up 3. Curveball. Why is consignment settlement considered high audit risk?
Answer: because it affects liability recognition and inventory valuation timing. Misalignment can distort financial statements and supplier balances.
Exclusive pro tip.
Always simulate at least one full consignment cycle, including period-end closing, before declaring S/4 migration stable.
Scenario 42. Scheduling agreement processing shifts after migration.
After migration to S/4HANA, scheduling agreements behave differently. Delivery schedule updates are inconsistent, forecast and JIT releases do not align as expected, and downstream confirmations create unexpected stock or accounting effects. Transactions execute, but planning stability deteriorates.
Scenario classification.
1. Complexity, high planning and inventory stability risk. 2. Phase, post-go-live execution and planning stabilization. 3. Primary ownership, MM cross-module. 4. Supporting SD.
Why this happens, scenario analysis and root cause.
Scheduling agreements integrate planning, logistics, and financial posting. 1. S/4HANA adjusts how delivery schedule lines are stored and processed. 2. Integration with MRP live changes planning sequence timing. 3. Output and release documentation behave differently under new frameworks. 4. Custom logic referencing legacy tables was not adapted. Planning reliability depends on structural and integration alignment.
Why this is a migration-exclusive failure.
ECC scheduling relied on classic MRP and table structures. 1. S/4HANA introduces MRP live and unified data persistence. 2. Structural simplifications alter delivery schedule processing. 3. Migration preserves configuration but changes execution semantics. 4. Planning differences surface only under real load scenarios. Transformation shifts how planning logic is executed, not just configured.
Ownership, who actually fixes it.
Scheduling agreements require coordinated planning and procurement governance. 1. MM cross-module lead reviews scheduling agreement configuration and release logic. 2. SD validates outbound communication and delivery integration. 3. PP confirms planning consistency with MRP live behavior. 4. ABAP refactors custom enhancements tied to legacy scheduling logic.
Who gets blamed versus who owns it.
When supply planning becomes unstable, tension escalates quickly. 1. Blamed planning team for forecast inaccuracy. 2. Blamed procurement for incorrect schedule maintenance. 3. Actual owner cross-module scheduling and planning alignment. 4. Root cause execution semantics changed under S4 simplification.
How this is actually fixed, the right way by a role.
Stabilization requires controlled end-to-end planning simulation. 1. MM validates schedule line behavior and release generation. 2. MRP live planning results are compared with ECC baselines. 3. Output release logic is tested under real demand scenarios. 4. Custom enhancements are redesigned for new data structures.
What not to do, common wrong fixes.
Planning shortcuts create downstream volatility. 1. Manually correcting schedule lines without root cause analysis. 2. Reverting to classic MRP without structural review. 3. Disabling release outputs to reduce noise. 4. Ignoring integration impact on inventory valuation. Scheduling stability requires architectural alignment, not quick fixes.
Follow-up 1. Why does MRP live influence scheduling agreements?
Answer: because MRP live processes planning differently and may alter timing or aggregation of requirements. This affects how delivery schedules are generated and interpreted.
Follow-up 2. How can teams validate scheduling stability before go live?
Answer: by running comparative planning simulations between ECC and S4 under identical demand data, and validating resulting delivery schedules.
Follow-up 3. Curveball. Why are scheduling shifts particularly disruptive?
Answer: because they directly impact supply reliability. Even small deviations in release timing can cascade into stock shortages or excess inventory.
Exclusive pro tip.
Never approve S4HANA migration without executing at least one full scheduling agreement lifecycle under MRP live conditions.
Category 7 wrap-up. Procurement is no longer just a transaction flow.
In S4HANA, procurement behavior shifts are subtle but financially powerful. Release logic, pricing, scheduling, and output are no longer isolated configurations. They are integrated governance mechanisms. When these shifts are underestimated, procurement becomes unstable even though transactions technically execute.
Transition. When invoices become the battlefield.
Once procurement stabilizes, the real financial pressure begins. Logistics invoice verification is where valuation, tolerance, and reconciliation collide. In S4HANA, even small semantic shifts in matching logic can block payments or distort financial statements.
Category 8. Logistics invoice verification live.
Invoice verification in S4HANA is no longer just about matching quantity and price. Unified journal integration, material ledger activation, and valuation transparency reshape how tolerance and reconciliation behave. These failures rarely look technical, they look financial.
Scenarios covered in Category 8.
Scenario 43, three-way match logic changes. Primary owner MM cross-module. Supporting FI. Scenario 44, tolerance keys produce unexpected blocks. Primary owner FI cross-module. Supporting MM. Scenario 45, MRBR behavior changes. Primary owner MM cross-module. Supporting FI. Scenario 46, subsequent debit or credit differences. Primary owner MM cross-module. Supporting FI. Scenario 47, GR or IR clearing results drift. Primary owner FI cross-module. Supporting MM.
Scenario 43. Three-way match logic changes after migration.
After S4HANA migration, invoices that previously posted without issue now trigger unexpected blocks during three-way matching. Goods receipt quantities appear correct, purchase order values are aligned, yet invoice verification behaves inconsistently. The process executes technically, but financial confidence erodes quickly.
Scenario classification.
1. Complexity high financial posting risk. 2. Phase post-go-live execution and period-end validation. 3. Primary ownership MM cross-module. 4. Supporting FI.
Why this happens, scenario analysis and root cause.
Three-way matching integrates procurement, valuation, and accounting tolerance logic. 1. Material ledger is mandatory in S4HANA and impacts valuation differences. 2. Unified journal posting logic alters how price variances are calculated. 3. Open GR or IR balances were not fully reconciled before conversion. 4. Tolerance configuration was transported but not validated under S4 semantics. Matching logic did not disappear. Its financial transparency increased.
Why this is a migration-exclusive failure.
ECC separated logistics and accounting more loosely. 1. S4HANA enforces material ledger integration system-wide. 2. Unified Journal merges inventory and accounting valuation logic. 3. Legacy tolerance assumptions may no longer hold under stricter valuation. 4. Transformation exposes historical reconciliation gaps. Migration forces valuation consistency that ECC tolerated loosely.
Ownership, who actually fixes it.
Invoice blocks may look transactional, but valuation governance drives resolution. 1. MM cross-module lead reviews PO and goods receipt alignment. 2. FI validates tolerance keys and price difference postings. 3. Data team reconciles open GR and IR balances. 4. ABAP reviews custom invoice validation logic.
Who gets blamed versus who owns it.
When invoices block unexpectedly, operational pressure escalates immediately. 1. Blamed accounts payable for incorrect invoice entry. 2. Blamed procurement for goods receipt errors. 3. Actual owner cross-module valuation and tolerance alignment. 4. Root cause, unified journal and material ledger integration effects.
How this is actually fixed, the right way by a role.
Stabilization requires controlled invoice lifecycle simulation. 1. MM validates goods receipt and PO consistency across valuation areas. 2. FI reviews tolerance configuration under unified journal logic. 3. Open balances are reconciled before further invoice posting. 4. End-to-end invoice simulation confirms financial stability.
What not to do, common wrong fixes.
Short-term overrides create long-term financial distortion. 1. Increasing tolerance limits blindly to unblock invoices. 2. Manually releasing blocked invoices without root cause validation. 3. Ignoring material ledger impact on valuation differences. 4. Closing GR or IR balances artificially. Tolerance inflation hides valuation inconsistencies instead of resolving them.
Follow-up 1. Why does three-way match appear stricter after migration?
Answer: because S4HANA integrates valuation logic through material ledger and unified journal posting. Variances that were previously absorbed or less visible in ECC are now calculated more transparently, making tolerance enforcement appear stricter.
Follow-up 2. How can teams validate three-way match stability before go-live?
Answer: by executing structured invoice simulations across multiple price variance scenarios and reconciling FI postings against MM document flow under S4 conditions. This exposes valuation mismatches early.
Follow-up 3. Curveball. Why is increasing tolerance considered dangerous in S4?
Answer: because it masks structural valuation discrepancies. Over time, inflated tolerances distort financial accuracy and weaken internal controls, increasing audit and compliance exposure.
Exclusive pro tip.
If three-way match behavior changes after migration, investigate valuation logic and material ledger impact before adjusting tolerance keys.
Scenario 44. Tolerance keys produce unexpected blocks.
After migration to S4HANA, invoices begin blocking under tolerance keys that rarely triggered in ECC. Small quantity or price differences now cause automatic posting blocks, even when business impact appears minor. The process runs, but accounts payable volume slows dramatically.
Scenario classification.
1. Complexity, high operational and financial control risk. 2. Phase, post-go-live invoice processing stabilization. 3. Primary ownership, FI cross-module. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
Tolerance evaluation is tightly integrated with valuation and posting logic. 1. Material ledger recalculates variances differently than ECC. 2. Unified journal integration affects price and quantity comparison. 3. Tolerance limits were copied but not recalibrated under S4 behavior. 4. Open historical imbalances distort variance baselines. Tolerance keys are not stricter by design, they are more transparent.
Why this is a migration-exclusive failure.
ECC tolerance logic operated under different valuation mechanics. 1. S/4HANA mandates material ledger integration. 2. Posting differences are calculated using unified journal semantics. 3. Migration preserves old limits but changes evaluation context. 4. Transformation exposes subtle financial variances that ECC masked. What looked acceptable in ECC may now trigger governance enforcement.
Ownership, who actually fixes it.
Although invoices block in FI, the cause spans procurement and valuation. 1. FI cross-module lead reviews tolerance configuration and variance logic. 2. MM validates PO price, quantity, and goods receipt consistency. 3. Data team reconciles historical GR and IR imbalances. 4. ABAP reviews custom invoice validation or enhancement logic.
Who gets blamed versus who owns it.
When invoice blocks increase, operational frustration escalates quickly. 1. Blamed accounts payable for incorrect invoice entry. 2. Blamed procurement for inaccurate goods receipt posting. 3. Actual owner cross-module tolerance calibration and valuation alignment. 4. Root cause, unified journal recalculation combined with unchanged ECC tolerance limits.
How this is actually fixed, the right way by a role.
Stabilization requires recalibration, not blind expansion. 1. FI recalibrates tolerance keys based on S4 variance behavior. 2. MM validates procurement master data accuracy. 3. Controlled invoice simulations validate adjusted thresholds. 4. Period-end reconciliation confirms no financial distortion.
What not to do, common wrong fixes.
Short-term tolerance expansion creates governance risk. 1. Dramatically increasing tolerance limits to unblock backlog. 2. Manually releasing all blocked invoices without variance review. 3. Ignoring valuation differences caused by material ledger. 4. Treating invoice blocks as user errors instead of system behavior changes. Tolerance controls protect financial integrity. They must be calibrated, not disabled.
Follow-up 1. Why do tolerance keys trigger more frequently in S4HANA?
Answer: because S4HANA calculates price and quantity variances using unified journal and material ledger integration. Variances that were previously absorbed in ECC are now evaluated more precisely.
Follow-up 2. How should tolerance limits be recalibrated safely?
Answer: by analyzing historical invoice variance patterns, running controlled simulations, and validating financial impact before adjusting thresholds in production.
Follow-up 3. Curveball. Why is mass release of blocked invoices risky?
Answer: because it bypasses governance controls and may allow systemic valuation errors to propagate into financial statements.
Exclusive pro tip.
If tolerance blocks spike after migration, review variance calculation logic before touching tolerance limits.
Scenario 45. MRBR behavior changes after migration.
After S4HANA migration, invoices that were previously released smoothly through MRBR now remain blocked or reblock after release. Automatic release logic behaves inconsistently, and finance teams struggle to clear backlog efficiently. The functionality exists, but the behavior feels different.
Scenario classification.
1. Complexity, high operational backlog risk. 2. Phase, post-go-live stabilization and invoice backlog processing. 3. Primary ownership, MM cross-module. 4. Supporting FI.
Why this happens, scenario analysis and root cause.
MRBR release logic depends on updated valuation and tolerance recalculations. 1. Material ledger recalculates variances differently at release time. 2. Unified journal posting updates can reevaluate previously blocked invoices. 3. Tolerance key recalibration was incomplete during migration. 4. Open GR or IR imbalances distort MRBR release conditions. MRBR logic is sensitive to valuation recalculation timing.
Why this is a migration-exclusive failure.
ECC release logic operated under older valuation mechanics. 1. S4HANA enforces unified journal recalculation during release processing. 2. Material ledger influences price variance reevaluation. 3. Transformation changes how invoice blocks are reassessed. 4. Historical balances from ECC behave differently in unified structures. Migration introduces recalculation transparency that alters release outcomes.
Ownership, who actually fixes it.
MRBR issues require valuation and tolerance governance alignment. 1. MM cross-module lead reviews invoice block reasons and release parameters. 2. FI validates tolerance configuration and price difference posting logic. 3. Data team reconciles GR and IR historical inconsistencies. 4. ABAP reviews custom release enhancements if present.
Who gets blamed versus who owns it.
When invoice backlog grows, accountability questions escalate quickly. 1. Blamed accounts payable for failing to process invoices. 2. Blamed system for inconsistent behavior. 3. Actual owner, cross-module tolerance and valuation recalibration. 4. Root cause, unified journal recalculation interacting with unchanged MRBR parameters.
How this is actually fixed, the right way by a role.
Stabilization requires release simulation under real variance conditions. 1. MM analyzes block reasons and variance sources. 2. FI recalibrates tolerance logic in coordination with MM. 3. Historical GR or IR imbalances are cleared. 4. Controlled MRBR test cycles validate release consistency.
What not to do, common wrong fixes.
Backlog pressure should not drive risky shortcuts. 1. Mass releasing invoices without root cause validation. 2. Disabling tolerance checks temporarily. 3. Blaming MRBR logic without reviewing valuation impact. 4. Ignoring material ledger recalculation behavior. Release automation must align with valuation governance.
Follow-up 1. Why do invoices reblock after being released?
Answer: because unified journal recalculations and material ledger adjustments can reevaluate variance conditions. If tolerance logic remains unchanged, invoices may fall back into blocked status.
Follow-up 2. How can MRBR stability be validated before go live?
Answer: by running structured invoice variance simulations and executing multiple release cycles under realistic GR and IR conditions.
Follow-up 3. Curveball. Why is MRBR instability considered a governance risk?
Answer: because inconsistent release behavior weakens internal control reliability and creates audit exposure through unpredictable invoice handling.
Exclusive pro tip.
Before go live, simulate high-volume invoice release cycles under S4 valuation logic to avoid post-migration backlog shock.
Scenario 46. Subsequent debit or credit differences behave unexpectedly.
After S4HANA migration, subsequent debit or credit postings behave differently during invoice verification. Adjustments that previously aligned smoothly with purchase order history now create valuation discrepancies or unexpected FI postings. The transaction completes, but financial reconciliation becomes unstable.
Scenario classification.
1. Complexity, high financial reconciliation risk. 2. Phase, post-go-live adjustment and period-end processing. 3. Primary ownership, MM cross-module. 4. Supporting FI.
Why this happens, scenario analysis and root cause.
Subsequent debits and credits interact directly with valuation and unified journal logic. 1. Material ledger recalculates price differences at adjustment time. 2. Unified journal integration alters how valuation adjustments post to FI. 3. Purchase order history representation differs under MATDOC and ACDOCA. 4. Open historical balances distort adjustment baselines. Adjustment logic is more transparent, but less forgiving under S4.
Why this is a migration-exclusive failure.
ECC valuation adjustments operated under optional material ledger activation. 1. S4HANA enforces material ledger for all inventory valuation. 2. Unified journal posting structure changes adjustment visibility. 3. Migration preserves transactional behavior but alters valuation interpretation. 4. Transformation exposes reconciliation gaps that ECC masked. Migration introduces deeper valuation consistency requirements.
Ownership, who actually fixes it.
Adjustment instability spans procurement and financial governance. 1. MM cross-module lead reviews PO history and adjustment alignment. 2. FI validates valuation postings in unified journal. 3. CO confirms cost object impact where relevant. 4. Data team reconciles open balances before adjustment cycles.
Who gets blamed versus who owns it?
When valuation adjustments misalign, accountability debates begin immediately. 1. Blamed accounts payable for incorrect invoice correction. 2. Blamed procurement for inconsistent goods receipt. 3. Actual owner cross-module valuation alignment under material ledger. 4. Root cause unified journal recalculation altering adjustment semantics.
How this is actually fixed, the right way by a role.
Stabilization requires end-to-end valuation validation. 1. MM validates purchase order history alignment with adjustment entries. 2. FI reconciles valuation postings in ACDOCA. 3. Material ledger configuration is reviewed for variance impact. 4. Controlled adjustment simulations confirm stable financial behavior.
What not to do, common wrong fixes.
Financial distortion often begins with rushed corrections. 1. Posting manual journal entries to force reconciliation. 2. Ignoring material ledger impact on price differences. 3. Clearing balances without root cause analysis. 4. Treating adjustment variance as minor rounding differences. Adjustment integrity is critical to period-end accuracy.
Follow-up 1. Why do subsequent debits or credits post differently in S/4HANA?
Answer: because unified journal and mandatory material ledger integration recalculate valuation and price differences more precisely. Adjustments now reflect deeper financial semantics than in ECC.
Follow-up 2. How can teams validate adjustment stability before production?
Answer: by simulating full procurement life cycles including goods receipt, invoice posting, and subsequent debit or credit adjustments under S4 valuation conditions.
Follow-up 3. Curveball. Why are adjustment inconsistencies particularly risky during audits?
Answer: because they directly impact inventory valuation and expense recognition timing. Misalignment can distort financial statements and weaken audit defensibility.
Exclusive pro tip.
Before go live, simulate at least one full adjustment cycle, including subsequent debit and credit under material ledger, to confirm valuation integrity.
Scenario 47. GR or IR clearing results drift after migration.
After S/4HANA migration, GR or IR clearing behaves inconsistently during period end. Open balances remain despite matching invoices and goods receipts, or clearing amounts differ slightly from expectations. Transactions post successfully, yet reconciliation between MM and FI becomes unstable.
Scenario classification.
1. Complexity, critical financial statement risk. 2. Phase, period-end closing and reconciliation. 3. Primary ownership, FI cross-module. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
GR or IR clearing interacts directly with unified valuation and posting logic. 1. Material ledger recalculates price differences differently than ECC. 2. Unified journal integration changes how clearing amounts are derived. 3. Historical open GR or IR balances were not fully reconciled pre-cut over. 4. Tolerance and adjustment behavior altered clearing baselines. Clearing drift reflects valuation inconsistency, not transactional failure.
Why this is a migration-exclusive failure.
ECC clearing logic operated under separated logistics and FI layers. 1. S/4HANA enforces unified journal posting and mandatory material ledger. 2. Transformation changes how variances are absorbed during clearing. 3. Migration preserves open balances but changes valuation interpretation. 4. Reconciliation issues surface primarily during first S4 period end close. Migration tightens valuation transparency at period end.
Ownership, who actually fixes it.
Clearing instability spans financial governance and procurement validation. 1. FI cross-module lead reviews clearing logic and account determination. 2. MM validates goods receipt and invoice matching accuracy. 3. Data team reconciles historical GR or IR balances. 4. CO confirms impact on inventory and expense allocation.
Who gets blamed versus who owns it.
When period-end numbers drift, pressure escalates rapidly. 1. Blamed accounts payable for incorrect invoice processing. 2. Blamed procurement for mismatched goods receipts. 3. Actual owner, cross-module valuation and clearing recalibration. 4. Root cause, unified journal and material ledger interaction under new semantics.
How this is actually fixed, the right way by a role.
Stabilization requires structured reconciliation under S4 valuation rules. 1. FI analyzes clearing differences in ACDOCA. 2. MM validates document flow from PO to invoice. 3. Historical GR or IR imbalances are corrected systematically. 4. Controlled period-end simulations confirm stable clearing behavior.
What not to do, common wrong fixes.
Short-term fixes undermine financial integrity. 1. Posting manual clearing adjustments to force balance. 2. Writing off small variances without investigation. 3. Ignoring material ledger recalculation effects. 4. Closing period without reconciling GR or IR differences. GR or IR clearing integrity is foundational to inventory valuation accuracy.
Follow-up 1. Why does GR or IR clearing differ after migration even if documents match?
Answer: because S/4HANA recalculates valuation differences using unified journal and material ledger integration. Clearing amounts reflect deeper financial semantics than in ECC.
Follow-up 2. How can teams ensure clearing stability before first S4 period end?
Answer: by executing structured reconciliation simulations including goods receipt, invoice posting, adjustments, and final clearing under S4 valuation logic.
Follow-up 3. Curveball. Why is GR or IR drift considered critical for auditors?
Answer: because it directly impacts inventory valuation and liability recognition. Unexplained clearing variances weaken financial statement reliability and audit confidence.
Exclusive pro tip.
Never close your first S4 period without performing a full GR or IR reconciliation review under unified journal and material ledger logic.
Category 8 wrap-up. Invoice verification is where finance feels the shock.
Logistics invoice verification exposes valuation truth. In S/4HANA, unified journal and mandatory material ledger remove the buffering effect ECC once provided. When tolerance, clearing, or adjustment logic shifts, the impact is immediate and financial. What appears operational is actually architectural.
Transition. When inventory itself changes meaning.
After invoices stabilize, the next wave of migration shock hits inventory management. Movement types, stock logic, and valuation behavior evolve under S/4HANA's simplified data model. What once behaved predictably in ECC may now behave differently under unified persistence.
Please check description or comments section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP functional modules interviews jobs like SAP MM Consultant jobs, SAP FICO Consultant jobs, SAP SD Consultant jobs, SAP PP Consultant jobs, SAP Ariba Consultant jobs, SAP Extended Warehouse Management EWM Consultant jobs, SAP Plant Maintenance PM Consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Category 9. Inventory management and movement types.
Inventory management in S/4HANA is not just about stock quantity. It is about valuation transparency, unified posting logic, and structural simplification. Movement types, stock segmentation, reservations, and procurement keys interact more tightly with finance and planning than ever before.
Scenarios covered in Category 9.
Scenario 48, movement types behave differently. Primary owner MM cross-module. Supporting FI. Scenario 49, negative stock handling changes. Primary owner MM cross-module. Supporting FI. Scenario 50, stock and transit differences. Primary owner MM cross-module. Supporting SD. Scenario 51, physical inventory variances increase. Primary owner MM cross-module. Supporting FI. Scenario 52, reservation logic changes. Primary owner MM cross-module. Supporting PP. Scenario 53, special procurement keys behave differently. Primary owner MM cross-module. Supporting PP. Scenario 54, stock segmentation activation changes MRP and valuation behavior. Primary owner MM cross-module. Supporting PPFI.
Scenario 48. Movement types behave differently after migration.
After migrating to S/4HANA, certain movement types no longer behave exactly as they did in ECC. Goods receipts, transfers, or consumption postings produce unexpected valuation entries or accounting impacts. Transactions post successfully, but financial interpretation changes subtly yet significantly.
Scenario classification.
1. Complexity, high valuation and accounting impact risk. 2. Phase post-go-live inventory stabilization. 3. Primary ownership MM cross-module. 4. Supporting FI.
Why this happens, scenario analysis and root cause.
Movement types drive quantity updates and accounting postings simultaneously. 1. S/4HANA integrates valuation through mandatory material ledger. 2. Unified journal posting logic alters accounting impact timing. 3. Custom enhancements referencing legacy tables were not adapted. 4. Account determination configuration interacts differently with unified structures. Movement types remain operational codes, but their financial semantics evolve.
Why this is a migration-exclusive failure.
ECC movement types operated under separated logistics and FI persistence. 1. S/4HANA unifies inventory and accounting through ACDOCA. 2. Material ledger recalculates valuation differences automatically. 3. Compatibility views preserve structure but not identical semantics. 4. Transformation exposes movement logic dependencies that ECC tolerated. Migration changes how movement types influence valuation, not how they are executed.
Ownership, who actually fixes it.
Movement type instability spans configuration and financial validation. 1. MM cross-module lead reviews movement configuration and account determination. 2. FI validates posting impact in unified journal. 3. ABAP refactors custom logic tied to legacy table behavior. 4. Data team reconciles pre- and post-migration inventory valuation.
Who gets blamed versus who owns it.
When valuation shifts unexpectedly, responsibility debates begin immediately. 1. Blamed warehouse for incorrect movement execution. 2. Blamed finance for posting discrepancies. 3. Actual owner movement configuration alignment with unified valuation logic. 4. Root cause structural integration shift under S4 simplification.
How this is actually fixed, the right way by a role.
Stabilization requires valuation-driven configuration review. 1. MM validates movement type configuration and account assignment. 2. FI reconciles posting logic through ACDOCA comparison. 3. Controlled goods movement simulations confirm stable valuation. 4. Custom enhancements are adapted to new data persistence structures.
What not to do, common wrong fixes.
Operational pressure must not override valuation discipline. 1. Adjusting GL accounts without root cause analysis. 2. Copying ECC configuration blindly into S4. 3. Ignoring material ledger recalculation effects. 4. Treating posting differences as minor rounding errors. Movement types are financial drivers, not just warehouse codes.
Follow-up 1. Why do the same movement types create different FI postings in S/4HANA?
Answer: because unified journal integration and mandatory material ledger recalculations alter valuation flow. The movement code is the same, but its accounting semantics are enhanced.
Follow-up 2. How can teams validate movement type stability before production?
Answer: by executing structured goods movement simulations across valuation areas and reconciling FI postings against ECC benchmarks under controlled conditions.
Follow-up 3. Curveball. Why are movement type shifts considered high risk in audits?
Answer: because they directly impact inventory valuation and cost recognition. Even subtle posting changes can distort financial statements if not properly validated.
Exclusive pro tip.
Treat every high-volume movement type as a financial control object during S4 migration validation.
Scenario 49. Negative stock handling changes after migration.
After migrating to S4HANA, negative stock behavior changes in subtle but impactful ways. Postings that previously flowed smoothly now trigger warnings, valuation inconsistencies, or planning distortions. Transactions complete, yet inventory and financial reporting become unstable.
Scenario classification.
1. Complexity, high inventory and valuation risk. 2. Phase, post-go-live inventory execution. 3. Primary ownership, cross-module. 4. Supporting FI.
Why this happens, scenario analysis and root cause.
Negative stock interacts directly with valuation timing and posting logic. 1. Material ledger recalculates moving average price differently under negative balances. 2. Unified journal posting structure alters variance timing recognition. 3. Stock segmentation or valuation area settings were not fully aligned. 4. MRP live planning reacts differently to negative quantity scenarios. Negative stock is not just a quantity issue. It is a valuation timing event.
Why this is a migration exclusive failure.
ECC tolerated negative stock under simpler valuation behavior. 1. S4HANA enforces mandatory material ledger integration. 2. Unified journal recalculates cost impact immediately. 3. Transformation changes price difference absorption behavior. 4. Migration exposes timing inconsistencies previously unnoticed. Migration increases valuation transparency under negative stock conditions.
Ownership, who actually fixes it.
Negative stock instability spans warehouse control and financial governance. 1. cross-module lead reviews negative stock configuration and movement patterns. 2. FI validates valuation impact in unified journal. 3. PP confirms planning consistency under MRP live. 4. Data team reconciles pre-migration negative stock positions.
Who gets blamed versus who owns it.
When inventory balances fluctuate, operational teams feel the pressure first. 1. Blamed warehouse for incorrect issue timing. 2. Blamed planning for inaccurate availability data. 3. Actual owner cross-module valuation and configuration alignment. 4. Root cause, unified journal recalculation interacting with negative stock timing.
How this is actually fixed, the right way by a role.
Stabilization requires controlled negative stock scenario testing. 1. validates negative stock settings at plant and storage location level. 2. FI reconciles valuation impact across negative posting cycles. 3. MRP live simulations confirm planning stability. 4. Movement timing and account determination are reviewed systematically.
What not to do, common wrong fixes.
Operational shortcuts distort valuation integrity. 1. Disabling negative stock globally without impact analysis. 2. Posting manual adjustments to offset valuation differences. 3. Ignoring planning distortions caused by temporary negative balances. 4. Treating price recalculation effects as rounding noise. Negative stock control must align with valuation discipline.
Follow-up 1. Why does negative stock impact valuation more visibly in S4HANA?
Answer: because mandatory material ledger and unified journal recalculation process price differences immediately. Negative balances amplify variance visibility under these tighter integration rules.
Follow-up 2. How can teams validate negative stock stability before go live?
Answer: by simulating issue before receipt scenarios and reconciling inventory valuation and F-I postings under controlled test cycles.
Follow-up 3, curveball. Why is negative stock considered a governance red flag in S4?
Answer: because it directly influences inventory valuation timing and cost recognition. Frequent negative balances increase financial volatility and audit scrutiny.
Exclusive pro tip.
If negative stock was heavily used in ECC, treat it as a controlled risk scenario during S4 valuation validation.
Scenario 50, stock and transit differences after migration.
After S4 HANA migration, stock in transit behaves differently during intercompany or cross-plant transfers. Quantities appear correct operationally, yet valuation timing and reporting totals do not align with ECC expectations. The transfer completes, but finance sees unexpected balance shifts.
Scenario classification.
1. Complexity, high intercompany valuation risk. 2. Phase, post-go-live cross-plant stabilization. 3. Primary ownership, MM cross-module. 4. Supporting SD.
Why this happens, scenario analysis and root cause.
Stock in transit affects both logistics tracking and financial recognition. 1. S4 HANA unifies inventory valuation through mandatory material ledger. 2. Intercompany transfers integrate more tightly with SD billing and FI posting. 3. Transfer pricing or valuation layers behave differently under parallel valuation. 4. Timing of goods issue and goods receipt postings impacts unified journal entries. Stock in transit is a valuation timing mechanism, not just a logistical placeholder.
Why this is a migration exclusive failure.
ECC separated logistics visibility from deeper valuation recalculation. 1. S4 HANA enforces integrated valuation across plants and company codes. 2. Material ledger captures price differences during transfer. 3. Migration preserves stock but changes financial interpretation timing. 4. Parallel valuation amplifies intercompany reconciliation exposure. Transformation tightens alignment between stock movement and accounting impact.
Ownership, who actually fixes it.
Transit instability requires coordinated logistics and financial validation. 1. MM cross-module lead reviews transfer movement configuration and valuation areas. 2. SD validates intercompany billing integration. 3. FI reconciles valuation impact in unified journal. 4. CO confirms transfer pricing alignment.
Who gets blamed versus who owns it.
When balances shift during transfers, blame often targets execution teams. 1. Blamed warehouse for incorrect transfer timing. 2. Blamed billing for misaligned intercompany processing. 3. Actual owner cross-module valuation alignment under unified journal. 4. Root cause migration-driven integration of stock and financial recognition timing.
How this is actually fixed, the right way by a role.
Stabilization requires synchronized transfer simulations. 1. MM validates movement types for stock and transit scenarios. 2. SD ensures billing logic aligns with transfer events. 3. FI reconciles intercompany valuation postings in ACDOCA. 4. Parallel valuation scenarios are tested end-to-end.
What not to do, common wrong fixes.
Quick alignment patches distort valuation accuracy. 1. Adjusting transfer prices without configuration review. 2. Delaying goods receipt artificially to control valuation timing. 3. Posting manual FI adjustments to balance intercompany drift. 4. Ignoring parallel valuation impacts. Transit valuation must reflect economic reality, not convenience timing.
Follow-up 1. Why do intercompany transfers look correct in quantity but wrong in value?
Answer: because unified journal and material ledger recalculations capture price differences during transfer events. Quantity visibility remains stable, but valuation recognition timing shifts.
Follow-up 2. How can teams validate transfer stability before first close?
Answer: by executing intercompany transfer cycles including billing, goods receipt, and valuation reconciliation under parallel valuation scenarios.
Follow-up 3. Curveball. Why are stock and transit differences highly visible to auditors?
Answer: because they impact inventory ownership recognition and revenue timing across company codes. Misalignment directly affects consolidated financial reporting.
Exclusive pro tip.
Always simulate intercompany stock transfers with parallel valuation active before your first S S/4HANA period end close.
Scenario 51. Physical inventory variances increase after migration.
After S/4HANA migration, physical inventory counts reveal higher variances than historically seen in ECC. Quantities may reconcile operationally, yet valuation adjustments appear larger or more frequent. The counting process works, but financial exposure becomes more visible.
Scenario classification.
1. Complexity, high inventory valuation and audit risk. 2. Phase, first physical inventory cycle post-go live. 3. Primary ownership MM cross-module. 4. Supporting FI.
Why this happens, scenario analysis and root cause.
Physical inventory now interacts directly with unified valuation transparency. 1. Mandatory material ledger recalculates price differences at adjustment. 2. Unified journal post-valuation impact immediately to financial statements. 3. Negative stock or timing inconsistencies amplify variance exposure. 4. Stock segmentation or valuation area settings change adjustment behavior. Physical counts remain operational, but valuation visibility increases.
Why this is a migration-exclusive failure.
ECC buffered some valuation effects through separated persistence layers. 1. S/4HANA integrates logistics and finance through ACDOCA. 2. Material ledger enforces full valuation recalculation. 3. Migration exposes historical inventory inaccuracies. 4. First cycle adjustments under S/4 often reveal legacy inconsistencies. Migration increases transparency rather than creating new discrepancies.
Ownership, who actually fixes it.
Variance control spans operational discipline and financial validation. 1. MM cross-module lead reviews counting procedures and stock movement timing. 2. FI validates financial impact of inventory adjustments. 3. Data team reconciles historical stock balances before adjustment. 4. CO confirms cost allocation accuracy post-adjustment.
Who gets blamed versus who owns it.
Inventory differences trigger immediate operational scrutiny. 1. Blamed warehouse for inaccurate counting. 2. Blamed system for incorrect stock records. 3. Actual owner cross-module valuation recalibration and historical cleanup. 4. Root cause, unified journal and material ledger exposing latent inconsistencies.
How this is actually fixed, the right way by a role.
Stabilization requires structured reconciliation before adjustments. 1. MM validates document flow prior to inventory count. 2. FI reviews valuation impact scenarios before posting adjustments. 3. Pre-count reconciliation ensures stock integrity. 4. Controlled simulation cycles confirm stable variance behavior.
What not to do, common wrong fixes.
Pressure to close periods must not override control integrity. 1. Posting large adjustments without root cause analysis. 2. Writing off variances to expense without reconciliation. 3. Blaming counting teams without validating valuation logic. 4. Skipping reconciliation during first S/4 inventory cycle. Physical inventory under S/4 is a financial audit event.
Follow-up 1. Why do inventory adjustments look larger in S/4HANA?
Answer: because unified journal and material ledger recalculations make valuation effects immediately visible. ECC sometimes distributed impact differently across accounts.
Follow-up 2. How can teams reduce first-cycle inventory shock?
Answer: by performing full stock reconciliation and simulation postings before official physical inventory adjustments under S/4 rules.
Follow-up 3. Curveball. Why do auditors focus heavily on the first S/4 physical inventory?
Answer: because it validates whether migration preserved stock integrity and valuation consistency. It is a critical control checkpoint in transformation projects.
Exclusive pro tip.
Treat your first S/4 physical inventory as a financial validation milestone, not just an operational count.
Scenario 52. Reservation logic changes after migration.
After migrating to S/4HANA, reservations created for production or maintenance behave differently. Stock appears reserved correctly, yet availability checks, MRP results, or issue postings show inconsistencies. The transaction works, but planning and consumption timing no longer align with ECC expectations.
Scenario classification.
1. Complexity, medium planning and availability risk. 2. Phase, post-go-live planning stabilization. 3. Primary ownership MM cross-module. 4. Supporting PP.
Why this happens, scenario analysis and root cause.
Reservations influence both availability and valuation timing. 1. MRP live processes planning logic differently than classic MRP. 2. Stock segmentation introduces new availability dimensions. 3. Unified journal impacts consumption recognition timing. 4. Custom enhancements tied to legacy reservation tables were not adapted. Reservations remain logistical markers, but now interact more tightly with planning engines.
Why this is a migration-exclusive failure.
ECC reservation logic operated under classic planning architecture. 1. S/4HANA introduces MRP live and simplified data persistence. 2. Stock segmentation alters availability interpretation. 3. Transformation changes how planning consumes reserved quantities. 4. Legacy assumptions no longer align with new planning engine behavior. Migration shifts reservation influence from static record to dynamic planning input.
Ownership, who actually fixes it.
Reservation instability spans logistics and production planning. 1. MM cross-module lead reviews reservation configuration and movement impact. 2. PP validates MRP live consumption logic. 3. ABAP refactors custom code referencing legacy reservation structures. 4. Data team reconciles reserved versus available quantities.
Who gets blamed versus who owns it.
Planning inconsistencies quickly create operational tension. 1. Blamed production for inaccurate planning. 2. Blamed warehouse for incorrect stock handling. 3. Actual owner reservation configuration alignment with MRP live logic. 4. Root cause planning engine shift under S4 simplification.
How this is actually fixed, the right way by a role.
Stabilization requires controlled planning simulations. 1. MM validates reservation categories and movement linkage. 2. PP executes MRP live simulations under realistic load. 3. Availability checks are reconciled with reserved quantities. 4. Custom enhancements are aligned to new data model structures.
What not to do, common wrong fixes.
Quick fixes can distort planning accuracy long-term. 1. Deleting reservations to force availability. 2. Reverting to classic MRP without understanding root cause. 3. Posting manual adjustments to override system planning. 4. Ignoring stock segmentation impact. Reservation logic must align with planning architecture, not user expectations.
Follow-up 1. Why does MRP live react differently to reservations?
Answer: because MRP live processes planning logic in memory under simplified persistence. It interprets reserved quantities within new segmentation and availability rules.
Follow-up 2. How can teams validate reservation stability before full planning cycles?
Answer: by executing scenario-based MRP simulations including reservations, stock segmentation, and consumption timing under controlled data conditions.
Follow-up 3. Curveball. Why do reservation issues often appear only under production load?
Answer: because parallel planning and segmentation interactions become visible only when multiple materials and plants are processed simultaneously.
Exclusive pro tip.
Validate reservation behavior under MRP live with realistic production volume before trusting availability reports.
Scenario 53. Special procurement keys behave differently after migration.
After S/4HANA migration, materials using special procurement keys such as subcontracting, stock transfer, or phantom assembly begin behaving differently in planning and valuation. MRP results shift, valuation postings vary, and interplant dependencies become more visible. The configuration appears unchanged, yet system behavior evolves.
Scenario classification.
1. Complexity, high planning and valuation interaction risk. 2. Phase, post-go-live planning and procurement stabilization. 3. Primary ownership, MM cross-module. 4. Supporting PP.
Why this happens, scenario analysis and root cause.
Special procurement keys influence sourcing logic, planning flow, and valuation timing. 1. MRP live processes special procurement differently than classic MRP. 2. Stock segmentation and valuation layers alter procurement interpretation. 3. Unified journal impacts intercompany and subcontracting valuation. 4. Legacy custom enhancements tied to procurement logic were not fully adapted. Special procurement keys are planning drivers, not static master data flags.
Why this is a migration-exclusive failure.
ECC procurement logic operated under separate persistence and simpler valuation integration. 1. S/4HANA introduces mandatory material ledger and unified journal. 2. MRP Live processes procurement in memory under new simplification rules. 3. Transformation exposes dependency chains between plants and valuation areas. 4. Migration shifts how procurement flows interact with accounting recognition. Procurement semantics evolve under S/4 integration depth.
Ownership, who actually fixes it.
Stabilizing procurement behavior requires cross-module validation. 1. Cross-module lead reviews special procurement configuration and sourcing logic. 2. PP validates MRP live planning results. 3. FI reconciles valuation impact for intercompany and subcontracting scenarios. 4. ABAP adapts custom enhancements tied to procurement behavior.
Who gets blamed versus who owns it.
Procurement shifts often trigger operational confusion. 1. Blamed planning for unexpected MRP results. 2. Blamed purchasing for sourcing discrepancies. 3. Actual owner procurement configuration alignment under S/4 simplification. 4. Root cause integrated valuation and planning engine transformation.
How this is actually fixed, the right way by a role.
Stabilization requires structured procurement scenario testing. 1. validates procurement key logic across plants and valuation areas. 2. PP runs end-to-end MRP live simulations. 3. FI reconciles accounting impact of procurement flows. 4. Cross-plant dependencies are reviewed for consistency.
What not to do, common wrong fixes.
Shortcuts distort procurement reliability. 1. Changing procurement keys without impact analysis. 2. Reverting to manual purchasing overrides. 3. Ignoring valuation differences under subcontracting scenarios. 4. Treating MRP differences as minor calculation changes. Procurement keys must align with unified planning and valuation architecture.
Follow-up 1. Why does subcontracting valuation change under S/4HANA?
Answer: because mandatory material ledger recalculates cost components under unified journal. Subcontracting components are valued and absorbed differently compared to ECC.
Follow-up 2. How can teams validate procurement key stability before full production?
Answer: by simulating interplant and subcontracting flows under MRP Live and reconciling accounting impact across valuation layers.
Follow-up 3. Curveball. Why are special procurement keys often underestimated during migration?
Answer: because they look like master data flags, yet they control sourcing logic, planning depth, and financial recognition timing across plants.
Exclusive pro tip.
Treat every special procurement key as a cross-module control object during S/4 validation, not just a planning parameter.
Scenario 54. Stock segmentation activation changes MRP and valuation behavior.
After activating stock segmentation in S/4HANA, planning and valuation begin behaving differently across plants and business units. Stock that previously appeared unified is now split by segment, affecting availability checks, MRP proposals, and accounting impact. Nothing seems technically broken, yet business interpretation shifts dramatically.
Scenario classification.
1. Complexity critical planning and valuation architecture shift. 2. Phase configuration and post-go-live stabilization. 3. Primary ownership cross-module. 4. Supporting PPFI.
Why this happens, scenario analysis and root cause.
Stock segmentation introduces an additional inventory dimension. 1. MRP Live processes availability separately per stock segment. 2. Unified journal posts valuation impact per segment. 3. Transfer postings may not consolidate automatically across segments. 4. Legacy reports assume aggregated stock without segment differentiation. Segmentation changes inventory visibility and financial recognition at the same time.
Why this is a migration-exclusive failure.
ECC rarely used advanced segmentation at scale. 1. S/4HANA enables deeper segmentation aligned to business models. 2. MRP Live interprets stock based on new segmentation logic. 3. Material ledger captures valuation per segment automatically. 4. Migration introduces segmentation without historical operational experience. Segmentation magnifies planning and valuation transparency simultaneously.
Ownership, who actually fixes it.
Stock segmentation stabilization requires structured cross-functional validation. 1. MM cross-module lead validates segmentation configuration and stock types. 2. PP reviews MRP live planning results across segments. 3. FI confirms valuation postings per segment in unified journal. 4. Data team reconciles segment-based stock balances with historical aggregates.
Who gets blamed versus who owns it.
Segmentation changes often trigger operational confusion. 1. Blamed planning for unexpected MRP proposals. 2. Blamed warehouse for incorrect stock allocation. 3. Actual owner segmentation design alignment with business model. 4. Root cause architectural activation without cross-module impact validation.
How this is actually fixed, the right way by a role.
Stabilization requires controlled segmentation scenario testing. 1. MM validates segment definitions and stock type configuration. 2. PP executes MRP simulations across multiple segments. 3. FI reconciles valuation impact at segment and ledger level. 4. Legacy reports are redesigned to reflect segmented inventory logic.
What not to do, common wrong fixes.
Short-term consolidation attempts distort segmentation integrity. 1. Manually merging segment stock for reporting convenience. 2. Disabling segmentation after go-live without structural review. 3. Ignoring valuation differences across segments. 4. Treating segmentation as purely a planning enhancement. Stock segmentation is a structural inventory redesign, not a cosmetic feature.
Follow-up 1. Why does segmentation affect valuation as well as planning?
Answer: because material ledger captures valuation differences per segment. Unified journal postings reflect segmented cost recognition, not aggregated stock.
Follow-up 2. How can teams validate segmentation before full activation?
Answer: by executing controlled pilot materials with segmentation, enabled and reconciling MRP results, valuation postings, and reporting consistency.
Follow-up 3. Curveball. Why is segmentation considered a strategic architecture decision rather than a configuration toggle?
Answer: because it redefines how inventory is interpreted across planning, logistics, and finance. Once activated, reversing segmentation impacts master data, valuation, and reporting structures.
Exclusive pro tip.
Activate stock segmentation only after cross-module simulation proves stable planning, valuation, and reporting alignment.
Category 9. Wrap-up. Inventory is no longer just quantity.
Inventory management in S/4HANA is deeply integrated with valuation, planning, and segmentation logic. Movement types, reservations, and procurement keys now influence financial transparency more than ever. What looked operational in ECC becomes architectural in S4.
Transition. When warehouse logic itself changes.
After inventory stabilizes, the next transformation wave hits warehouse execution. The shift from classic WM to embedded EWM is not a technical upgrade. It is a conceptual redesign of stock types, tasks, handling units, and execution control.
Category 10. WM to embedded EWM transformation.
Embedded EWM introduces a different warehouse philosophy. Concepts such as warehouse tasks, stock types, and handling units replace legacy transfer orders and simplified stock logic. Migration exposes structural differences that operational teams often underestimate.
Scenarios covered in Category 10.
Scenario 55, stock type mapping differences. Primary owner UM cross-module. Supporting MM. Scenario 56, transfer order versus warehouse task confusion. Primary owner UM cross-module. Supporting MM. Scenario 57, EWM physical inventory differences. Primary owner UM cross-module. Supporting MM. Scenario 58, handling unit management activation side effects. Primary owner UM cross-module. Supporting MM. Scenario 59, legacy WM enhancements stop working. Primary owner ABAP technical lead. Supporting UM.
Scenario 55. Stock type mapping differences after WM to EWM migration.
After activating embedded EWM, Stock types no longer behave exactly as they did in classic WM. Inventory appears in different categories such as unrestricted, quality inspection, blocked, or EWM-specific stock types. Quantities exist, yet availability checks and warehouse execution behave differently.
Scenario classification.
1. Complexity, high warehouse execution and availability risk. 2. Phase, configuration and post-go-live stabilization. 3. Primary ownership, UM cross-module. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
Embedded EWM introduces its own stock type, logic layered above IM. 1. Classic WM stock types do not map one-to-one with EWM stock categories. 2. EWM introduces availability groups and stock type combinations. 3. Custom movement configurations were not fully aligned with EWM mapping. 4. Stock appears correct in IM but restricted in EWM availability checks. Stock mapping errors create operational confusion without technical failure.
Why this is a migration-exclusive failure.
ECCWM operated with simpler stock interpretation rules. 1. Embedded EWM introduces an additional warehouse layer over IM. 2. Transformation requires explicit stock type mapping configuration. 3. Migration exposes hidden dependencies between IM and WM logic. 4. Stock type semantics evolve during WM to EWM redesign. The warehouse engine changes, even if material master stays the same.
Ownership, who actually fixes it.
Stock type instability spans warehouse configuration and inventory control. 1. UM cross-module lead validates stock type and availability group mapping. 2. MM confirms IM stock category alignment. 3. ABAP reviews custom enhancements affecting stock posting. 4. Operations team validates real warehouse process impact.
Who gets blamed versus who owns it.
When stock cannot be picked or consumed, operational pressure rises immediately. 1. Blamed warehouse for incorrect execution. 2. Blamed inventory management for wrong stock status. 3. Actual owner stock type mapping configuration between IM and EWM. 4. Root cause structural mapping gap during WM to EWM transformation.
How this is actually fixed, the right way by a role.
Stabilization requires systematic mapping validation. 1. EWM reviews stock type determination and availability group settings. 2. MM validates IM stock category consistency. 3. Integration tests confirm correct stock visibility in picking scenarios. 4. End-to-end warehouse simulations validate operational flow.
What not to do, common wrong fixes.
Short-term overrides can distort warehouse accuracy. 1. Manually changing stock categories to unblock picking. 2. Disabling availability checks without configuration review. 3. Ignoring IM and EWM mapping mismatches. 4. Treating EWM stock as identical to WM stock. Stock mapping integrity defines warehouse stability.
Follow-up 1. Why does stock appear available in IM but blocked in EWM?
Answer: because EWM interprets stock types and availability groups independently from IM categories. Mapping gaps cause availability restrictions at the warehouse execution level.
Follow-up 2. How can teams validate stock type mapping before go-live?
Answer: by performing controlled goods receipt, transfer, and picking simulations, and validating stock visibility across both IM and EWM layers.
Follow-up 3. Curveball. Why is stock type mapping considered a strategic design decision?
Answer: because it defines how inventory is interpreted operationally and financially. Incorrect mapping can halt warehouse execution without producing technical errors.
Exclusive pro tip.
Treat stock type mapping as a warehouse architecture blueprint, not a configuration checkbox during WM to EWM migration.
Scenario 56. Transfer order versus warehouse task confusion after migration.
After migrating from classic WM to embedded EWM, users struggle with the conceptual shift from transfer orders to warehouse tasks. Processes that were previously single-step now involve warehouse requests, tasks, confirmations, and queues. Transactions execute, yet operational flow feels fragmented and unfamiliar.
Scenario classification.
1. Complexity, high operational process redesign risk. 2. Phase post-go-live user stabilization. 3. Primary ownership UM cross-module. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
EWM replaces simplified WM execution with a task-oriented architecture. 1. Transfer orders in WM are replaced by warehouse requests and warehouse tasks. 2. EWM separates planning, task creation, and confirmation steps. 3. Queue management introduces execution sequencing. 4. Users attempt to apply WM logic to EWM execution flow. The process works differently because the warehouse engine has changed fundamentally.
Why this is a migration-exclusive failure.
Classic WM was embedded tightly within IM with simpler execution objects. 1. Embedded EWM introduces decoupled warehouse execution architecture. 2. Task-oriented design increases flexibility but requires process discipline. 3. Migration forces users into a redesigned execution paradigm. 4. Operational confusion emerges during first real warehouse cycles. Transformation is conceptual, not just transactional.
Ownership, who actually fixes it.
Stabilizing execution flow requires structured process alignment. 1. UM cross-module lead redesigns execution flow and task configuration. 2. MM validates integration between IM and warehouse postings. 3. Operations team adapts warehouse procedures to EWM logic. 4. Training team ensures users understand task lifecycle.
Who gets blamed versus who owns it.
Execution delays quickly trigger operational frustration. 1. Blamed warehouse operators for slow confirmations. 2. Blamed system for making processes complicated. 3. Actual owner EWM execution design and user enablement. 4. Root cause conceptual shift from order-based to task-based architecture.
How this is actually fixed, the right way by a role.
Stabilization requires structured execution modeling. 1. EWM configures warehouse process types and task determination correctly. 2. Queue structures are optimized for operational efficiency. 3. End-to-end picking and put-away simulations validate flow. 4. User training reinforces task lifecycle understanding.
What not to do, common wrong fixes.
Attempting to replicate WM behavior inside EWM creates instability. 1. Customizing EWM to mimic classic transfer order simplicity. 2. Bypassing queue logic to speed up confirmation. 3. Overriding task creation rules without impact analysis. 4. Ignoring process redesign and relying only on system configuration. EWM requires operational redesign, not cosmetic adjustments.
Follow-up 1. Why does EWM feel more complex than WM?
Answer: because EWM decouples planning, task generation, and confirmation. This adds flexibility and scalability, but increases visible process steps for users.
Follow-up 2. How can teams reduce confusion during go-live?
Answer: by running scenario-based warehouse simulations and conducting hands-on training focused on task lifecycle and queue management.
Follow-up 3. Curveball. Why do projects underestimate the 2 to WT shift?
Answer: because it appears to be a naming change. In reality, it represents a structural redesign of warehouse execution architecture.
Exclusive pro tip.
Do not compare EWM tasks to WM transfer orders. Design warehouse execution around task orchestration from day one.
Scenario 57. EWM physical inventory differences after migration.
After moving from classic WM to embedded EWM, physical inventory behaves differently. Counting procedures, document structures, and variance postings follow EWM logic rather than IM-centric processes. Inventory can be counted successfully, yet discrepancies appear in execution flow and reconciliation.
Scenario classification.
1. Complexity, high warehouse control and audit risk. 2. Phase, first physical inventory cycle in EWM. 3. Primary ownership, UM cross-module. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
EWM manages inventory at warehouse level before IM posting. 1. EWM physical inventory documents are separate from IM documents. 2. Counting occurs at bin level with warehouse task integration. 3. Differences are first adjusted in EWM before posting to IM. 4. Legacy WM counting assumptions do not align with EWM document flow. Inventory control shifts from IM-driven to warehouse-driven execution.
Why this is a migration-exclusive failure.
Classic WM inventory relied more directly on IM integration. 1. Embedded EWM introduces layered warehouse and IM synchronization. 2. Physical inventory requires additional document lifecycle steps. 3. Migration forces process redesign for counting and confirmation. 4. First cycle EWM inventory exposes procedural gaps. Transformation changes how discrepancies are detected and resolved.
Ownership, who actually fixes it.
Physical inventory stabilization requires warehouse governance alignment. 1. UM cross-module lead reviews warehouse inventory procedures and document flow. 2. MM validates IM posting consistency after EWM adjustments. 3. Operations team ensures counting procedures align with EWM process. 4. FI reviews valuation impact of inventory differences.
Who gets blamed versus who owns it.
Counting discrepancies quickly trigger operational escalation. 1. Blamed warehouse staff for inaccurate counts. 2. Blamed system for complex inventory process. 3. Actual owner EWM physical inventory design and integration alignment. 4. Root cause layered warehouse first counting architecture.
How this is actually fixed, the right way by a role.
Stabilization requires structured warehouse simulation cycles. 1. EWM validates physical inventory procedure configuration. 2. Bin-level counting and task confirmations are tested end-to-end. 3. IM postings are reconciled with EWM adjustments. 4. Variance tolerance settings are aligned with financial policy.
What not to do, common wrong fixes.
Shortcuts create audit exposure. 1. Posting IM adjustments without completing EWM inventory process. 2. Bypassing bin-level confirmation steps. 3. Ignoring warehouse task confirmations during count. 4. Treating EWM physical inventory as identical to WM. EWM physical inventory is a structured workflow, not a simple count.
Follow-up 1. Why are EWM physical inventory documents separate from IM?
Answer: because EWM operates as a warehouse execution layer. Adjustments are first controlled at warehouse level before synchronizing with IM to ensure bin-level accuracy.
Follow-up 2. How can teams prepare for first EWM physical inventory?
Answer: by conducting dry run simulations including counting, confirmation, variance posting, and IM synchronization under realistic warehouse volume.
Follow-up 3. Curveball. Why is EWM physical inventory considered a maturity test for warehouse governance?
Answer: because it validates whether execution discipline, system configuration, and financial integration are fully aligned under the new architecture.
Exclusive pro tip.
Treat your first EWM physical inventory as an operational stress test, not just a compliance exercise.
Scenario 58. Handling unit management activation side effects.
After activating handling unit management in embedded EWM, warehouse execution begins behaving differently. Stock is now tied to handling units, affecting picking, packing, and goods movements. Quantities exist, yet transactions fail or require additional steps because HU control logic was not fully anticipated.
Scenario classification.
1. Complexity, critical warehouse execution architecture shift. 2. Phase, configuration, and post-go-live stabilization. 3. Primary ownership, UM cross-module. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
Handling unit activation restructures how stock is physically and logically represented. 1. Stock becomes HU managed instead of purely quantity managed. 2. Warehouse tasks now reference handling units during execution. 3. Picking and put-away strategies depend on HU configuration. 4. Legacy WM processes did not account for HU-based control. HU activation changes warehouse execution depth, not just packaging logic.
Why this is a migration-exclusive failure.
Classic WM rarely enforced full HU-driven architecture. 1. Embedded EWM integrates handling units deeply into execution flow. 2. Migration introduces HU governance without historical operational discipline. 3. Process redesign is required beyond configuration activation. 4. Transformation exposes warehouse structural assumptions. HU management is a structural warehouse redesign, not a cosmetic feature.
Ownership, who actually fixes it.
HU instability spans configuration and operational workflow alignment. 1. UM cross-module lead reviews HU requirement and warehouse process type configuration. 2. MM validates IM integration for HU managed stock. 3. Operations team aligns packing and picking procedures with HU logic. 4. ABAP reviews custom enhancements affecting HU processing.
Who gets blamed versus who owns it.
Execution delays caused by HU logic quickly create tension. 1. Blamed warehouse operators for incorrect packing or confirmation. 2. Blamed system for blocking simple movements. 3. Actual owner HU activation design and execution configuration. 4. Root cause warehouse architecture shift without procedural alignment.
How this is actually fixed, the right way by a role.
Stabilization requires structured HU process validation. 1. EWM validates HU requirement determination and packing configuration. 2. Warehouse simulations test picking, packing, and confirmation cycles. 3. IM synchronization is verified for HU managed stock. 4. User training reinforces HU lifecycle handling.
What not to do, common wrong fixes.
Disabling controls undermines warehouse integrity. 1. Deactivating HU requirement globally without impact analysis. 2. Allowing manual HU overrides in production. 3. Bypassing task confirmation steps tied to HU logic. 4. Treating HU management as optional packaging configuration. Handling units redefine warehouse control, not just packaging.
Follow-up 1. Why does HU activation block simple goods movements?
Answer: because EWM enforces handling unit consistency during warehouse execution. Stock tied to HUs must follow structured packing and confirmation logic before movement is allowed.
Follow-up 2. How can teams validate HU activation safely?
Answer: by activating HU logic in controlled pilot warehouses and simulating full picking, packing, and goods issue cycles before broad rollout.
Follow-up 3. Curveball. Why do projects underestimate HU activation risk?
Answer: because it appears to be a packaging feature. In reality, it restructures how warehouse execution, stock control, and system validation interact.
Exclusive pro tip.
Activate handling unit management only after redesigning warehouse execution processes around HU lifecycle logic.
Scenario 59. Legacy WM enhancements stop working after migration.
After migrating from classic WM to embedded EWM, custom user exits, enhancements, and Z program logic tied to WM tables and events stop working. Warehouse processes execute, but custom validations, automatic postings, or integrations silently fail because the technical trigger points no longer exist.
Scenario classification.
1. Complexity, critical custom code and execution risk. 2. Phase, code remediation and post-go-live stabilization. 3. Primary ownership, ABAP technical lead. 4. Supporting UM.
Why this happens, scenario analysis and root cause.
Embedded EWM replaces core WM tables, events, and execution logic. 1. Classic WM tables and function modules are no longer used. 2. EWM introduces different BAD-IS and enhancement frameworks. 3. Custom code referenced obsolete tables such as LTAC and LTAP. 4. Simplification removed legacy triggers relied upon by Z programs. Enhancements did not fail randomly. Their technical anchor points were removed.
Why this is a migration-exclusive failure.
ECCWM enhancements were tightly embedded into legacy execution objects. 1. Embedded EWM introduces new persistent structures and APIs. 2. Migration requires enhancement redesign rather than code copy. 3. Compatibility views do not replicate functional trigger behavior. 4. Transformation exposes unsupported custom logic dependencies. Custom enhancements must evolve with architectural redesign.
Ownership, who actually fixes it.
Stabilization requires technical redesign aligned with EWM architecture. 1. ABAP technical lead identifies obsolete enhancements and redesigns logic using EWM BAD-IS. 2. UM validates new enhancement integration points. 3. Confirms functional requirements remain valid. 4. Testing team executes regression scenarios for warehouse execution.
Who gets blamed versus who owns it?
When automation disappears, operational frustration escalates quickly. 1. Blame developers for broken custom code. 2. Blame system for removing working logic. 3. Actual owner, technical remediation aligned with WM to EWM redesign. 4. Root cause, enhancement dependency on obsolete WM architecture.
How this is actually fixed, the right way by a role.
Remediation requires structured enhancement redesign. 1. ABAP performs full custom code impact analysis. 2. Enhancements are rebuilt using EWM add-is and released APIs. 3. Functional validation ensures new logic aligns with process flow. 4. Regression testing confirms no silent automation gaps remain.
What not to do, common wrong fixes.
Short-term patches create long-term instability. 1. Reactivating obsolete WM tables via compatibility hacks. 2. Copying old code without redesign. 3. Embedding logic in implicit enhancements without governance. 4. Ignoring simplification warnings for enhancement objects. Enhancement redesign is mandatory in WM to EWM transformation.
Follow-up 1. Why do compatibility views not fix enhancement failures?
Answer: compatibility views preserve table access, but not business events or execution triggers. Enhancements tied to obsolete events must be redesigned within EWM frameworks.
Follow-up 2. How can teams prevent enhancement gaps before go live?
Answer: by conducting full custom code impact analysis, mapping each WM exit to its EWM equivalent, and executing end-to-end warehouse regression tests.
Follow-up 3. Curveball. Why is ignoring enhancement redesign a strategic risk?
Answer: because silent automation failures degrade warehouse control over time. Missing validations or integrations may not fail immediately, but can create operational drift.
Exclusive pro tip.
Treat every WM enhancement as a redesign project during embedded EWM migration, not a simple code migration task.
Category 10 wrap-up. Warehouse is now an execution engine.
The shift from classic WM to embedded EWM is not a configuration change. It is a warehouse execution redesign. Stock types, handling units, tasks, and enhancements operate under a new architectural layer. Stability requires operational discipline, not just technical activation.
Transition. When planning logic moves to in-memory intelligence.
After warehouse execution stabilizes, the next transformation hits planning. MRP Live replaces classic batch logic with in-memory processing. What worked for decades under MD01 may behave differently under MD01N. This is where planning assumptions are exposed.
Please check description or comments section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers. Required for your SAP functional modules interviews jobs like SAP MM Consultant jobs, SAP FICO Consultant jobs, SAP SD Consultant jobs, SAP PP Consultant jobs, SAP Ariba Consultant jobs, SAP Extended Warehouse Management EWM Consultant jobs, SAP Plant Maintenance PM Consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's Why given 50 question and answers for each section? These questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Category 11, MRP Live MD01N Transformation.
MRP Live introduces an in-memory planning engine that simplifies data access and accelerates execution. However, it does not replicate every classic MRP behavior. Exclusion keys, planning file logic, BAD and availability rules may shift under S/4HANA's simplified architecture.
Scenarios covered in Category 11.
Scenario 60, classic MD01 works but MD01N fails. Primary owner PP cross-module. Supporting MM. Scenario 61, planning file PPH_DBVM inconsistencies. Primary owner PP cross-module. Supporting MM. Scenario 62, MRP exclusion keys not supported in MRP Live. Primary owner PP cross-module. Supporting MM. Scenario 63, custom MRP BAD is not triggered. Primary owner ABAP technical lead. Supporting PP. Scenario 64, MM and PP planning results drift from ECC. Primary owner PP cross-module. Supporting MM. Scenario 65A, ATP replaces classic ATP and availability results differ. Primary owner SD cross-module. Supporting MM.
Scenario 60, classic MD01 works, but MD01N fails after migration.
After migrating to S/4HANA, classic MRP transaction MD01 appears to run successfully, yet MD01N fails or produces incomplete results. Materials are skipped, proposals are missing, or runtime errors occur. The planning data exists, but the new engine behaves differently.
Scenario classification.
1. Complexity high core planning engine risk. 2. Phase configuration and post-go-live planning stabilization. 3. Primary ownership PP cross-module. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
MRP Live does not replicate classic MRP behavior line by line. 1. MD01N uses an in-memory planning engine optimized for HANA. 2. Certain planning scenarios are not supported in MRP Live. 3. Planning file entries were not fully updated for MD01N logic. 4. Custom enhancements tied to classic MRP are not triggered. MD01 and MD01N are not interchangeable engines.
Why this is a migration-exclusive failure.
Classic ECC relied entirely on traditional batch MRP logic. 1. S/4HANA introduces MRP Live as the strategic planning engine. 2. Some classic logic paths are deprecated or restricted. 3. Migration activates MD01N by default in many scenarios. 4. Transformation exposes planning configurations incompatible with MRP Live. Planning behavior shifts under simplified in-memory architecture.
Ownership, who actually fixes it.
Planning engine instability spans configuration and enhancement alignment. 1. PP cross-module lead reviews MRP type and planning configuration. 2. MM validates material master and MRP parameters. 3. ABAP analyzes enhancement compatibility with MRP Live. 4. Basis validates HANA performance and runtime consistency.
Who gets blamed versus who owns it.
When planning proposals disappear, escalation is immediate. 1. Blamed system for not generating procurement proposals. 2. Blamed master data for incorrect planning settings. 3. Actual owner MRP Live compatibility configuration and engine selection. 4. Root cause in-memory planning engine with different supported logic.
How this is actually fixed, the right way by a role.
Stabilization requires structured engine validation. 1. PP validates MRP type compatibility with MRP Live. 2. Unsupported scenarios are identified and rerouted to classic MRP if required. 3. Material master parameters are reviewed systematically. 4. Enhancements are adapted or redesigned for MRP Live framework.
What not to do, common wrong fixes.
Quick engine switching can mask structural issues. 1. Disabling MRP Live globally without impact analysis. 2. Forcing classic MRP as permanent fallback. 3. Ignoring unsupported planning scenarios. 4. Treating MD01N failure as a performance issue only. Engine compatibility must be validated, not assumed.
Follow-up 1. Why does MD01 work while MD01N fails?
Answer: because classic MRP supports broader legacy scenarios. MRP Live is optimized and may restrict certain logic paths not redesigned for in-memory processing.
Follow-up 2. How can teams safely transition to MRP Live?
Answer: by identifying unsupported scenarios, validating planning file consistency, and executing side-by-side comparisons between MD01 and MD01N before go live.
Follow-up 3. Curveball. Why is relying permanently on classic MRP risky in S4?
Answer: because SAP's roadmap prioritizes MRP Live. Delaying transition increases technical debt and future upgrade risk.
Exclusive pro tip.
Validate MRP Live compatibility early in sandbox systems, rather than discovering unsupported scenarios during go live.
Scenario 61. Planning file PPH_DBVM inconsistencies after migration.
After conversion, materials expected to be planned by MRP Live are skipped or partially processed. The planning file table PPH_DBVM contains inconsistent or outdated entries, leading to missing procurement proposals. The system appears operational, yet planning coverage becomes unreliable.
Scenario classification.
1. Complexity high planning coverage risk. 2. Phase data migration and post-go-live stabilization. 3. Primary ownership PP cross-module. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
MRP Live relies on an updated planning file structure introduced in S4HANA. 1. ECC planning file entries were converted into new S4 tables. 2. Incomplete migration of planning indicators causes skip materials. 3. Change pointers were not fully regenerated post-conversion. 4. Parallel planning runs created inconsistent planning flags. MRP Live depends on clean planning file logic to function correctly.
Why this is a migration-exclusive failure.
ECC planning file logic was stable under classic batch processing. 1. S4HANA introduces new planning file persistence logic. 2. Conversion scripts transform legacy indicators into new structures. 3. Migration errors surface only once MRP Live executes. 4. Transformation exposes hidden planning inconsistencies. Planning file instability rarely appears in steady-state ECC.
Ownership, who actually fixes it.
Planning file integrity requires structured validation. 1. PP cross-module lead executes planning file regeneration programs. 2. MM validates material master MRP settings. 3. ABAP reviews custom logic manipulating planning indicators. 4. Basis ensures background jobs complete without interruption.
Who gets blamed versus who owns it.
Missing proposals quickly trigger escalation from production teams. 1. Blamed MRP engine for skipping materials. 2. Blamed master data for incorrect parameters. 3. Actual owner planning file conversion and regeneration alignment. 4. Root cause inconsistent migration of planning indicators.
How this is actually fixed. The right way by a role.
Stabilization requires planning file reset and validation. 1. PP executes full planning file regeneration. 2. Material MRP types and lot sizing procedures are reviewed. 3. Parallel planning runs are eliminated during correction. 4. MRP Live results are compared with classic MRP for validation.
What not to do, common wrong fixes.
Surface fixes create recurring planning instability. 1. Manually creating procurement proposals without root cause analysis. 2. Running partial regeneration without full scope validation. 3. Switching planning engines repeatedly. 4. Ignoring change pointer inconsistencies. Planning file consistency underpins reliable MRP Live execution.
Follow-up 1. Why are only some materials skipped?
Answer: because only materials with inconsistent planning indicators are affected. Others remain properly flagged and processed by MRP Live.
Follow-up 2. How can teams detect planning file issues early?
Answer: by performing mass planning file checks post-conversion and validating material coverage before production planning cycles begin.
Follow-up 3. Curveball. Why does planning file inconsistency create silent risk?
Answer: because missing proposals may not trigger technical errors. Production shortages appear days later, making root cause tracing difficult.
Exclusive pro tip.
Always regenerate and validate planning files immediately after migration, before executing the first full MRP live run.
Scenario 62. MRP exclusion keys not supported in MRP Live.
After activating MRP Live, planners notice that certain materials previously excluded from planning are now being considered. Exclusion keys that worked reliably in classic MRP no longer behave as expected. The result is unexpected procurement proposals and planning noise.
Scenario classification.
1. Complexity, medium to high planning logic drift. 2. Phase, configuration and planning stabilization. 3. Primary ownership, PP cross-module. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
MRP Live does not support every classic exclusion logic path. 1. Certain exclusion keys are not compatible with MRP Live processing. 2. Classic planning logic relied on batch-based evaluation steps. 3. MRP Live simplifies processing and ignores unsupported scenarios. 4. Configuration assumptions were not validated against MD01N behavior. Unsupported exclusion logic creates silent planning expansion.
Why this is a migration-exclusive failure.
ECC supported broader planning logic flexibility. 1. S/4HANA optimizes planning scenarios for in-memory processing. 2. Migration shifts execution to MRP Live by default. 3. Unsupported configuration elements are quietly ignored. 4. Transformation exposes planning logic no longer strategically supported. Planning simplification changes behavioral expectations.
Ownership, who actually fixes it.
Resolution requires planning configuration redesign. 1. PP cross-module lead reviews exclusion key usage across materials. 2. MM validates material master planning relevance. 3. ABAP analyzes custom planning logic if implemented. 4. Testing team performs comparative MD01 versus MD01 and validation.
Who gets blamed versus who owns it.
Unexpected procurement proposals trigger immediate confusion. 1. Blamed MRP engine for planning unnecessary materials. 2. Blamed master data for incorrect exclusion flags. 3. Actual owner planning configuration not validated for MRP Live. 4. Root cause, unsupported exclusion logic in in-memory engine.
How this is actually fixed, the right way by a role.
Correction requires compatibility review and redesign. 1. PP identifies unsupported exclusion keys and redesigns planning control. 2. Material master settings are standardized across plants. 3. MRP Live compatibility documentation is reviewed thoroughly. 4. Side-by-side test runs confirm planning consistency.
What not to do, common wrong fixes.
Temporary suppression increases long-term instability. 1. Disabling MRP Live globally without root cause analysis. 2. Manually deleting unwanted procurement proposals. 3. Ignoring unsupported configuration warnings. 4. Treating unexpected proposals as performance glitches. Planning configuration must evolve with engine capability.
Follow-up 1. How can teams identify unsupported exclusion keys early?
Answer: by reviewing SAP documentation for MRP Live supported scenarios and running pilot comparisons between classic MRP and MRP Live before migration freeze.
Follow-up 2. Can exclusion behavior be replicated in MRP Live?
Answer: in some cases, alternative configuration or planning parameters can achieve similar outcomes. However, direct one-to-one logic replication is not always possible.
Follow-up 3. Curveball. Why is silent planning expansion more dangerous than visible errors?
Answer: because it creates procurement noise without technical failure. Excess proposals distort planning KPIs and can lead to unnecessary purchasing decisions.
Exclusive pro tip.
Validate all planning exclusion logic in MRP Live during sandbox testing. Unsupported logic should be redesigned, not assumed to function automatically.
Scenario 63. Custom MRP add is not triggered in MRP Live.
After switching to MRP Live, custom logic implemented through classic MRP add is or user exit stops triggering. Planning runs complete without errors, yet special procurement logic, safety stock overrides, or custom prioritization rules are silently ignored. The system appears stable, but planning intelligence is degraded.
Scenario classification.
1. Complexity critical custom planning logic failure. 2. Phase code remediation and post-go-live stabilization. 3. Primary ownership ABAP technical lead. 4. Supporting PP.
Why this happens, scenario analysis and root cause.
MRP Live uses a different enhancement framework than classic MRP. 1. Classic MRP BAD is are not triggered in MD01N processing. 2. MRP Live supports a restricted set of enhancement spots. 3. Custom logic was tied to batch-oriented processing steps. 4. Enhancement redesign was not included in migration scope. Enhancement compatibility must be validated for MRP Live.
Why this is a migration-exclusive failure.
ECC allowed broad enhancement flexibility in planning. 1. S/4HANA simplifies planning architecture for in-memory processing. 2. Unsupported enhancement hooks are bypassed silently. 3. Migration shifts engine execution without auto-migrating enhancements. 4. Transformation exposes reliance on legacy enhancement frameworks. Custom logic must evolve with planning engine design.
Ownership, who actually fixes it.
Restoring custom logic requires structured redesign. 1. ABAP technical lead identifies unsupported BAD is and redesigns logic. 2. PP validates business requirements for planning behavior. 3. Testing team executes side-by-side MRP comparison runs. 4. Basis ensures runtime stability during redesign testing.
Who gets blamed versus who owns it.
When planning logic changes silently, escalation is immediate. 1. Blamed developers for missing enhancement logic. 2. Blamed planning team for incorrect configuration. 3. Actual owner enhancement redesign aligned to MRP Live framework. 4. Root cause engine shift without enhancement adaptation.
How this is actually fixed, the right way by a role.
Correction requires enhancement realignment, not code copying. 1. ABAP maps classic enhancement logic to MRP Live supported BAD is. 2. PP validates functional equivalence under new engine behavior. 3. Regression tests compare MD01 and MD01N outputs. 4. Unsupported logic is redesigned instead of forced.
What not to do, common wrong fixes.
Temporary engine fallback creates technical debt. 1. Forcing classic MRP permanently to preserve custom logic. 2. Copying legacy BAD is without compatibility checks. 3. Ignoring enhancement redesign until post-go-live. 4. Embedding logic in unsupported implicit enhancements. Planning enhancements must be re-architected, not reactivated.
Follow-up 1. Why does MRP Live ignore classic BAD is?
Answer: because MRP Live is designed with a simplified and performance-optimized architecture. Only specific enhancement points are supported to maintain HANA efficiency.
Follow-up 2. How can teams detect enhancement gaps before go live?
Answer: by executing detailed comparison tests between MD01 and MD01 in outputs, and verifying that all custom planning behavior is triggered as expected.
Follow-up 3. Curveball. Why is silent enhancement failure more dangerous than runtime errors?
Answer: because no technical failure is reported. Planning logic degrades quietly, leading to incorrect procurement decisions without immediate visibility.
Exclusive pro tip.
Perform a full custom code impact analysis specifically for MRP Live enhancement compatibility before activating MD01N in production.
Scenario 64. MM and PP planning results drift from ECC after migration.
After go live on S/4HANA, planners notice that procurement proposals, planned orders, or rescheduling results differ from what ECC previously generated. No technical errors occur, yet planning outputs are no longer identical. The system is working, but the behavior has shifted.
Scenario classification.
1. Complexity, high cross-module planning alignment risk. 2. Phase post-go-live stabilization. 3. Primary ownership PP cross-module. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
MRP Live and simplified planning logic alter calculation sequencing. 1. Planning run sequencing differs under in-memory processing. 2. Lot sizing and rounding rules behave slightly differently. 3. Rescheduling logic is optimized for HANA performance. 4. Configuration dependencies were not fully revalidated. Planning drift often reflects logic optimization, not system failure.
Why this is a migration-exclusive failure?
ECC planning outputs were shaped by classic batch engine behavior. 1. S/4HANA simplifies planning architecture. 2. MRP live processes materials differently than legacy runs. 3. Migration shifts engine logic without recalibrating expectations. 4. Transformation exposes assumptions embedded in ECC behavior. Behavioral differences are structural, not random.
Ownership, who actually fixes it?
Planning drift requires structured validation, not blame shifting. 1. PP cross-module lead performs side-by-side ECC versus S4 comparisons. 2. MM validates material master and lot sizing settings. 3. ABAP reviews enhancement impact on planning calculations. 4. Leadership aligns business tolerance for acceptable variance.
Who gets blamed versus who owns it?
When outputs differ, tension spreads quickly. 1. Blamed MRP live for changing logic. 2. Blamed master data for incorrect parameters. 3. Actual owner cross-module validation of planning configuration. 4. Root cause engine optimization and logic simplification.
How this is actually fixed, the right way by a role.
Stabilization requires evidence-based comparison. 1. Side-by-side planning runs are executed in test systems. 2. Configuration differences are documented and rationalized. 3. Business tolerance thresholds are defined formally. 4. Enhancements are adjusted to align with new engine sequencing.
What not to do, common wrong fixes.
Forcing identical results may undermine optimization. 1. Blindly reverting to classic MRP. 2. Manipulating lot sizing values to match ECC output artificially. 3. Declaring S4 incorrect without structured comparison. 4. Ignoring performance-driven logic adjustments. Planning equivalence must be validated, not assumed.
Follow-up 1. Should S4 planning results match ECC exactly?
Answer: not necessarily. S/4HANA may optimize sequencing and performance. The focus should be on business correctness, not byte-level output matching.
Follow-up 2. How do teams decide if drift is acceptable?
Answer: by defining measurable planning, KPIs such as service level, stock coverage, and procurement lead time stability, rather than exact document count comparison.
Follow-up 3. Curveball. Why can insisting on identical ECC behavior slow innovation?
Answer: because S/4HANA is designed to simplify and optimize. Forcing legacy replication prevents adoption of improved planning capabilities.
Exclusive pro tip.
Focus on planning outcome stability rather than exact procedural replication when validating S/4HANA MRP behavior.
Scenario 65. A. ATP replaces classic ATP and availability results differ.
After migration to S/4HANA, availability checks during sales order processing no longer match ECC behavior. Confirmed quantities, delivery dates, or partial confirmations differ. No technical error occurs, yet business users report inconsistent promise dates and unexpected stock allocations.
Scenario classification.
1. Complexity critical order fulfillment risk. 2. Phase configuration and post-go-live stabilization. 3. Primary ownership SD cross-module. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
Advanced ATP introduces redesigned availability logic under S/4HANA. 1. A. ATP replaces classic ATP logic with rule-based availability checks. 2. Backorder processing and product allocation behave differently. 3. Check control and scope of check settings were not fully revalidated. 4. Migration activates ATP without recalibrating business expectations. Availability logic is re-architected, not merely upgraded.
Why this is a migration-exclusive failure.
Classic ECC ATP relied on simpler stock confirmation logic. 1. S/4HANA introduces advanced ATP capabilities by default. 2. Availability rules are processed using new prioritization models. 3. Migration shifts confirmation logic without replicating old sequencing. 4. Transformation exposes hidden dependencies between MM and SD settings. Availability behavior shifts structurally in S/4HANA.
Ownership, who actually fixes it.
Stabilization requires cross-functional validation. 1. SD cross-module lead reviews check control and confirmation strategies. 2. MM validates stock determination and scope of check configuration. 3. PP ensures supply proposals align with confirmation logic. 4. Testing team executes controlled order simulation scenarios.
Who gets blamed versus who owns it.
When customer confirmations change, escalation is immediate. 1. Blamed warehouse for incorrect stock availability. 2. Blamed planning for inaccurate supply proposals. 3. Actual owner A. ATP configuration and cross-module alignment. 4. Root cause redesigned availability engine with different prioritization.
How this is actually fixed, the right way by a role.
Correction requires rule-based configuration review. 1. SD revalidates confirmation control and backorder processing rules. 2. MM reviews stock determination and allocation settings. 3. Comparative testing between ECC ATP and ATP is executed. 4. Business tolerance for confirmation variance is formally defined.
What not to do, common wrong fixes.
Suppressing logic drift increases downstream risk. 1. Disabling ATP without impact analysis. 2. Manually overriding confirmations in production. 3. Ignoring rule-based prioritization changes. 4. Assuming warehouse or planning errors without configuration review. Availability redesign must be governed, not bypassed.
Follow-up 1. Should ATP confirmations match classic ATP exactly?
Answer: not necessarily. ATP introduces prioritization and advanced allocation logic. The objective is business consistency, not historical replication.
Follow-up 2. How can teams safely validate ATP behavior?
Answer: by executing controlled order simulations across plants and materials, comparing confirmation logic under real supply and demand scenarios.
Follow-up 3. Curveball. Why is availability drift more sensitive than planning drift?
Answer: because availability impacts customer commitments directly. Incorrect confirmations affect revenue recognition, delivery performance, and customer trust immediately.
Exclusive pro tip.
Treat ATP activation as a customer commitment redesign project, not just a technical migration task.
Category 11 wrap-up. Planning intelligence has changed.
MRP Live and ATP are not technical upgrades. They redefine planning and availability logic under S/4HANA's in-memory architecture. Stability requires validation, redesign, and cross-module alignment, rather than assuming ECC behavior will replicate automatically.
Transition. When compliance architecture is rewritten.
After planning stabilizes, international trade becomes the next structural shift. Foreign trade tables disappear, compliance logic moves outward, and integration with GTS becomes central. This is not a reporting issue. It is a regulatory architecture transformation.
Category 12. International trade, foreign trade replacement.
S/4HANA removes classic foreign trade tables and replaces legacy compliance handling with redesigned integration and reporting mechanisms. Intrastat logic, commodity code handling, and export control validation shift structurally. Migration exposes dependencies that ECC silently tolerated.
Scenarios covered in Category 12.
Scenario 66, ECC foreign trade tables ICP and IPO removed. Primary owner SD cross-module. Supporting MM. Scenario 67, intrastat reporting breaks post-migration. Primary owner SD cross-module. Supporting FI. Scenario 68, commodity codes not migrated properly. Primary owner MM data-led. Supporting data. Scenario 69, GTS integration becomes mandatory. Primary owner SD cross-module. Supporting integration. Scenario 70, export and import control logic behaves differently. Primary owner SD cross-module. Supporting compliance.
Scenario 66. ECC foreign trade tables, EIKP and EIPO removed.
After migration to S/4HANA, custom reports and interfaces referencing classic foreign trade tables, EIKP and EIPO begin failing. Data that once stored export and import information is no longer available in the same structure. Transactions execute, but reporting and compliance integrations break silently.
Scenario classification.
1. Complexity, critical compliance and reporting risk. 2. Phase, code remediation and post-conversion stabilization. 3. Primary ownership, SD cross-module. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
S/4HANA removes classic foreign trade data structures. 1. Tables EIKP and EIPO are deprecated in S/4HANA. 2. Foreign trade functionality is restructured or shifted toward GTS. 3. Custom code still references obsolete data tables. 4. Migration does not automatically refactor dependent enhancements. Compatibility views do not replicate full foreign trade behavior.
Why this is a migration-exclusive failure.
ECC relied on embedded foreign trade tables for compliance logic. 1. S/4HANA simplifies the data model and removes legacy trade structures. 2. Migration retains transactional flow but not table persistence. 3. Reporting and integrations tied to old tables collapse post-conversion. 4. Transformation exposes reliance on obsolete compliance storage. Foreign trade logic must be redesigned, not assumed portable.
Ownership, who actually fixes it.
Stabilization requires redesign of compliance data access. 1. SD cross-module lead reviews foreign trade and export processes. 2. ABAP refactors custom reports and interfaces using new structures. 3. Integration adjusts data feeds toward GTS or alternative systems. 4. Compliance team validates regulatory reporting integrity.
Who gets blamed versus who owns it.
Compliance failures escalate quickly due to regulatory exposure. 1. Blamed IT for breaking reporting logic. 2. Blamed SAP for removing tables. 3. Actual owner custom code dependency on obsolete structures. 4. Root cause structural simplification in S/4HANA data model.
How this is actually fixed, the right way by a role.
Correction requires redesign, not reactivation. 1. ABAP replaces direct table reads with released CDS views or APIs. 2. SD validates compliance logic under new architecture. 3. Integration aligns with GTS where required. 4. Full regression testing ensures regulatory accuracy.
What not to do, common wrong fixes.
Short-term compatibility hacks increase audit risk. 1. Creating shadow tables to mimic EIKP and EIPO. 2. Hard-coding old structures into new programs. 3. Ignoring compliance validation during testing. 4. Assuming GTS integration is optional. Compliance redesign must be treated as mandatory migration scope.
Follow-up 1. Why were foreign trade tables removed in S/4HANA?
Answer: because SAP streamlined the data model and shifted international trade compliance toward integrated or externalized solutions such as GTS. Legacy persistence was not aligned with strategic architecture.
Follow-up 2. Can compatibility views fully replace EIKP and EIPO?
Answer: no. Compatibility views may provide limited data access but do not replicate full compliance logic or event handling embedded in ECC.
Follow-up 3. Curveball. Why is foreign trade redesign considered high risk?
Answer: because regulatory reporting failures can result in penalties, shipment delays, and audit exposure. Even minor data inconsistencies may have legal consequences.
Exclusive pro tip.
Perform a full custom code scan for EIKP and EIPO references before conversion. Treat every hit as compliance-critical remediation.
Scenario 67. Intrastat reporting breaks post-migration.
After go-live on S/4HANA, intrastat declarations generate incorrect totals, missing transactions, or validation errors. No core logistics transaction fails, yet compliance reporting becomes unreliable. Finance and trade compliance teams escalate immediately due to regulatory exposure.
Scenario classification.
1. Complexity, critical regulatory reporting risk. 2. Phase, post-go-live stabilization. 3. Primary ownership, SD cross-module. 4. Supporting FI.
Why this happens, scenario analysis and root cause.
Intrastat logic depends on correct foreign trade and material master alignment. 1. Foreign trade tables were restructured or removed in S/4HANA. 2. Commodity codes or country indicators were not migrated consistently. 3. Reporting programs rely on new data sources or CDS views. 4. Configuration for statistical values was not revalidated. Compliance reporting shifts from table-based logic to structured CDS-driven models.
Why this is a migration-exclusive failure.
ECC embedded intrastat reporting tightly into legacy structures. 1. S/4HANA simplifies the data model and shifts compliance logic. 2. Migration preserves transactions but alters reporting foundations. 3. Legacy custom enhancements may no longer align with CDS reporting. 4. Transformation exposes configuration dependencies previously hidden. Regulatory logic must be revalidated under the new architecture.
Ownership, who actually fixes it.
Compliance correction requires structured cross-functional validation. 1. SD cross-module lead reviews trade and intrastat configuration. 2. FI validates statistical values and reporting alignment. 3. ABAP refactors custom intrastat reports using released views. 4. Compliance team validates regulatory accuracy before submission.
Who gets blamed versus who owns it.
Regulatory discrepancies create immediate escalation pressure. 1. Blamed IT for broken reporting. 2. Blamed finance for incorrect statistical values. 3. Actual owner trade configuration and data migration alignment. 4. Root cause structural reporting redesign in S/4HANA.
How this is actually fixed. The right way by a role.
Resolution requires structured reporting reconciliation. 1. SD revalidates foreign trade configuration and determination logic. 2. FI verifies statistical values and country codes. 3. ABAP adapts custom reporting to new CDS-based structures. 4. Parallel reporting comparisons are executed before regulatory submission.
What not to do, common wrong fixes.
Temporary workarounds increase compliance exposure. 1. Manually adjusting declaration totals without root cause analysis. 2. Submitting reports without structured reconciliation. 3. Reactivating deprecated foreign trade tables. 4. Assuming reporting differences are minor formatting issues. Regulatory reporting errors carry financial and legal risk.
Follow-up 1. Why do transactions post correctly but intrastat fails?
Answer: because operational posting logic is independent from statistical reporting logic. S/4HANA may process transactions correctly, while reporting structures derive data differently.
Follow-up 2. How can teams validate intrastat before first submission?
Answer: by running parallel ECC and S4 simulations using identical data sets and reconciling totals, country indicators, and statistical values.
Follow-up 3. Curveball. Why is intrastat drift often detected late?
Answer: because reporting cycles are periodic. Errors surface only at month-end or quarter-end, when regulatory submission is due.
Exclusive pro tip.
Treat the first intrastat submission in S4HANA as a controlled compliance audit, not a routine report run.
Scenario 68. Commodity codes not migrated properly.
After migration, export and import transactions begin failing compliance checks or generating incomplete declarations. Commodity codes appear missing, outdated, or inconsistent across plants. Operational documents post successfully, but trade classification becomes unreliable.
Scenario classification.
1. Complexity, high compliance and data integrity risk. 2. Phase, data migration and post-go-live stabilization. 3. Primary ownership, data-led. 4. Supporting data.
Why this happens. Scenario analysis and root cause.
Commodity codes depend on accurate material master migration. 1. Commodity codes were stored differently in ECC structures. 2. Migration scripts did not fully align classification fields. 3. Plant-specific or country-specific codes were overlooked. 4. Custom classification enhancements were not remapped. Trade classification integrity depends on disciplined data migration.
Why this is a migration-exclusive failure.
ECC trade classification evolved organically over years. 1. S/4HANA simplifies and restructures trade data persistence. 2. Migration transforms classification fields into new models. 3. Legacy inconsistencies surface only during compliance validation. 4. Transformation reveals gaps in master data governance. Classification errors are often historical, not newly created.
Ownership, who actually fixes it?
Correction requires structured master data remediation. 1. MM Data-led reviews material master classification consistency. 2. Data team validates migration mapping and field completeness. 3. SD confirms export and import process alignment. 4. Compliance team validates regulatory correctness.
Who gets blamed versus who owns it?
When shipments are blocked, operational tension escalates. 1. Blame trade compliance for incorrect codes. 2. Blamed IT for migration errors. 3. Actual owner master data migration and governance discipline. 4. Root cause historical classification inconsistencies exposed.
How this is actually fixed, the right way by a role.
Stabilization requires controlled data cleansing. 1. Mass validation of commodity codes across plants and countries. 2. Data cleansing and enrichment where gaps are identified. 3. Re-execution of compliance checks post-remediation. 4. Implementation of stronger governance controls for future updates.
What not to do, common wrong fixes.
Temporary overrides increase compliance exposure. 1. Manually overriding blocked shipments without root cause resolution. 2. Applying blanket commodity codes across materials. 3. Ignoring plant-specific classification requirements. 4. Assuming historical data is automatically accurate. Trade compliance errors carry regulatory and financial risk.
Follow-up 1. Why do commodity code issues appear only after go-live?
Answer: because compliance validation typically triggers during real export or import transactions. Test scenarios may not cover all country and plant combinations.
Follow-up 2. How can teams prevent classification gaps during migration?
Answer: by executing structured master data audits before conversion and validating commodity codes against current regulatory standards.
Follow-up 3. Curveball. Why are commodity codes considered high-risk master data?
Answer: because incorrect classification can result in shipment delays, penalties, and reputational damage. Even small errors may have significant legal implications.
Exclusive pro tip.
Treat commodity code migration as a regulatory audit exercise, not just a data mapping task.
Scenario 69. GTS integration becomes mandatory after migration.
After moving to S/4HANA, the embedded foreign trade functionality no longer supports all compliance scenarios. Organizations discover that SAP Global Trade Services integration is now required to handle export control, sanctioned party screening, and customs processes. Shipments begin failing because compliance checks are incomplete.
Scenario classification.
1. Complexity, critical compliance and integration architecture risk. 2. Phase, architecture redesign and post-go-live stabilization. 3. Primary ownership, SD cross-module. 4. Supporting integration.
Why this happens, scenario analysis and root cause.
S/4HANA shifts international trade compliance toward GTS-centric architecture. 1. Classic embedded foreign trade logic is reduced or removed. 2. Compliance checks such as sanctioned party screening are externalized. 3. Integration with GTS was not fully scoped during migration. 4. Transactional processes continue while compliance validation gaps expand. Compliance responsibility shifts from embedded logic to integrated architecture.
Why this is a migration-exclusive failure.
ECC allowed more embedded foreign trade functionality. 1. S/4HANA streamlines core ERP and externalizes trade services. 2. Migration changes architectural responsibility for compliance. 3. Projects underestimate GTS integration effort during conversion. 4. Transformation exposes dependency on external compliance engines. Compliance architecture becomes distributed rather than embedded.
Ownership, who actually fixes it.
Resolution requires structured integration governance. 1. SD cross-module lead validates trade process requirements. 2. Integration team designs and stabilizes GTS interface flows. 3. Compliance team verifies screening and export control coverage. 4. Basis ensures connectivity and performance stability.
Who gets blamed versus who owns it.
When shipments are blocked, operational pressure escalates rapidly. 1. Blamed logistics for shipment delays. 2. Blamed IT for missing integration setup. 3. Actual owner, trade architecture redesign, and GTS scope planning. 4. Root cause, underestimated compliance externalization during migration.
How this is actually fixed, the right way by a role.
Correction requires full compliance integration alignment. 1. Integration establishes reliable and monitored GTS interfaces. 2. SD validates document flow from sales to customs declaration. 3. Compliance executes end-to-end screening simulations. 4. Governance enforces mandatory compliance checks before shipment.
What not to do, common wrong fixes.
Bypassing compliance controls increases legal exposure. 1. Disabling screening checks temporarily to release shipments. 2. Assuming GTS is optional for regulated industries. 3. Treating integration as a minor technical interface. 4. Ignoring performance and monitoring requirements. Compliance integration must be treated as mission-critical architecture.
Follow-up 1. Why is GTS more important in S/4HANA than in ECC?
Answer: because S/4HANA reduces embedded foreign trade functionality and positions GTS as the strategic compliance engine. Architectural responsibility shifts toward dedicated trade systems.
Follow-up 2. Can organizations operate without GTS in S4?
Answer: in limited scenarios, yes. However, for regulated export and import environments, lack of GTS integration increases compliance risk significantly.
Follow-up 3. Curveball. Why do projects underestimate GTS scope?
Answer: because compliance logic was historically embedded and invisible. Migration makes compliance architecture explicit, expanding integration complexity.
Exclusive pro tip.
Assess GTS scope during blueprint phase, not after discovering blocked shipments in production.
Scenario 70. Export and import control logic behaves differently.
After migration to S/4HANA, export and import control checks begin triggering differently. Some documents that passed in ECC are now blocked, while others proceed without expected validation. Operational processes continue, but compliance teams detect inconsistencies in license checks, embargo validations, or customs documentation.
Scenario classification.
1. Complexity, critical regulatory and legal exposure. 2. Phase, post-go-live stabilization. 3. Primary ownership, SD cross-module. 4. Supporting compliance.
Why this happens, scenario analysis and root cause.
S/4HANA restructures how export and import controls are evaluated. 1. Foreign trade tables and embedded logic are simplified or removed. 2. Compliance checks may now rely on GTS or redesigned validation flows. 3. License determination and embargo logic are recalculated differently. 4. Configuration alignment was not fully validated after migration. Control logic shifts structurally rather than cosmetically.
Why this is a migration-exclusive failure.
ECC, embedded trade control logic directly into transactional flow. 1. S/4HANA separates compliance logic more clearly from core transactions. 2. Migration changes data persistence and validation sequencing. 3. Historical assumptions about automatic checks no longer hold. 4. Transformation exposes weak governance around export control configuration. Compliance logic must be revalidated under new architecture.
Ownership, who actually fixes it.
Compliance stabilization requires structured cross-functional review. 1. SD cross-module lead reviews document flow and compliance integration. 2. Compliance team validates license and embargo determination logic. 3. Integration team ensures proper connectivity to GTS if applicable. 4. ABAP adjusts custom validation enhancements.
Who gets blamed versus who owns it.
Compliance blocks often create operational tension. 1. Blamed sales or logistics for document errors. 2. Blamed IT for breaking validation checks. 3. Actual owner trade compliance configuration and architectural redesign. 4. Root cause, structural shift in export and import control logic.
How this is actually fixed, the right way by a role.
Resolution requires end-to-end compliance revalidation. 1. Compliance performs structured license and embargo scenario testing. 2. SD validates document type configuration and trade determination logic. 3. Integration ensures complete data transfer to compliance systems. 4. Governance enforces documented compliance validation checkpoints.
What not to do, common wrong fixes.
Bypassing controls introduces severe legal exposure. 1. Temporarily disabling export control checks. 2. Granting broad override authorizations to users. 3. Assuming ECC configuration can be copied directly. 4. Ignoring blocked document patterns without analysis. Export control logic is a legal safeguard, not a system inconvenience.
Follow-up 1. Why do some documents pass while others are blocked?
Answer: because determination logic may depend on material classification, country codes, or license configuration that changed during migration.
Follow-up 2. How can teams validate export control stability after migration?
Answer: by executing full end-to-end compliance simulations across representative countries, materials, and business partners before regulatory submission.
Follow-up 3. Curveball. Why is compliance drift often underestimated during projects?
Answer: because compliance processes run in the background during ECC operations. Migration makes compliance architecture visible and exposes hidden dependencies.
Exclusive pro tip.
Treat export and import control validation as a legal readiness audit, not just a configuration review.
Category 12 wrap-up. Compliance is now architecture.
International trade in S/4HANA is no longer an embedded afterthought. It is an architectural decision involving integration, compliance, and governance. Projects that treat foreign trade as configuration only often discover regulatory risk too late.
Transition. When commercial logic is rewritten.
If foreign trade exposed regulatory architecture shifts, settlement management exposes commercial logic shifts. S/4HANA replaces the classic rebate engine with condition contract management. This is not a technical migration, it is a financial redesign.
Please check description or comment section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP functional modules interviews jobs like SAP MM Consultant jobs, SAP FICO Consultant jobs, SAP SD Consultant jobs, SAP PP Consultant jobs, SAP Ariba Consultant jobs, SAP Extended Warehouse Management EWM Consultant jobs, SAP Plant Maintenance PM Consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section. These questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Category 13. Settlement management. Rebate engine replacement.
S/4HANA eliminates the classic rebate processing model and replaces it with condition contract management. Accrual logic, settlement flows, and document behavior change structurally. Migration exposes assumptions built into pricing, FI postings, and reporting reconciliation.
Scenarios covered in Category 13.
Scenario 71, subsequent settlement agreements don't migrate. Primary owner SD cross-module, supporting MM. Scenario 72, condition contract management not configured. Primary owner SD cross-module, supporting FI. Scenario 73, old rebate logic produces no accruals. Primary owner FI cross-module, supporting SD. Scenario 74, settlement documents differ from ECC. Primary owner SD cross-module, supporting FI. Scenario 75, performance issues in CCM processing. Primary owner SD technical lead. Supporting basis.
Scenario 71. Subsequent settlement agreements don't migrate.
During conversion to S/4HANA, legacy rebate agreements fail to migrate into condition contract management. Existing agreements appear missing, partially converted, or structurally incompatible. Business users discover that expected rebate accruals and settlements are no longer visible.
Scenario classification.
1. Complexity, high revenue and accrual risk. 2. Phase, data migration and functional conversion. 3. Primary ownership, SD cross-module. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
Classic rebate processing is replaced entirely in S/4HANA. 1. ECC rebate agreements use legacy condition techniques. 2. S/4HANA requires condition contract management structures. 3. Conversion programs do not automatically replicate all agreement logic. 4. Historical custom enhancements are not compatible with CCM. Rebate logic is redesigned, not migrated one-to-one.
Why this is a migration-exclusive failure.
Rebate functionality removal occurs only during S/4 transformation. 1. ECC supports classic rebate processing natively. 2. S/4HANA removes the old rebate engine completely. 3. Migration requires functional redesign rather than technical conversion. 4. Transformation exposes gaps in rebate configuration discipline. No steady-state ECC system faces this structural replacement.
Ownership, who actually fixes it.
Stabilization requires functional and financial alignment. 1. SD redesigns agreements using condition contract management. 2. MM validates purchasing-related rebate implications. 3. FI reviews accrual and revenue recognition impact. 4. Data team validates agreement master data completeness.
Who gets blamed versus who owns it.
When accruals disappear, financial pressure rises quickly. 1. Blamed IT for failed migration. 2. Blamed finance for incorrect reporting. 3. Actual owner functional redesign of rebate logic. 4. Root cause structural replacement of rebate engine.
How this is actually fixed. The right way by a role.
Correction requires structured CCM activation and validation. 1. SD configures condition contract management properly. 2. Existing agreements are recreated or migrated via structured conversion. 3. FI validates accrual posting logic under new framework. 4. End-to-end settlement testing is executed before production stabilization.
What not to do, common wrong fixes.
Shortcuts distort financial transparency. 1. Manually adjusting accrual postings without root cause analysis. 2. Recreating agreements without validating condition mapping. 3. Attempting to reactivate obsolete rebate configuration. 4. Ignoring performance and settlement timing validation. Commercial logic must be revalidated structurally.
Follow-up 1. Why can't classic rebate agreements simply be copied?
Answer: because S/4HANA removes the legacy rebate engine entirely. Condition contract management introduces new master data objects and posting logic that are not one-to-one compatible.
Follow-up 2. How should projects prepare for this shift?
Answer: by identifying all active rebate agreements early and mapping them to CCM equivalents during blueprint. Functional workshops are essential before technical migration.
Follow-up 3. Curveball. Why do rebate issues often surface late?
Answer: because settlement cycles are periodic. Accrual discrepancies become visible only during financial closing or partner settlement runs.
Exclusive pro tip.
Treat rebate engine replacement as a revenue model redesign, not a configuration update.
Scenario 72. Condition contract management not configured.
After migration, settlement processes are technically available in S/4HANA, but condition contract management is not properly configured. Business users attempt to create new agreements, yet accruals do not post, settlements fail, or pricing conditions do not trigger as expected.
Scenario classification.
1. Complexity, high financial accrual and revenue risk. 2. Phase, configuration and post-go-live stabilization. 3. Primary ownership, SD cross-module. 4. Supporting FI.
Why this happens, scenario analysis and root cause.
CCM is not automatically activated with full configuration during conversion. 1. Settlement management was not fully scoped during blueprint. 2. Condition types were not reassigned to CCM structures. 3. Account determination was not mapped to new accrual postings. 4. Pricing procedures still reference legacy rebate logic. Availability of functionality does not equal readiness of configuration.
Why this is a migration-exclusive failure.
ECC rebate engine function with legacy configuration. 1. S/4HANA removes classic rebate processing entirely. 2. Condition contract management requires new setup steps. 3. Migration does not auto-convert configuration dependencies. 4. Transformation exposes incomplete commercial design decisions. CCM must be intentionally configured, not assumed.
Ownership, who actually fixes it.
Resolution requires functional and financial coordination. 1. SD configures CCM objects, settlement processes, and condition types. 2. FI validates account determination and accrual postings. 3. MM confirms purchasing-related agreement integration if applicable. 4. ABAP adjusts any custom enhancements referencing old rebate logic.
Who gets blamed versus who owns it.
When accruals fail, financial tension escalates rapidly. 1. Blamed finance for missing accrual entries. 2. Blamed IT for incomplete migration. 3. Actual owner functional configuration gap in CCM. 4. Root cause blueprint did not fully redesign rebate processes.
How this is actually fixed, the right way by a role.
Stabilization requires structured configuration validation. 1. SD activates and configures CCM settlement structures properly. 2. FI tests accrual posting logic across scenarios. 3. End-to-end pricing and settlement simulations are executed. 4. Governance ensures CCM documentation and process training.
What not to do, common wrong fixes.
Temporary accounting workarounds distort financial integrity. 1. Manually posting accruals without CCM alignment. 2. Reactivating legacy rebate condition types. 3. Ignoring settlement simulation results. 4. Delaying CCM configuration until after go-live. Incomplete CCM configuration creates compounding revenue risk.
Follow-up 1. Why does CCM configuration require deeper testing than classic rebates?
Answer: because CCM integrates tightly with pricing, FI postings, and settlement documents. Errors impact revenue recognition and accrual integrity across modules.
Follow-up 2. How can teams validate CCM readiness before go-live?
Answer: by executing settlement simulations covering full contract lifecycle scenarios including accrual posting, partial settlement, and final reconciliation.
Follow-up 3. Curveball. Why is CCM often underestimated during migration?
Answer: because rebates are viewed as pricing details. In reality, settlement management affects financial reporting and revenue recognition significantly.
Exclusive pro tip.
Never treat condition contract management as a pricing enhancement. It is a financial control framework.
Scenario 73. Old rebate logic produces no accruals.
After migration, sales documents process successfully, but expected rebate accrual postings do not appear in FI. Settlement agreements exist, pricing appears correct, yet no accrual entries are generated. Finance detects revenue distortion during period-end review.
Scenario classification.
1. Complexity, critical revenue recognition and accrual integrity risk. 2. Phase, post-go-live stabilization. 3. Primary ownership, FI cross-module. 4. Supporting SD.
Why this happens, scenario analysis and root cause.
Legacy rebate assumptions persist while the underlying engine has changed. 1. Old rebate condition types were not mapped to CCM accrual logic. 2. Account determination for accrual postings was not reassigned. 3. Settlement management configuration was incomplete. 4. Pricing procedures still reference obsolete rebate condition keys. Pricing execution does not guarantee accrual posting.
Why this is a migration-exclusive failure.
Classic rebate engine generated accruals automatically in ECC. 1. S/4HANA removes classic rebate posting logic entirely. 2. Accrual logic is now governed by condition contract management. 3. Migration requires structural financial redesign. 4. Transformation exposes dependency between pricing and FI integration. Accrual generation logic is redesigned, not carried forward.
Ownership, who actually fixes it?
Financial stabilization requires cross-functional redesign. 1. FI validates account determination and accrual posting logic. 2. SD aligns pricing procedures with CCM condition types. 3. ABAP adjusts any custom logic interfering with accrual triggers. 4. Controlling confirms revenue recognition alignment.
Who gets blamed versus who owns it?
Missing accruals create immediate financial concern. 1. Blamed sales for incorrect pricing setup. 2. Blamed IT for migration gaps. 3. Actual owner FI and SD alignment in CCM configuration. 4. Root cause legacy rebate logic not structurally replaced.
How this is actually fixed, the right way by a role.
Restoring accrual integrity requires structured validation. 1. FI validates accrual account determination and posting keys. 2. SD ensures condition types trigger CCM accrual events. 3. End-to-end sales-to-settlement simulation is executed. 4. Regression testing confirms period-end financial accuracy.
What not to do, common wrong fixes.
Manual workarounds distort financial reporting. 1. Posting manual accrual entries outside CCM. 2. Reactivating legacy rebate conditions in pricing. 3. Ignoring reconciliation differences at month-end. 4. Assuming missing accruals will auto-correct during settlement. Accrual errors compound silently if not corrected structurally.
Follow-up 1. Why do pricing conditions appear correct while accruals are missing?
Answer: because pricing calculation and accrual posting are governed by separate determination logic in S/4HANA. Conditions may calculate values without triggering financial postings.
Follow-up 2. How can teams detect accrual gaps early?
Answer: by executing settlement simulations and reconciling FI postings immediately after test transactions, rather than waiting for period-end reporting.
Follow-up 3. Curveball. Why are accrual issues often discovered by auditors first?
Answer: because operational teams focus on pricing execution, while auditors validate financial completeness. Missing accruals may not disrupt daily sales but distort financial statements.
Exclusive pro tip.
Always reconcile pricing output against FI accrual postings during CCM testing. Commercial success without financial accuracy is a hidden liability.
Scenario 74. Settlement documents differ from ECC.
After activating condition contract management, settlement documents are generated successfully, but they look and behave differently from ECC rebate documents. FI postings, document flow, and reporting references no longer align with legacy expectations. Business users question whether the system is calculating settlements correctly.
Scenario classification.
1. Complexity, high financial reporting and reconciliation risk. 2. Phase post-go-live stabilization. 3. Primary ownership SD cross-module. 4. Supporting FI.
Why this happens, scenario analysis and root cause.
Settlement document architecture changes fundamentally in S/4HANA. 1. CCM uses different document categories and flow structures. 2. FI posting logic is redesigned under settlement management. 3. Accrual reversal and final settlement handling differ from ECC. 4. Reporting references rely on new data models. Settlement documents are structurally different, not cosmetically altered.
Why this is a migration-exclusive failure.
ECC rebate documents followed a legacy settlement engine. 1. S/4HANA removes classic rebate document logic entirely. 2. CCM introduces new settlement document flow. 3. Historical expectations no longer match system design. 4. Transformation forces commercial reporting redesign. Document differences are architectural outcomes of engine replacement.
Ownership, who actually fixes it.
Stabilization requires commercial and financial reconciliation. 1. SD validates settlement document generation logic. 2. FI confirms posting keys, account assignments, and reconciliation. 3. Controlling reviews impact on profitability analysis. 4. Reporting team aligns new document structures and analytics.
Who gets blamed versus who owns it.
Settlement discrepancies create immediate financial tension. 1. Blamed finance for reporting mismatch. 2. Blamed IT for document differences. 3. Actual owner functional redesign under CCM. 4. Root cause structural replacement of settlement engine.
How this is actually fixed, the right way by a role.
Alignment requires controlled reconciliation and education. 1. SD validates contract configuration and settlement flow. 2. FI reconciles postings against accrual and revenue accounts. 3. Joint workshops explain new document structure to business users. 4. Updated reporting logic aligns analytics with CCM architecture.
What not to do, common wrong fixes.
Surface adjustments hide structural differences. 1. Attempting to replicate ECC document format artificially. 2. Manually adjusting settlement postings to match old reports. 3. Ignoring document flow redesign in analytics. 4. Treating user confusion as a minor training issue only. Settlement redesign requires structural understanding, not cosmetic alignment.
Follow-up 1. Why do settlement postings look unfamiliar to finance teams?
Answer: because condition contract management changes document types and posting logic. Even if financial results are correct, document structure may appear different from legacy expectations.
Follow-up 2. How can teams validate correctness despite document differences?
Answer: by reconciling total accruals, settlements, and revenue impact across periods rather than relying solely on document appearance.
Follow-up 3. Curveball. Why is document appearance such a sensitive issue?
Answer: because financial users trust familiar patterns. Even structurally correct postings can trigger doubt if presentation changes unexpectedly.
Exclusive pro tip.
Educate finance teams on CCM document flow early. Familiarity reduces resistance and accelerates stabilization.
Scenario 75. Performance issues in CCM processing.
After go-live, condition contract management settlement runs take significantly longer than expected. Large contracts freeze background jobs, settlement simulations time out, and finance closing windows become compressed. What was assumed to be a functional redesign becomes a runtime bottleneck.
Scenario classification.
1. Complexity, high financial close performance risk. 2. Phase, post-go-live stabilization. 3. Primary ownership, SD technical-led. 4. Supporting basis.
Why this happens, scenario analysis and root cause.
CCM processes large transactional datasets under new logic. 1. Condition contracts reference extensive historical sales volumes. 2. Settlement runs execute complex accrual recalculations. 3. Indexing and HANA optimization were not fully reviewed. 4. Legacy custom enhancements were not performance tested. Settlement volume and architecture shift amplify runtime sensitivity.
Why this is a migration-exclusive failure.
ECC rebate processing used different calculation models. 1. S/4HANA consolidates data in HANA-driven structures. 2. CCM processes operate on larger unified datasets. 3. Migration increases historical data footprint in one structure. 4. Transformation exposes scalability assumptions never tested in ECC. Runtime exposure is a byproduct of architectural consolidation.
Ownership, who actually fixes it.
Resolution requires both functional and technical tuning. 1. SD technical-led reviews contract scope and settlement configuration. 2. Basis analyzes HANA performance, memory allocation, and job scheduling. 3. ABAP optimizes custom enhancements affecting settlement logic. 4. FI aligns closing calendar with optimized processing windows.
Who gets blamed versus who owns it.
When closing windows compress, escalation happens fast. 1. Blamed basis for system slowness. 2. Blamed HANA for underperformance. 3. Actual owner combined CCM design and performance planning. 4. Root cause underestimated runtime impact of new settlement engine.
How this is actually fixed, the right way by a role.
Performance stabilization requires structured analysis. 1. Settlement jobs are analyzed using performance traces. 2. Indexes and data partitioning strategies are optimized. 3. Custom enhancements are refactored or removed. 4. Settlement cycles are redesigned to distribute workload.
What not to do, common wrong fixes.
Short-term hardware scaling does not solve structural issues. 1. Increasing memory allocation without root cause analysis. 2. Splitting contracts artificially without process redesign. 3. Running settlement during peak business hours. 4. ignoring trace analysis and assuming HANA will auto-optimize. Performance issues must be architecturally resolved, not masked.
Follow-up 1. Why does CCM performance differ from ECC rebate runs?
Answer: because CCM operates on unified HANA-based data structures and recalculates accruals differently. Volume concentration increases runtime sensitivity.
Follow-up 2. How can teams proactively prevent CCM bottlenecks?
Answer: by executing volume-based performance testing before go-live and reviewing HANA indexing and job scheduling strategies during blueprint.
Follow-up 3. Curveball. Why do teams assume HANA eliminates performance risk?
Answer: because in-memory processing creates the illusion of infinite scalability. In reality, inefficient design can still overwhelm optimized hardware.
Exclusive pro tip.
Never assume HANA performance replaces design discipline. Settlement architecture must scale by design.
Category 13 wrap-up. Revenue logic is not plug-and-play.
Settlement management in S/4HANA replaces the rebate engine entirely. It changes accrual logic, document flow, and financial impact. Projects that treat it as configuration only often discover revenue distortion during closing cycles.
Transition, when numbers stop matching.
If settlement redesign challenges revenue recognition, reporting redesign challenges trust. In S/4HANA, classic reports behave differently. CDS views replace table logic, and analytics operate on new semantic layers. Totals may be correct, but not where or how you expect.
Category 14. Reporting and analytics break.
S/4HANA introduces a new reporting architecture based on CDS views, embedded analytics, and harmonized data models. Classic ECC reports may still exist, but their underlying logic changes. Migration exposes reconciliation gaps between operational reports and financial statements.
Scenarios covered in Category 14.
Scenario 76, MB5B and MB52 totals don't match. Primary owner MM cross-module. Supporting FI. Scenario 77, stock aging reports incorrect. Primary owner MM cross-module. Supporting FI. Scenario 78, CDS reports show different numbers. Primary owner ABAP technical lead. Supporting MM. Scenario 79, embedded analytics versus ECC ALV differences. Primary owner MM cross-module. Supporting analytics. Scenario 80, advanced analytics such as SSC or BW totals drift. Primary owner analytics cross-module. Supporting MM.
Scenario 76. MB5B and MB52 totals don't match.
After migration to S/4HANA, inventory reports such as MB5B and MB52 show totals that do not align with FI balances or with each other. Users compare stock quantities and values across reports and detect unexplained variances. Confidence in inventory reporting begins to erode.
Scenario classification.
1. Complexity, high inventory and financial reconciliation risk. 2. Phase post-go-live stabilization. 3. Primary ownership MM cross-module. 4. Supporting FI.
Why this happens, scenario analysis and root cause.
S/4HANA changes how inventory and accounting data are stored and reported. 1. Inventory data is consolidated through MATDOC rather than MSEG. 2. Financial postings are unified in ACDOCA. 3. Classic report logic may rely on compatibility views. 4. Custom enhancements alter selection logic differently post-migration. Report appearance may remain familiar while data semantics shift.
Why this is a migration-exclusive failure.
ECC reporting relied on physically separated tables. 1. S/4HANA consolidates operational and financial data models. 2. Compatibility views preserve old access paths temporarily. 3. Migration introduces semantic differences between reports. 4. Transformation exposes assumptions in custom inventory logic. Reporting drift appears when architecture changes underneath familiar transactions.
Ownership, who actually fixes it.
Reconciliation requires cross-functional validation. 1. MM validates stock quantity and valuation logic. 2. FI confirms balance sheet and inventory account integrity. 3. ABAP reviews custom report logic referencing legacy tables. 4. Analytics team aligns CDS views and embedded reporting logic.
Who gets blamed versus who owns it?
Inventory mismatches immediately trigger escalation. 1. Blamed finance for incorrect balances. 2. Blamed IT for broken reports. 3. Actual owner cross-module reconciliation and reporting redesign. 4. Root cause semantic shift in inventory and accounting data models.
How this is actually fixed, the right way by a role.
Stabilization requires structured reconciliation analysis. 1. Execute stock to FI reconciliation using S/4HANA data models. 2. Replace legacy table reads with MATDOC and ACDOC-based logic. 3. Align CDS reporting structures with financial statements. 4. Conduct regression validation across reporting periods.
What not to do, common wrong fixes.
Superficial fixes create deeper reconciliation risk. 1. Manually adjusting inventory balances to force alignment. 2. Filtering report output to match expected totals. 3. Ignoring compatibility view warnings. 4. Assuming historical data inconsistencies will self-correct. Inventory reconciliation must be structurally validated, not cosmetically aligned.
Follow-up 1. Why do MB5B and MB52 show different totals after migration?
Answer: because their underlying data access logic may reference compatibility views or different semantic layers. The data model consolidation in S/4HANA changes how quantities and values are calculated.
Follow-up 2. How can teams validate which report is correct?
Answer: by reconciling both reports against ACDOC and MATDOC-based extractions, and validating against FI balances rather than trusting report appearance.
Follow-up 3. Curveball. Why is reporting trust more critical than transactional stability?
Answer: because management decisions rely on reports. Even if transactions post correctly, inaccurate reporting undermines strategic and financial confidence.
Exclusive pro tip.
Always validate inventory reports against financial postings immediately after migration. Trust is rebuilt through reconciliation transparency.
Scenario 77. Stock aging reports incorrect.
After migration, stock aging reports display unexpected results. Materials appear older or newer than expected, and slow-moving inventory classifications no longer match ECC reports. Finance and operations question whether inventory aging logic is functioning correctly.
Scenario classification.
1. Complexity, high inventory valuation and provisioning risk. 2. Phase post-go-live stabilization. 3. Primary ownership MM cross-module. 4. Supporting FI.
Why this happens, scenario analysis and root cause.
S/4HANA redefines how stock history and movement dates are derived. 1. Stock aging now relies on MATDOC-based logic instead of MSEG history. 2. Valuation layers may differ due to material ledger activation. 3. Custom aging reports reference deprecated tables. 4. Posting date versus document date logic changed during migration. Aging logic shifts when the underlying data model changes.
Why this is a migration-exclusive failure.
ECC aging calculations relied on physical document tables. 1. S/4HANA consolidates inventory history into MATDOC. 2. Material ledger influences valuation timing. 3. Compatibility views alter how historical records are accessed. 4. Transformation changes semantics without changing transaction codes. Aging inconsistencies emerge from structural data redesign.
Ownership, who actually fixes it.
Resolution requires coordinated validation of quantity and valuation logic. 1. MM reviews stock history and movement date derivation. 2. FI validates provisioning and valuation impact. 3. ABAP refactors custom aging reports to align with MATDOC. 4. Controlling reviews slow-moving inventory impact on financial planning.
Who gets blamed versus who owns it.
Aging discrepancies quickly escalate to financial discussions. 1. Blamed operations for incorrect stock movement timing. 2. Blamed IT for reporting errors. 3. Actual owner cross-module validation of aging logic. 4. Root cause data model consolidation and valuation redesign.
How this is actually fixed, the right way by a role.
Stabilization requires semantic alignment, not cosmetic adjustment. 1. Reconcile aging buckets using MATDOC-based extraction. 2. Align valuation logic with material ledger activation. 3. Refactor custom reports to use released CDS views. 4. Validate provisioning calculations against FI standards.
What not to do, common wrong fixes.
Surface-level fixes distort inventory strategy. 1. Adjusting aging thresholds without root cause analysis. 2. Manipulating posting dates to align reports artificially. 3. Reverting to compatibility table reads. 4. Ignoring valuation impact during reconciliation. Aging accuracy influences financial provisioning and audit exposure.
Follow-up 1. Why does aging logic behave differently under material ledger?
Answer: because material ledger introduces multi-layer valuation timing. Aging calculations may reflect actual costing periods rather than simple movement dates.
Follow-up 2. How can teams validate correct aging logic post-migration?
Answer: by reconciling sample materials across movement history, valuation layers, and FI postings to ensure consistent semantic alignment.
Follow-up 3. Curveball. Why is aging often a CFO-level concern?
Answer: because inventory aging directly influences financial provisioning and balance sheet exposure. Misclassification can materially impact financial statements.
Exclusive pro tip.
Never validate aging logic using report appearance alone. Always reconcile against underlying valuation layers and accounting impact.
Scenario 78. CDS reports show different numbers.
After migration, new CDS-based reports display totals that differ from classic ECC reports. Operational users compare outputs and detect mismatches in quantities or values. Technically, both reports run successfully, but their semantic layers are no longer identical.
Scenario classification.
1. Complexity, high reporting semantics risk. 2. Phase, post-go-live stabilization. 3. Primary ownership, ABAP technical lead. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
CDS views introduce semantic aggregation and filtering logic. 1. CDS views apply predefined joins and filters. 2. Compatibility views alter legacy table access behavior. 3. Custom logic embedded in classic reports is not replicated. 4. Authorization checks may influence CDS aggregation results. CDS reports reflect semantic design, not raw table extraction.
Why this is a migration-exclusive failure.
ECC relied heavily on direct table reads and ALV-based reports. 1. S/4HANA shifts reporting to CDS and embedded analytics. 2. Data aggregation logic is centralized within views. 3. Migration retains legacy reports but changes underlying semantics. 4. Transformation creates parallel reporting layers. Different semantic engines produce different totals.
Ownership, who actually fixes it.
Resolution requires semantic alignment and technical validation. 1. ABAP reviews CDS view definitions and joins. 2. MM validates business meaning of aggregated values. 3. FI confirms financial reconciliation impact. 4. Analytics team aligns reporting layer strategy.
Who gets blamed versus who owns it.
Reporting mismatches trigger cross-team scrutiny. 1. Blamed IT for incorrect report logic. 2. Blamed business for misunderstanding data. 3. Actual owner semantic reporting redesign under S4. 4. Root cause architectural shift to CDS-based aggregation.
How this is actually fixed, the right way by a role.
Alignment requires transparent semantic reconciliation. 1. Compare CDS output against MATDOC and ACDOC base extractions. 2. Adjust CDS joins or filters where misaligned. 3. Document semantic differences clearly for users. 4. Retire legacy reports where redundant.
What not to do, common wrong fixes.
Superficial harmonization hides architectural differences. 1. Hard-coding manual adjustments into CDS logic. 2. Duplicating legacy report logic inside new views. 3. Ignoring authorization effects on aggregation. 4. Maintaining parallel reports indefinitely. Semantic transparency is more important than cosmetic alignment.
Follow-up 1. Why can two technically correct reports show different totals?
Answer: because they may apply different aggregation rules, joins, or filters. CDS views embed semantic assumptions that differ from legacy table-based logic.
Follow-up 2. How can teams choose which report to trust?
Answer: by reconciling both outputs against underlying financial and inventory tables and validating alignment with accounting standards.
Follow-up 3. Curveball. Why are CDS discrepancies often political issues?
Answer: because reporting influences performance metrics and decision-making. When numbers shift, stakeholders question ownership and accountability.
Exclusive pro tip.
When implementing CDS reporting, document semantic assumptions explicitly. Transparency prevents trust erosion.
Scenario 79. Embedded analytics versus ECC/ALV differences.
After migration, embedded analytics in S/4HANA show results that differ from classic ECC/ALV-based reports. Users compare the same business objects across Fiori tiles and GUI transactions and detect mismatches in quantities, values, or filtering behavior. Confidence in analytics begins to decline.
Scenario classification.
1. Complexity, high decision-making and KPI integrity risk. 2. Phase post-go-live stabilization. 3. Primary ownership cross-module. 4. Supporting analytics.
Why this happens, scenario analysis and root cause.
Embedded analytics operate on CDS-based semantic layers. 1. ALV reports read directly from compatibility tables. 2. Embedded analytics apply CDS view aggregation logic. 3. Authorization filtering may behave differently in Fiori. 4. KPI definitions are standardized under new analytical models. Reporting interface changes reflect deeper semantic shifts.
Why this is a migration-exclusive failure.
ECC relied on report-specific extraction logic. 1. S/4HANA centralizes reporting through embedded analytics. 2. Data harmonization alters aggregation paths. 3. Migration retains legacy reports alongside new analytical tools. 4. Transformation introduces dual reporting paradigms. Parallel paradigms generate visible divergence.
Ownership, who actually fixes it.
Stabilization requires analytical alignment rather than interface tuning. 1. MM validates business meaning behind KPIs. 2. Analytics team reviews CDS-based KPI definitions. 3. ABAP adjusts legacy report logic if required. 4. FI confirms financial reconciliation consistency.
Who gets blamed versus who owns it.
Analytics discrepancies often trigger executive concern. 1. Blamed IT for reporting consistencies. 2. Blamed business for incorrect KPI understanding. 3. Actual owner analytical model redesigned during migration. 4. Root cause structural shift from report-based to semantic layer analytics.
How this is actually fixed, the right way by a role.
Resolution requires harmonized KPI definition and validation. 1. Reconcile embedded analytics against financial base tables. 2. Align KPI definitions between Fiori and legacy reports. 3. Retire redundant ALV reports where possible. 4. Educate users on semantic aggregation logic differences.
What not to do, common wrong fixes.
Superficial harmonization increases long-term complexity. 1. Duplicating ALV logic inside embedded analytics. 2. Maintaining parallel reporting frameworks indefinitely. 3. Overriding KPI logic to match historical expectations. 4. Ignoring authorization-driven aggregation differences. Analytics integrity depends on unified semantic governance.
Follow-up 1. Why do Fiori analytics sometimes show fewer records than GUI reports?
Answer: because embedded analytics apply CDS-based filtering and authorization logic differently. Aggregation rules may exclude records that ALV reports include.
Follow-up 2. How can teams align embedded analytics with financial reporting?
Answer: by reconciling KPI outputs against ACDOC and MATDOC, and documenting the semantic assumptions behind each analytical view.
Follow-up 3. Curveball. Why is embedded analytics resistance common after migration?
Answer: because users trust familiar ALV outputs. When presentation and aggregation logic change simultaneously, it creates psychological resistance even if data is technically correct.
Exclusive pro tip.
Align KPI definitions across modules before retiring legacy reports. Semantic consistency reduces post-migration resistance.
Scenario 80. Advanced analytics such as SAC or BW totals drift.
After migration to S/4HANA, advanced analytics platforms such as SAC or BW begin showing totals that do not align with S/4 operational reports. Extractors run successfully, data loads complete without errors, yet management dashboards reflect inconsistent inventory or valuation figures.
Scenario classification.
1. Complexity, critical executive reporting and strategic risk. 2. Phase, post-go-live stabilization. 3. Primary ownership, analytics cross-module. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
Extraction logic changes when S/4HANA data models shift. 1. Legacy BW extractors reference deprecated ECC tables. 2. S/4HANA consolidates inventory and accounting data into MATDOC and ACDOCA. 3. CDS-based extraction replaces classic extractors. 4. Delta logic may not align with new semantic layers. Extraction success does not guarantee semantic alignment.
Why this is a migration-exclusive failure.
ECC analytics relied on stable physical table structures. 1. S/4HANA restructures core data persistence layers. 2. Migration shifts from table-based extraction to CDS-driven extraction. 3. Delta logic and aggregation rules change structurally. 4. Transformation introduces semantic gaps between source and target. Analytics drift reflects data model evolution, not random error.
Ownership, who actually fixes it.
Resolution requires end-to-end extraction redesign. 1. Analytics team reviews extractors and delta logic alignment. 2. MM validates operational inventory semantics. 3. FI confirms financial reconciliation consistency. 4. ABAP adjusts CDS-based extraction where necessary.
Who gets blamed versus who owns it.
Executive dashboard discrepancies trigger rapid escalation. 1. Blamed IT for broken data pipelines. 2. Blamed finance for inconsistent validation. 3. Actual owner, analytics extraction redesign and semantic reconciliation. 4. Root cause, structural data model shift under S/4HANA.
How this is actually fixed, the right way by a role.
Stabilization requires semantic and delta validation. 1. Replace legacy extractors with S/4 released CDS-based extractors. 2. Validate delta mechanisms against MATDOC and ACDOCA. 3. Execute reconciliation between S/4 operational totals and analytics dashboards. 4. Retire deprecated BW logic dependent on ECC structures.
What not to do, common wrong fixes.
Quick adjustments distort analytical integrity. 1. Manually adjusting dashboard figures to match expectations. 2. Maintaining legacy extractors referencing compatibility views. 3. Ignoring delta inconsistencies after initial full load. 4. Blaming reporting tools without validating source semantics. Analytics accuracy depends on semantic transparency from source to dashboard.
Follow-up 1. Why do SAC or BW dashboards drift even when loads succeed?
Answer: because load success validates technical transfer, not semantic correctness. Extraction logic may aggregate or filter data differently under the new S/4 data model.
Follow-up 2. How can teams prevent analytics drift during migration?
Answer: by executing reconciliation between S/4 operational reports and analytics outputs during testing, especially validating delta logic and aggregation assumptions.
Follow-up 3. Curveball. Why are analytics discrepancies politically sensitive?
Answer: because executive dashboards influence strategic decisions. Even minor inconsistencies can undermine trust at leadership levels.
Exclusive pro tip.
Treat analytics redesign as a core migration workstream. Reporting credibility determines post-migration confidence.
Category 14 wrap-up. When reporting stops being trusted.
Reporting discrepancies after migration are rarely about missing data. They are about changed semantics. When totals drift between operational reports and analytics dashboards, trust erodes faster than performance. Stabilizing reporting means stabilizing meaning.
Transition from numbers to control.
Even when numbers reconcile, access and control may not. S/4HANA redesigns authorization objects, role logic, and segregation boundaries. What worked in ECC security models often becomes unstable after conversion.
Please check description or comments section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP functional modules interviews jobs like SAP MM Consultant jobs, SAP FICO Consultant jobs, SAP SD Consultant jobs, SAP PP Consultant jobs, SAP Ariba Consultant jobs, SAP Extended Warehouse Management EWM Consultant jobs, SAP Plant Maintenance PM Consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Category 15, Authorization and Control Redesign.
S/4HANA introduces structural changes in authorization objects, Fiori roles, and segregation of duties logic. Migration exposes control gaps, unexpected posting blocks, and compliance risks that were invisible in ECC.
Scenarios covered in Category 15.
Scenario 81, MIGO authorization conflicts. Primary owner security cross-module. Supporting MM. Scenario 82, segregation of duties changes. Primary owner security cross-module. Supporting FI. Scenario 83, inventory posting blocked unexpectedly. Primary owner MM cross-module. Supporting security. Scenario 84, warehouse authorization conflicts. Primary owner, security cross-module. Supporting UM. Scenario 85, audit flags inventory differences. Primary owner FI cross-module. Supporting MM.
Scenario 81, MIGO authorization conflicts.
After migration, users who previously executed goods movements without issue begin encountering authorization errors in MIGO. The transaction loads, but specific movement types, plants, or posting functions are blocked. Business operations slow down while security and MM teams debate responsibility.
Scenario classification.
1. Complexity, high operational disruption risk. 2. Phase, cutover and post-go-live. 3. Primary ownership, security cross-module. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
Authorization objects are restructured during migration. 1. S/4HANA introduces updated authorization objects for inventory transactions. 2. Movement type level restrictions may be evaluated differently. 3. Fiori and GUI roles may not align structurally. 4. Role transports may not reflect updated object hierarchies. The transaction exists, but access logic has changed.
Why this is a migration-exclusive failure.
ECC roles were built around legacy authorization models. 1. S/4HANA refactors inventory and posting control objects. 2. Conversion does not automatically harmonize roles. 3. New Fiori catalog structures introduce layered access control. 4. Transformation exposes previously tolerated over-authorizations. Security redesign is not optional during migration.
Ownership, who actually fixes it.
Resolution requires structured role redesign. 1. Security team reviews and redesigns authorization objects. 2. MM validates operational movement requirements. 3. Basis ensures role transports are synchronized across systems. 4. Audit confirms compliance alignment.
Who gets blamed versus who owns it?
Posting blocks escalate quickly to leadership. 1. Blamed IT for broken access. 2. Blamed MM for configuration issues. 3. Actual owner security redesign under S4 model. 4. Root cause authorization structure evolution.
How this is actually fixed, the right way by a role.
Stabilization requires structural role alignment. 1. Redesign roles based on S4 authorization objects. 2. Test movement types across plants and storage locations. 3. Align Fiori and GUI role catalogs. 4. Validate segregation and audit impact before production.
What not to do, common wrong fixes.
Short-term access workarounds create audit risk. 1. Granting SAP all temporarily without remediation plan. 2. Copying ECC roles blindly into S4. 3. Ignoring Fiori-specific authorization layers. 4. Fixing one plant without validating enterprise scope. Access shortcuts today become compliance findings tomorrow.
Follow-up 1. Why do users lose access after migration, even if roles were transported?
Answer: because the underlying authorization objects and evaluation logic change in S4HANA. Transporting roles does not guarantee structural alignment with the new model.
Follow-up 2. How can teams proactively avoid MIGO conflicts?
Answer: by conducting role redesign workshops during migration and executing movement type-specific testing before go-live.
Follow-up 3. Curveball. Why are authorization conflicts often political?
Answer: because posting restrictions halt operations immediately. Operational pressure forces rapid decisions, often at the expense of long-term compliance.
Exclusive pro tip.
Never treat authorization redesign as a post-go-live task. In S4HANA, security architecture is foundational, not cosmetic.
Scenario 82. Segregation of duties changes.
After migration, segregation of duties conflicts begin surfacing that never appeared in ECC. Users who previously held combined roles are now flagged in GRC or internal audit tools. What once seemed operationally efficient now appears as a compliance exposure under S4HANA's redesigned control model.
Scenario classification.
1. Complexity, critical compliance and audit risk. 2. Phase, cutover and post-go-live. 3. Primary ownership, security cross-module. 4. Supporting FI.
Why this happens, scenario analysis and root cause.
S4HANA reorganizes process flows and authorization objects. 1. New Fiori apps consolidate functions previously separated in ECC. 2. Authorization objects are restructured and evaluated differently. 3. Embedded analytics expose transactional combinations more clearly. 4. Legacy roles were never designed with S4 duty matrices in mind. The system did not create new risk. It exposed existing ones.
Why this is a migration-exclusive failure.
ECC environments evolved gradually with overlapping access. 1. S4HANA centralizes workflows across modules. 2. GRC rule sets are updated for new transaction logic. 3. Migration reveals role overlaps previously tolerated. 4. Transformation changes segregation evaluation boundaries. Control frameworks shift during structural system redesign.
Ownership, who actually fixes it.
Resolution requires governance, not quick access changes. 1. Security team redesigns role architecture and SOD matrices. 2. FI validates financial risk exposure. 3. MM confirms operational necessity of combined roles. 4. Audit approves risk mitigation controls.
Who gets blamed versus who owns it.
Compliance escalations create cross-functional tension. 1. Blamed security for restricting access. 2. Blamed business for role sprawl. 3. Actual owner governance model not redesigned during migration. 4. Root cause structural consolidation of processes in S4.
How this is actually fixed, the right way by a role.
Remediation must balance compliance and operations. 1. Redesign roles using updated SOD matrices. 2. Introduce mitigating controls where separation is impractical. 3. Align GRC rules with S4 transaction logic. 4. Execute compliance validation before final role deployment.
What not to do, common wrong fixes.
Shortcuts increase audit exposure. 1. Suppressing GRC findings without analysis. 2. Granting broad composite roles for convenience. 3. Reusing ECC duty matrices without redesign. 4. Ignoring Fiori app consolidation impact. Compliance shortcuts become audit findings.
Follow-up 1. Why do SOD conflicts increase after migration?
Answer: because S/4HANA consolidates transaction logic and exposes previously hidden overlaps. Role combinations that were operationally silent in ECC become visible under updated rule sets.
Follow-up 2. Can we keep old ECC role structures?
Answer: technically yes, but compliance risks remain unresolved. S/4HANA requires structural role redesign to align with new process and authorization architecture.
Follow-up 3. Curveball. Why do business leaders resist SOD redesign?
Answer: because segregation often reduces operational flexibility. However, ignoring redesign exposes the organization to regulatory and audit risk.
Exclusive pro tip.
Treat segregation redesign as part of process transformation, not just access control. In S/4HANA, governance architecture is inseparable from system architecture.
Scenario 83. Inventory posting blocked unexpectedly.
After migration, users attempting goods movements or invoice postings encounter unexpected blocking errors. The configuration appears correct, movement types exist, and authorization roles are assigned. Yet the system prevents postings that worked flawlessly in ECC.
Scenario classification.
1. Complexity, high operational continuity risk. 2. Phase, cutover and early hypercare. 3. Primary ownership, MM cross-module. 4. Supporting security.
Why this happens, scenario analysis and root cause.
Posting validation layers expand in S/4HANA. 1. New authorization objects evaluate plant and movement level access differently. 2. Field status groups enforce stricter validation rules. 3. Account determination logic checks additional dimensions. 4. Embedded business validations trigger before document creation. The posting logic did not disappear, it became stricter.
Why this is a migration-exclusive failure.
ECC allowed certain validation gaps that S4 closes. 1. S/4HANA integrates valuation and accounting checks more tightly. 2. Extended data fields trigger additional validation dependencies. 3. Migration exposes configuration inconsistencies previously tolerated. 4. Transformation increases control precision across modules. Stricter validation exposes latent configuration weakness.
Ownership, who actually fixes it.
Diagnosis requires joint configuration and access review. 1. MM reviews movement type configuration and account determination. 2. Security validates authorization objects and field-level access. 3. FI confirms account assignments and valuation settings. 4. Basis checks transport consistency across environments.
Who gets blamed versus who owns it.
Unexpected posting blocks escalate quickly. 1. Blamed MM for incorrect configuration. 2. Blamed security for access restriction. 3. Actual owner combined validation and authorization redesign. 4. Root cause expanded validation layers in S/4HANA.
How this is actually fixed, the right way by a role.
Resolution requires structured cross-module validation. 1. Reconcile account determination with valuation logic. 2. Review movement type level authorization objects. 3. Execute end-to-end posting simulations. 4. Validate field status and mandatory field alignment.
What not to do, common wrong fixes.
Short-term bypasses increase financial exposure. 1. Granting broad posting authorizations temporarily. 2. Disabling validation checks without impact analysis. 3. Changing account determination without reconciliation. 4. Assuming the issue is purely technical. Quick fixes create audit and valuation risk.
Follow-up 1. Why do posting blocks appear even when configuration looks correct?
Answer: because S/4HANA evaluates validation rules across multiple dimensions simultaneously. A single missing assignment or authorization restriction can halt posting even if movement configuration appears unchanged.
Follow-up 2. How can teams proactively detect these issues before go live?
Answer: by executing comprehensive end-to-end posting simulations across plants and movement types, including negative scenarios. Testing must include account determination, authorization, and valuation dimensions together.
Follow-up 3, curveball. Why are these blocks more frequent in S4 than ECC?
Answer: because S/4HANA tightens integration between inventory and finance. The system enforces financial correctness earlier in the process, rather than allowing inconsistencies to surface later.
Exclusive pro tip.
When postings are blocked in S/4HANA, assume validation depth increased. Diagnose across configuration, authorization, and valuation simultaneously.
Scenario 84, warehouse authorization conflicts.
After migration, warehouse users experience unexpected access restrictions in inventory and warehouse-related transactions. Activities such as transfer postings, bin confirmations, or stock adjustments are blocked even though operational roles appear unchanged from ECC.
Scenario classification.
1. Complexity, high operational and warehouse continuity risk. 2. Phase, cutover and post-go-live stabilization. 3. Primary ownership, security, cross-module. 4. Supporting EWM.
Why this happens, scenario analysis and root cause.
Embedded EWM and S4 integration alter authorization evaluation. 1. Warehouse authorization objects differ from classic WM objects. 2. Plant and storage location checks integrate more tightly with EWM roles. 3. Fiori apps introduce additional catalog-based restrictions. 4. Role mappings from ECC do not align structurally with EWM logic. Access logic evolves alongside warehouse architecture.
Why this is a migration-exclusive failure.
ECC WM roles were transaction-based and loosely integrated. 1. S4 Embedded EWM centralizes warehouse and inventory logic. 2. Authorization objects are redesigned under new data structures. 3. Migration introduces integrated plant warehouse validation layers. 4. Transformation requires role realignment to new architecture. Warehouse security must evolve with warehouse design.
Ownership, who actually fixes it.
Resolution requires coordinated security and warehouse review. 1. Security redesigns warehouse authorization objects. 2. EWM validates operational access requirements. 3. Confirms integration consistency with inventory postings. 4. Basis aligns role transports across environments.
Who gets blamed versus who owns it.
Warehouse blocks trigger immediate escalation. 1. Blamed IT for restricting warehouse activity. 2. Blamed EWM for configuration complexity. 3. Actual owner security redesign aligned to embedded EWM. 4. Root cause authorization model shift in S4.
How this is actually fixed, the right way by a role.
Stabilization requires structured authorization realignment. 1. Map ECCWM roles to embedded EWM authorization objects. 2. Test bin level and plant level activities end-to-end. 3. Align Fiori catalogs with warehouse transaction scope. 4. Execute regression testing for all warehouse processes.
What not to do, common wrong fixes.
Shortcuts increase operational and audit risk. 1. Granting unrestricted warehouse authorizations temporarily. 2. Copying ECCWM roles directly into S4. 3. Ignoring Fiori catalog dependencies. 4. Fixing access for one warehouse without enterprise validation. Warehouse access must be structurally aligned, not patched.
Follow-up 1. Why do warehouse users lose access even when roles are assigned?
Answer: because embedded EWM evaluates authorization objects differently from classic WM. The same role name does not guarantee alignment with new object structures.
Follow-up 2. How can teams avoid warehouse authorization instability?
Answer: by conducting warehouse-specific role redesign workshops and validating every operational scenario during integration testing.
Follow-up 3. Curveball. Why are warehouse authorization errors particularly disruptive?
Answer: because warehouse operations are real-time and operationally critical. Even minor access restrictions can halt physical inventory flow and logistics execution.
Exclusive pro tip.
Embedded EWM requires embedded security redesign. Treat warehouse authorizations as a transformation project, not a transport task.
Scenario 85. Audit flags inventory differences.
After migration, Internal or external auditors flag unexplained inventory differences between MM and FI reports. Operational users may not notice daily discrepancies, but reconciliation at period end reveals valuation or quantity gaps that did not exist in ECC.
Scenario classification.
1. Complexity, critical financial and audit risk. 2. Phase, first closing cycle after go live. 3. Primary ownership, FI cross-module. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
Inventory valuation logic tightens in S/4HANA. 1. Material ledger becomes mandatory and integrates valuation layers. 2. ACDOC consolidates accounting entries differently than ECC. 3. Movement type postings trigger additional valuation checks. 4. Parallel currencies and ledgers increase reconciliation complexity. Valuation integration increases precision and exposure.
Why this is a migration-exclusive failure.
ECC tolerated certain reconciliation timing gaps. 1. S/4HANA centralizes valuation through material ledger. 2. Unified journal architecture changes accounting aggregation. 3. Migration recalculates historical balances under new logic. 4. Transformation exposes inconsistencies previously masked. Structural accounting integration reveals latent gaps.
Ownership, who actually fixes it.
Resolution requires coordinated valuation analysis. 1. FI leads financial reconciliation and ledger validation. 2. MM validates quantity movements and valuation class mapping. 3. CO reviews cost component structure alignment. 4. Analytics confirms reporting consistency across ledgers.
Who gets blamed versus who owns it.
Audit findings trigger cross-functional escalation. 1. Blamed MM for inventory mismanagement. 2. Blamed FI for reconciliation failure. 3. Actual owner cross-module valuation redesign under S4. 4. Root cause mandatory material ledger and unified journal integration.
How this is actually fixed. The right way by a role.
Stabilization requires structured reconciliation and valuation validation. 1. Execute period-end reconciliation between MM quantities and FI values. 2. Validate material ledger configuration and price difference logic. 3. Review valuation class and account determination consistency. 4. Document reconciliation methodology for audit transparency.
What not to do, common wrong fixes.
Superficial reconciliation hides systemic issues. 1. Posting manual adjustment journals without root cause analysis. 2. Blaming reporting tools without reviewing valuation logic. 3. Suppressing audit findings to avoid executive escalation. 4. Ignoring parallel currency and ledger alignment. Financial integrity depends on structural valuation clarity.
Follow-up 1. Why do valuation differences appear after go live rather than during testing?
Answer: because full valuation impact often surfaces only during first closing cycles with complete transaction volume. Test data rarely reflects real-world complexity.
Follow-up 2. How can teams proactively prevent audit flags?
Answer: by performing parallel valuation reconciliation in sandbox systems before go live and validating material ledger configuration early in the project.
Follow-up 3. Curveball. Why are inventory audit findings politically sensitive?
Answer: because inventory valuation directly impacts financial statements and executive credibility. Even minor discrepancies can escalate into regulatory scrutiny.
Exclusive pro tip.
Treat the first S4 closing cycle as a structural validation milestone. Reconciliation success determines financial trust in the new system.
Category 15 wrap-up. Control is architecture.
Authorization conflicts and audit flags prove that security and control are not side activities in S4HANA migration. They are architectural components. If governance is not redesigned alongside processes, instability is inevitable.
Transition, when modules collide.
Even when MM works, FI works, and PP works individually, integration across modules may fracture. S4HANA tightens cross-module integration, exposing assumptions that ECC quietly tolerated.
Category 16. Cross-module integration failures.
S4HANA strengthens integration between MM, FI, PP, SD, and external engines. This precision exposes mismatches in accounting flows, stock consumption logic, delivery integration, and tax handling that never surfaced in ECC.
Scenarios covered in Category 16.
Scenario 86, MMFI Accounting Document Differences. Primary Owner FI Cross-Module. Supporting MM. Scenario 87, MMPP Production Orders Consume Stock Incorrectly. Primary Owner PP Cross-Module. Supporting MM. Scenario 88, MMSD Deliveries Show Inconsistent Stock. Primary Owner SD Cross-Module. Supporting MM. Scenario 89, Third-Party Logistics Interfaces Misaligned. Primary Owner Integration Cross-Module. Supporting MM. Scenario 90, Tax Engine Integration Breaks. Primary Owner FI Cross-Module. Supporting Integration.
Scenario 86. MMFI Accounting Document Differences.
After migration, goods movements generate accounting documents that differ from ECC expectations. FI reports show unexpected line items, additional ledger postings, or valuation differences. Operationally, everything appears posted correctly, yet financial reconciliation reveals inconsistencies.
Scenario classification.
1. Complexity, critical financial integrity risk. 2. Phase, cutover and first closing cycle. 3. Primary ownership, FI cross-module. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
Material ledger and universal journal redesign change posting structure. 1. ACDOC consolidates accounting entries differently than ECC. 2. Parallel ledgers create additional valuation postings. 3. Movement types trigger more granular accounting lines. 4. Account determination logic integrates new dimensions. The system posts correctly but differently.
Why this is a migration-exclusive failure.
ECC separated inventory and finance layers more loosely. 1. S/4HANA integrates valuation and accounting tightly. 2. Universal journal architecture alters posting aggregation. 3. Migration recalculates valuation under new logic. 4. Transformation increases transparency of financial impact. Accounting precision increases visibility of variance.
Ownership, who actually fixes it.
Resolution requires cross-module valuation alignment. 1. FI leads reconciliation and ledger validation. 2. MM validates movement type configuration and valuation classes. 3. CO reviews cost component structure where applicable. 4. Analytics confirms reporting consistency.
Who gets blamed versus who owns it.
Financial differences trigger rapid escalation. 1. Blamed MM for incorrect movement configuration. 2. Blamed FI for reconciliation gaps. 3. Actual owner integrated posting redesign under S4. 4. Root cause, universal journal and material ledger integration.
How this is actually fixed, the right way by a role.
Stabilization requires structured reconciliation. 1. Reconcile accounting documents against goods movements. 2. Validate account determination and valuation logic. 3. Test parallel ledger impact across currencies. 4. Document posting logic differences for stakeholders.
What not to do, common wrong fixes.
Superficial fixes distort financial accuracy. 1. Posting manual adjustment entries without root cause. 2. Suppressing additional ledger postings. 3. Ignoring valuation layer differences. 4. Assuming the system is incorrect without analysis. Accounting redesign must be understood, not overridden.
Follow-up 1. Why do accounting documents show more line items in S4?
Answer: because the universal journal captures more granular valuation and ledger information. What was aggregated in ECC is now structurally separated.
Follow-up 2. How can teams prevent reconciliation surprises?
Answer: by simulating goods movements in sandbox systems and reconciling accounting documents before go live, especially under parallel ledger scenarios.
Follow-up 3. Curveball. Why are these differences often mistaken as system errors?
Answer: because users expect historical posting patterns. Structural redesign changes presentation and granularity, creating perceived inconsistency.
Exclusive pro tip.
Never compare S4 postings to ECC screenshots. Compare valuation logic and ledger impact instead.
Scenario 87. MMPP production orders consume stock incorrectly.
After migration, Production orders begin consuming stock in unexpected quantities or valuation layers. Components are issued, yet inventory balances appear inconsistent across MM and PP reports. What worked predictably in ECC now behaves differently under S4 integration logic.
Scenario classification.
1. Complexity, high production and inventory integrity risk. 2. Phase post-go-live stabilization. 3. Primary ownership PP cross-module. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
Stock consumption logic is evaluated under material ledger and unified valuation. 1. Backflushing logic interacts differently with valuation layers. 2. Batch or special stock handling is evaluated under new rules. 3. Parallel ledgers influence component valuation impact. 4. Reservation and availability logic integrate more tightly. Consumption accuracy depends on valuation alignment.
Why this is a migration-exclusive failure.
ECC production integration tolerated certain timing differences. 1. S/4HANA enforces tighter stock and accounting synchronization. 2. Material ledger recalculates valuation impacts differently. 3. Unified journal changes cost posting aggregation. 4. Migration exposes inconsistencies between PP and MM assumptions. Production integration precision increases exposure of gaps.
Ownership, who actually fixes it.
Resolution requires coordinated production and inventory review. 1. PP reviews order configuration and backflush settings. 2. MM validates movement types and stock category handling. 3. FI confirms valuation and cost postings. 4. CO reviews cost component and order settlement impact.
Who gets blamed versus who owns it.
Consumption discrepancies quickly escalate. 1. Blamed PP for incorrect order settings. 2. Blamed MM for stock mismanagement. 3. Actual owner cross-module integration redesign. 4. Root cause valuation and consumption logic changes in S4.
How this is actually fixed, the right way by a role.
Stabilization requires end-to-end production simulation. 1. Test backflush and manual issue scenarios across valuation layers. 2. Validate batch and special stock handling logic. 3. Reconcile component consumption with financial postings. 4. Review settlement and variance calculations post-production.
What not to do, common wrong fixes.
Quick configuration changes distort costing accuracy. 1. Changing backflush settings without valuation review. 2. Adjusting stock quantities manually to force reconciliation. 3. Ignoring ledger impact on cost variance. 4. Blaming MRP logic without analyzing posting flow. Production integrity depends on structural alignment.
Follow-up 1. Why does stock appear correct in MM but not in PP reports?
Answer: because PP consumption logic and MM inventory display evaluate stock differently under new valuation layers. Timing and ledger effects can create apparent inconsistencies.
Follow-up 2. How can teams validate production integration before go live?
Answer: by simulating full production cycles including component issue, confirmation, and settlement, and reconciling financial and quantity impacts.
Follow-up 3. Curveball. Why are production integration issues financially sensitive?
Answer: because production variance directly affects cost of goods sold and profitability reporting. Minor stock misalignments can distort financial statements.
Exclusive pro tip.
Always test production scenarios under full material ledger conditions. Stock consumption without valuation validation is incomplete testing.
Scenario 88. MMSD deliveries show inconsistent stock.
After migration, delivery processing in SD shows stock inconsistencies compared to MM inventory reports. Sales orders confirm availability, but delivery creation or goods issue reveals unexpected shortages or stock mismatches across plants and storage locations.
Scenario classification.
1. Complexity, high order fulfillment and revenue risk. 2. Phase post-go-live stabilization. 3. Primary ownership SD cross-module. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
Availability logic evolves under S/4HANA. 1. ATP logic may be replaced or enhanced by advanced ATP. 2. Stock categories are evaluated differently in S4. 3. Special stock handling integrates more tightly with valuation layers. 4. Batch or segmentation logic affects delivery confirmation. Stock visibility changes when availability logic changes.
Why this is a migration-exclusive failure.
ECC allowed looser synchronization between SD and MM. 1. S/4HANA centralizes stock and availability evaluation. 2. Advanced ATP introduces new confirmation logic. 3. Unified data model changes stock aggregation behavior. 4. Migration exposes mismatches in plant and storage settings. Availability precision increases visibility of configuration gaps.
Ownership, who actually fixes it.
Resolution requires integrated availability analysis. 1. SD reviews ATP configuration and delivery settings. 2. MM validates stock categories and plan assignments. 3. PP confirms planning integration if production is involved. 4. Integration validates external order interfaces if applicable.
Who gets blamed versus who owns it.
Delivery delays trigger immediate escalation. 1. Blamed SD for incorrect confirmations. 2. Blamed MM for inventory inconsistency. 3. Actual owner integrated availability redesign under S4. 4. Root cause ATP and stock evaluation logic evolution.
How this is actually fixed, the right way by a role.
Stabilization requires end-to-end order simulation. 1. Simulate order creation through goods issue across plants. 2. Validate ATP categories and stock segmentation rules. 3. Reconcile confirmed quantities against physical inventory. 4. Align delivery logic with planning and production settings.
What not to do, common wrong fixes.
Quick availability overrides create systemic instability. 1. Forcing manual confirmations without analysis. 2. Adjusting stock quantities to match delivery demands. 3. Disabling advanced ATP to mimic ECC behavior. 4. Ignoring stock segmentation or batch logic differences. Order fulfillment depends on structural availability alignment.
Follow-up 1. Why does ATP confirmation differ from actual delivery availability?
Answer: because ATP logic evaluates availability based on specific stock categories and timing assumptions. Delivery processing may reveal restrictions not visible during confirmation.
Follow-up 2. How can teams proactively stabilize SD-MM integration?
Answer: by testing complete order-to-cash cycles under real stock scenarios, including segmentation, batch, and plant-specific rules.
Follow-up 3. Curveball. Why are stock inconsistencies politically sensitive?
Answer: because they directly impact revenue recognition and customer trust. Delivery failure after confirmation damages operational credibility.
Exclusive pro tip.
Never validate ATP in isolation. Always validate it through full delivery and goods issue simulation.
Scenario 89. Third-party logistics interfaces misalign.
After migration, integration with third-party logistics providers begins producing inconsistent stock updates, delayed confirmations, or duplicate goods movements. Interfaces technically process successfully, but warehouse and financial reconciliation expose timing and quantity discrepancies.
Scenario classification.
1. Complexity, high external dependency and reconciliation risk. 2. Phase post-go-live stabilization. 3. Primary ownership integration cross-module. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
S/4HANA changes stock and accounting event timing. 1. Goods movement posting logic differs from ECC behavior. 2. Event timing under S4 may not align with legacy interface assumptions. 3. Extended fields or valuation layers affect payload structure. 4. Batch and segmentation logic introduce additional complexity. External systems rely on assumptions that may no longer hold.
Why this is a migration-exclusive failure.
ECC integration timing evolved organically over years. 1. S/4HANA redefines posting and event sequencing. 2. Migration alters data structures without redesigning interfaces automatically. 3. Compatibility views may hide deeper semantic shifts. 4. Transformation exposes interface logic built on outdated assumptions. Interface success does not equal process alignment.
Ownership, who actually fixes it.
Resolution requires synchronized integration redesign. 1. Integration reviews message structure and event timing. 2. Validates stock movement configuration. 3. FI confirms valuation and accounting postings. 4. External vendor adjusts processing logic where required.
Who gets blamed versus who owns it?
External reconciliation failures escalate quickly. 1. Blamed third-party provider for incorrect updates. 2. Blamed IT for broken interface. 3. Actual owner integration redesign aligned to S4 event model. 4. Root cause posting sequence and semantic changes in S4.
How this is actually fixed, the right way by a role.
Stabilization requires event and payload validation. 1. Redesign interface timing to match S4 posting logic. 2. Validate extended field handling in payload structures. 3. Execute reconciliation between warehouse and S4 balances. 4. Align error handling and retry logic across systems.
What not to do, common wrong fixes.
Temporary patches increase long-term instability. 1. Manually correcting stock quantities after interface errors. 2. Suppressing duplicate messages without root cause validation. 3. Ignoring valuation differences under new ledger structure. 4. Blaming external providers without reviewing internal posting logic. External integration stability depends on internal design clarity.
Follow-up 1. Why do third-party systems appear correct, while S4 shows differences?
Answer: because third-party systems process based on previous ECC assumptions. If posting timing or valuation logic changes in S4, external confirmations may not align with internal accounting results.
Follow-up 2. How can teams stabilize third-party integration before go live?
Answer: by conducting parallel testing with real stock scenarios and validating end-to-end reconciliation between systems before final cut-over.
Follow-up 3. Curveball. Why are external integration issues politically complex?
Answer: because responsibility is distributed across organizations. Misalignment creates contractual tension and cross-company accountability challenges.
Exclusive pro tip.
Redesign external interfaces based on S4 posting semantics, not ECC legacy assumptions.
Scenario 90. Tax engine integration breaks.
After migration, integration with external tax engines begins failing intermittently or producing incorrect tax calculations. Purchase orders, goods movements, or invoice postings generate unexpected tax values. The interface may run successfully, yet financial compliance is compromised.
Scenario classification.
1. Complexity, critical compliance and financial exposure risk. 2. Phase, cutover and first financial closing. 3. Primary ownership, FI cross-module. 4. Supporting integration.
Why this happens, scenario analysis and root cause.
Tax determination logic is evaluated differently in S/4HANA. 1. Business partner replaces vendor or customer tax master logic. 2. Extended tax-relevant fields change payload structure. 3. Universal journal impacts tax posting aggregation. 4. Interface sequencing differs from ECC assumptions. Tax accuracy depends on structural integration alignment.
Why this is a migration-exclusive failure.
ECC tax integration evolved under legacy master data structures. 1. S/4HANA centralizes master data under business partner. 2. Extended field lengths and structures alter payload definitions. 3. Material ledger and unified journal influence tax base amounts. 4. Transformation modifies posting sequence and event timing. Compliance risk increases when integration assumptions shift.
Ownership, who actually fixes it.
Resolution requires structured tax and integration review. 1. FI validates tax determination configuration and compliance impact. 2. Integration reviews payload structure and sequencing. 3. MM and SD confirm transactional tax-relevant data fields. 4. External vendor adjusts tax engine configuration if required.
Who gets blamed versus who owns it.
Tax discrepancies trigger high-level escalation. 1. Blamed tax engine vendor for incorrect calculation. 2. Blamed IT for broken interface. 3. Actual owner integration and master data redesign under S4. 4. Root cause structural shift in tax-relevant data and posting flow.
How this is actually fixed, the right way by a role.
Stabilization requires end-to-end tax validation. 1. Validate tax determination in purchase and sales flows. 2. Align business partner tax fields with external engine mapping. 3. Reconcile tax base and calculated amounts across ledgers. 4. Execute parallel compliance validation before final closing.
What not to do, common wrong fixes.
Short-term fixes increase regulatory exposure. 1. Manually adjusting tax amounts in accounting documents. 2. Hard-coding tax codes in interface payloads. 3. Ignoring business partner tax master alignment. 4. Suppressing compliance warnings during closing. Tax integration errors carry regulatory consequences.
Follow-up 1. Why does tax calculation differ even when rates are unchanged?
Answer: because the tax base amount and master data evaluation may change under S/4HANA. Extended fields and posting sequences alter the context in which the tax engine calculates values.
Follow-up 2. How can teams proactively stabilize tax integration?
Answer: by executing parallel tax validation scenarios in sandbox environments and reconciling calculated amounts against expected compliance results.
Exclusive pro tip.
Treat tax integration testing as a compliance rehearsal. If tax flows are not validated end-to-end before go-live, financial risk becomes systemic.
Category 16 wrap-up. Integration is where assumptions break.
Cross-module failures prove that S/4HANA migration is not about isolated configuration. It is about integrated design. When modules collide under new posting logic, old assumptions collapse and reconciliation becomes mandatory.
Transition, faster database, slower reality.
S/4HANA runs on HANA, a high-performance in-memory database. Yet many projects report slower reports, blocked jobs, and runtime instability after migration. The problem is rarely the database. It is the code.
Please check description or comment section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP functional modules interviews jobs like SAP MM Consultant jobs, SAP FICO Consultant jobs, SAP SD Consultant jobs, SAP PP Consultant jobs, SAP Ariba Consultant jobs, SAP Extended Warehouse Management EWM Consultant jobs, SAP Plant Maintenance PM Consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Category 17. HANA Performance and Runtime Impact.
S/4HANA changes how data is stored and accessed. Custom code, legacy select logic, and background processing patterns built for ECC often perform unpredictably under HANA. Performance failures expose architectural inefficiencies rather than hardware limitations.
Scenarios covered in Category 17.
Scenario 91, inventory reports slower despite HANA. Primary owner ABAP technical lead. Supporting MM. Scenario 92, parallel execution exposes legacy assumptions. Primary owner ABAP technical lead. Supporting basis. Scenario 93, long background jobs block users. Primary owner basis technical lead. Supporting ABAP. Scenario 94, stock determination becomes CPU heavy. Primary owner MM cross-module. Supporting ABAP. Scenario 95, custom enhancements cause runtime drift. Primary owner ABAP technical lead. Supporting MM.
Scenario 91. Inventory reports slower despite HANA.
After migration to S/4HANA, inventory reports such as stock overview or historical movement analysis perform slower than in ECC. Stakeholders question the promised performance benefits of HANA, yet system monitoring shows no database bottleneck.
Scenario classification.
1. Complexity, high performance perception, and operational risk. 2. Phase, post-go-live stabilization. 3. Primary ownership, ABAP technical lead. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
HANA optimizes set-based processing, not legacy coding patterns. 1. Legacy select star statements retrieve excessive data volumes. 2. Custom joins still reference compatibility views instead of CDS. 3. Nested loops built for ECC row-based logic degrade performance. 4. Code was not optimized for in-memory processing principles. HANA accelerates optimized logic, not inefficient design.
Why this is a migration-exclusive failure.
ECC database limitations masked inefficient code. 1. S/4HANA changes table structures and indexing behavior. 2. Compatibility views add abstraction layers to legacy queries. 3. Migration exposes performance assumptions embedded in code. 4. Transformation shifts responsibility from database tuning to code optimization. Performance gaps reveal technical debt.
Ownership, who actually fixes it.
Resolution requires structured code remediation. 1. ABAP refactors inefficient queries and removes select star logic. 2. MM validates functional impact of report redesign. 3. Basis monitors runtime metrics and memory consumption. 4. Architecture reviews use of CDS views and push-down logic.
Who gets blamed versus who owns it.
Performance complaints escalate quickly. 1. Blamed HANA for underperforming. 2. Blamed infrastructure for hardware limitations. 3. Actual owner legacy ABAP logic not optimized for HANA. 4. Root cause inefficient data access patterns.
How this is actually fixed, the right way by a role.
Optimization requires structural redesign. 1. Replace compatibility table reads with CDS-based queries. 2. Eliminate unnecessary data retrieval and nested loops. 3. Push calculations to database layer where appropriate. 4. Execute runtime analysis using SD05 and SAT tools.
What not to do, common wrong fixes.
Superficial tuning delays structural correction. 1. Adding hardware resources without code remediation. 2. Creating secondary indexes without analysis. 3. Reducing data volume artificially for testing. 4. Blaming HANA without reviewing ABAP patterns. Hardware cannot compensate for inefficient design.
Follow-up 1. Why does HANA sometimes appear slower than ECC?
Answer: because inefficient ECC-era coding patterns may perform worse under in-memory optimization. HANA expects set-based processing and push-down logic, not row-by-row loops.
Follow-up 2. How can teams proactively avoid performance regression?
Answer: by conducting custom code remediation and ATC checks before migration, and by redesigning data access logic around CDS views.
Follow-up 3. Curveball. Why are performance issues emotionally charged in projects?
Answer: because HANA is marketed as faster by default. When users experience delays, confidence in the entire migration program declines rapidly.
Exclusive pro tip.
Performance testing is not optional in S/4HANA. Treat custom code remediation as a prerequisite, not a post-go-live task.
Scenario 92. Parallel execution exposes legacy assumptions.
After migration, background jobs and transactional postings begin running in parallel under HANA. Previously stable custom programs now produce locking conflicts, inconsistent stock updates, or duplicate processing. The issue was invisible in ECC because execution was effectively sequential.
Scenario classification.
1. Complexity, critical data consistency risk. 2. Phase, post-go-live stabilization. 3. Primary ownership, ABAP technical lead. 4. Supporting basis.
Why this happens, scenario analysis and root cause.
HANA enables true parallelism that ECC rarely exposed. 1. Custom code assumes single-thread execution. 2. Lock handling logic is incomplete or missing. 3. Update task sequencing is no longer predictable. 4. Parallel processing surfaces hidden race conditions. Concurrency reveals architectural blind spots.
Why this is a migration-exclusive failure.
ECC database and hardware limits naturally serialized processing. 1. HANA processes requests in parallel by design. 2. Legacy programs were never stress-tested for concurrency. 3. Transformation shifts execution behavior without altering code. 4. Migration amplifies race conditions embedded in ECC logic. Parallelism magnifies weak synchronization design.
Ownership, who actually fixes it.
Stabilization requires concurrency-aware redesign. 1. ABAP implements proper locking mechanisms and sequence control. 2. Basis monitors job parallelization parameters. 3. Validates business impact of duplicate or inconsistent postings. 4. Architecture reviews update task and in-queue design.
Who gets blamed versus who owns it.
Concurrency failures trigger operational panic. 1. Blamed HANA for changing execution behavior. 2. Blamed Basis for increasing parallel jobs. 3. Actual owner custom programs lacking concurrency safeguards. 4. Root cause sequential assumptions in legacy logic.
How this is actually fixed, the right way by a role.
Fixing concurrency requires structural redesign. 1. Introduce in-queue logic where business objects overlap. 2. Redesign programs for idempotent execution. 3. Control parallel job configuration intentionally. 4. Stress test under high-load simulation before release.
What not to do, common wrong fixes.
Quick fixes hide systemic risk. 1. Disabling parallel processing entirely. 2. Reducing job volume instead of fixing logic. 3. Adding arbitrary wait statements. 4. Blaming infrastructure without code review. Concurrency problems demand architectural correction.
Follow-up 1. Why did this never appear in ECC?
Answer: ECC database constraints and hardware limitations effectively serialized many operations. Programs were never executed under true parallel load conditions.
Follow-up 2. How can teams detect race conditions early?
Answer: by performing load testing in sandbox systems and analyzing locking patterns using SM12 and performance traces.
Follow-up 3. Curveball. Why is disabling parallelism considered dangerous?
Answer: because it sacrifices scalability and masks underlying defects. As business volume grows, the same structural weakness will resurface under pressure.
Exclusive pro tip.
Parallelism is not the enemy. Weak synchronization design is. Build for concurrency instead of suppressing it.
Scenario 93. Long background jobs block users.
After migration, background inventory or valuation jobs begin running significantly longer than expected. Users experience locking conflicts, delayed postings, and blocked transactions during peak hours. The system appears stable, yet operational productivity drops sharply.
Scenario classification.
1. Complexity, high operational disruption risk. 2. Phase, post-go-live stabilization. 3. Primary ownership basis technical-led. 4. Supporting ABAP.
Why this happens, scenario analysis and root cause.
Job execution behavior changes under HANA. 1. Background jobs process larger MATDOC and universal journal volumes. 2. Custom programs were not optimized for HANA pushdown logic. 3. Parallel execution creates lock contention during peak hours. 4. Batch scheduling overlaps with active user transaction windows. Runtime inefficiency becomes visible under real production load.
Why this is a migration-exclusive failure.
ECC batch processing was tuned for smaller datasets. 1. S/4HANA consolidates data into high-volume structures. 2. Legacy batch windows no longer match runtime behavior. 3. Transformation shifts performance bottlenecks from DB to code. 4. HANA exposes inefficient background processing design. Volume and architecture shifts expose weak scheduling logic.
Ownership, who actually fixes it.
Runtime stabilization requires coordinated ownership. 1. Basis reviews job scheduling and system resource allocation. 2. ABAP analyzes runtime traces and optimizes heavy programs. 3. Validates business-critical batch timing dependencies. 4. Architecture defines scheduling standards for peak operations.
Who gets blamed versus who owns it.
Operational slowdowns trigger immediate escalation. 1. blamed infrastructure for insufficient resources. 2. Blamed HANA for unexpected runtime behavior. 3. Actual owner batch design and custom program inefficiency. 4. Root cause scheduling patterns not redesigned for S4 volume.
How this is actually fixed, the right way by a role.
Stabilization requires role-driven correction. 1. Basis team resequences background jobs to avoid peak transactional overlap. 2. ABAP team optimizes heavy reports using HANA-optimized logic and CDS views. 3. MM team reviews batch timing dependencies for inventory and valuation processes. 4. Architecture team defines controlled batch windows aligned with business cycles.
What not to do, common wrong fixes.
Superficial fixes delay real stabilization. 1. Increasing hardware without analyzing runtime bottlenecks. 2. Disabling background jobs entirely. 3. Reducing job frequency without impact analysis. 4. Ignoring lock statistics during stabilization. Performance issues require design correction, not cosmetic tuning.
Follow-up 1. Why do background jobs impact user transactions more in S/4HANA?
Answer: because consolidated tables such as MATDOC and ACDOC concentrate data access. When heavy jobs scan these tables, lock contention and resource competition become more visible during live operations.
Follow-up 2. How can teams proactively avoid this issue?
Answer: by conducting performance simulations with production-like data volumes and redesigning batch scheduling before go live. Early runtime analysis prevents user-facing disruption.
Follow-up 3. Curveball. Why is reducing job frequency sometimes dangerous?
Answer: because delayed processing may shift operational risk into financial closing cycles. Postponing jobs can create reconciliation backlogs and compound performance pressure later.
Exclusive pro tip.
Batch architecture must be redesigned for S/4HANA volume. If background jobs collide with live operations, the design, not the hardware, is wrong.
Scenario 94. Stock determination becomes CPU heavy.
After migration, stock determination logic during goods movements or reservations becomes noticeably slower. Users experience delays during MIGO or transfer postings. System monitoring shows high CPU consumption, even though database response time appears stable.
Scenario classification.
1. Complexity, high operational performance risk. 2. Phase post-go-live stabilization. 3. Primary ownership cross-module. 4. Supporting ABAP.
Why this happens, scenario analysis and root cause.
Stock determination logic expands under S/4HANA. 1. MATDOC and stock segmentation increase evaluation dimensions. 2. Advanced ATP and valuation layers add processing overhead. 3. Custom exits inject additional logic during stock checks. 4. Parallel evaluation increases CPU utilization under load. Complex determination logic amplifies processing intensity.
Why this is a migration-exclusive failure.
ECC stock logic operated on simpler table structures. 1. S/4HANA introduces unified journal and extended dimensions. 2. Stock segmentation and parallel valuation increase decision layers. 3. Legacy enhancements were not performance tested under new logic. 4. Transformation increases calculation complexity per transaction. Performance degradation reflects expanded business semantics.
Ownership, who actually fixes it.
Optimization requires cross-functional evaluation. 1. MM reviews stock determination configuration and strategy complexity. 2. ABAP analyzes custom exits and optimizes logic execution. 3. Basis monitors CPU utilization and system workload distribution. 4. Architecture validates necessity of advanced determination layers.
Who gets blamed versus who owns it.
Performance complaints often escalate inaccurately. 1. Blamed HANA for high CPU usage. 2. Blamed infrastructure for insufficient capacity. 3. Actual owner overcomplicated stock determination design. 4. Root cause expanded evaluation logic not performance tuned.
How this is actually fixed, the right way by a role.
Performance stabilization must be role-driven. 1. MM team simplifies stock determination strategy and removes unnecessary layers. 2. ABAP team optimizes custom exits and eliminates redundant logic loops. 3. Basis team analyzes CPU spikes and adjusts workload parameters where required. 4. Architecture team reviews segmentation and valuation design impact on runtime.
What not to do, common wrong fixes.
Superficial tuning increases long-term instability. 1. Disabling stock determination checks entirely. 2. Adding hardware without logic review. 3. Ignoring custom enhancement impact. 4. Reducing validation steps without business approval. Operational speed must not compromise inventory accuracy.
Follow-up 1. Why does stock determination consume more CPU in S/4HANA?
Answer: because the system evaluates additional valuation layers, segmentation dimensions, and advanced availability logic. Each transaction triggers more computational steps than in ECC.
Follow-up 2. How can teams test this proactively?
Answer: by executing high-volume goods movement simulations with production-like data and analyzing CPU and trace metrics before go-live.
Follow-up 3. Curveball. Why is simplifying configurations sometimes politically difficult?
Answer: because advanced determination strategies were often justified during earlier optimization efforts. Removing them may feel like regression, even if they no longer deliver proportional value.
Exclusive pro tip.
Every additional stock determination layer has a runtime cost. If performance suffers, evaluate complexity before scaling infrastructure.
Scenario 95. Custom enhancements cause runtime drift.
After migration, previously stable transactions begin showing inconsistent runtime behavior. Some executions complete instantly, while others take significantly longer under similar data conditions. Standard SAP code performs predictably, but custom enhancements introduce volatility.
Scenario classification.
1. Complexity, critical unpredictable runtime behavior. 2. Phase post-go-live stabilization. 3. Primary ownership ABAP technical lead. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
Custom logic behaves differently under S4 architecture. 1. Enhancements reference compatibility views instead of optimized CDS structures. 2. Legacy select patterns trigger full table scans in MATDOC or ACDOCA. 3. Implicit enhancements execute additional validations per transaction. 4. Code paths expand under extended field lengths and valuation layers. Runtime inconsistency reflects unoptimized custom logic.
Why this is a migration-exclusive failure.
ECC performance behavior masked inefficiencies. 1. S4HANA changes table architecture and indexing strategies. 2. Compatibility views add overhead to legacy code. 3. Unified journal increases record density per transaction. 4. Transformation amplifies inefficiencies embedded in enhancements. Migration exposes the true cost of customization.
Ownership, who actually fixes it.
Runtime stabilization demands disciplined remediation. 1. ABAP conducts code review and optimizes inefficient enhancement logic. 2. MM validates business necessity of each custom validation step. 3. Basis monitors runtime metrics and system load distribution. 4. Architecture defines strict enhancement governance standards.
Who gets blamed versus who owns it.
Unstable performance creates uncertainty. 1. Blamed S4HANA for instability. 2. Blamed infrastructure for insufficient tuning. 3. Actual owner custom enhancements not redesigned for HANA. 4. Root cause legacy code incompatible with new data architecture.
How this is actually fixed. The right way by a role.
Correction must be ownership-driven and systematic. 1. ABAP team performs structured custom code remediation using ATC and runtime analysis tools. 2. MM team reviews and removes non-essential business validations embedded in enhancements. 3. Basis team tracks performance metrics during optimization cycles. 4. Architecture team enforces clean core principles to prevent future drift.
What not to do, common wrong fixes.
Shortcuts increase long-term instability. 1. Disabling enhancements without impact analysis. 2. Increasing hardware to mask inefficient logic. 3. Ignoring ATC findings during remediation. 4. Assuming runtime drift will stabilize naturally. Unoptimized customization erodes S/4HANA benefits.
Follow-up 1. Why do custom enhancements behave unpredictably in S/4HANA?
Answer: because they were originally designed for ECC table structures and database behavior. When the underlying architecture changes, enhancement logic may execute inefficiently or trigger expanded data scans.
Follow-up 2. How can teams systematically prevent runtime drift?
Answer: by performing full custom code inventory and ATC-based remediation before migration, combined with strict clean core governance policies post-go-live.
Follow-up 3. Curveball. Why is clean core governance critical after migration?
Answer: because without disciplined enhancement control, the same technical debt will accumulate again. S/4HANA performance gains disappear when customization grows unchecked.
Exclusive pro tip.
Clean core is not a buzzword. It is a performance insurance policy. If custom code is not governed, S/4HANA eventually behaves like ECC again.
Category 17 wrap-up. HANA does not fix bad design.
HANA accelerates well-designed logic. It does not compensate for inefficient custom code, poor concurrency control, or overloaded enhancement layers. Performance instability in S/4HANA is rarely a hardware problem. It is an architectural audit.
Transition. When customization collides with clean core.
S/4HANA promotes extensibility through controlled enhancement frameworks. Yet many ECC systems evolved through implicit enhancements, user exits, and direct modifications. Migration exposes which extensions survive and which collapse.
Category 18. Extensibility and modification surprises.
S/4HANA enforces clean core principles and restricts modification patterns tolerated in ECC. User exits, implicit enhancements, and classic modification techniques may no longer trigger as expected. What once felt flexible becomes fragile under transformation.
Scenarios covered in Category 18.
Scenario 96: user exits no longer trigger. Primary owner ABAP technical lead. Supporting MM. Scenario 97: implicit enhancements break. Primary owner ABAP technical lead. Supporting MM. Scenario 98: BADI implementation order changes. Primary owner ABAP technical lead. Supporting MM. Scenario 99: SPDD or SBAU removes critical logic. Primary owner ABAP technical lead. Supporting basis. Scenario 100: Z transactions break in Fiori. Primary owner ABAP technical lead. Supporting Fiori.
Scenario 96. User exits no longer trigger.
After migration, certain custom validations or enhancements that previously executed during goods movements or purchase order processing no longer trigger. Business users notice missing checks, automatic fields not populating, or approval logic silently disappearing.
Scenario classification.
1. Complexity, high functional logic disruption. 2. Phase code remediation and post-go-live stabilization. 3. Primary ownership ABAP technical lead. 4. Supporting MM.
Why this happens. Scenario analysis and root cause.
S/4HANA modifies execution flows and enhancement frameworks. 1. Classic user exit points were replaced or deprecated. 2. Business logic moved to new BADI or enhancement spots. 3. Transaction flow sequencing changed under S/4 architecture. 4. Compatibility layers do not guarantee identical call order. Enhancement points evolve with architectural redesign.
Why this is a migration-exclusive failure.
ECC enhancement structures differ from S/4 frameworks. 1. S/4HANA reorganizes application logic internally. 2. New BADI definitions replace classic exits. 3. SBAU adjustments may deactivate legacy modifications. 4. Transformation shifts enhancement invocation order. Custom logic survival depends on correct adaptation.
Ownership, who actually fixes it.
Stabilization requires enhancement reevaluation. 1. ABAP reviews deprecated exits and migrates logic to supported BADIs. 2. MM validates functional impact of enhancement behavior. 3. Basis ensures transport consistency after remediation. 4. Architecture aligns custom logic with clean core standards.
Who gets blamed versus who owns it.
Missing validations create business concern. 1. Blamed SAP for removing exit functionality. 2. Blamed migration team for incomplete testing. 3. Actual owner custom enhancement not adapted to S4 framework. 4. Root cause legacy exit reliance without redesign.
How this is actually fixed, the right way by a role.
Correction must follow supported enhancement models. 1. ABAP team migrates legacy user exit logic to released baddies or enhancement spots. 2. MM team confirms business validation logic aligns with redesigned processes. 3. Basis team transports and validates enhancement activation across landscapes. 4. Architecture team enforces clean core compliance for future extensibility.
What not to do, common wrong fixes.
Temporary fixes create structural fragility. 1. Reactivating deprecated exit points forcefully. 2. Hard-coding validations directly in standard programs. 3. Ignoring ATC findings related to enhancement adaptation. 4. Assuming compatibility views guarantee enhancement stability. Unsupported modification patterns undermine upgrade stability.
Follow-up 1. Why do some exits partially work while others fail?
Answer: because certain compatibility layers still invoke legacy logic under specific transaction flows. However, internal sequencing changes prevent consistent execution across all business scenarios.
Follow-up 2. How can teams proactively detect exit failures?
Answer: by conducting code scans using ATC and reviewing simplification notes that identify deprecated enhancement points. Regression testing must explicitly validate custom logic execution.
Follow-up 3. Curveball. Why is forcing legacy exits considered risky long-term?
Answer: because unsupported enhancement points may break during future upgrades. Clean core compliance ensures forward compatibility and reduces technical debt accumulation.
Exclusive pro tip.
Every enhancement should be traceable to a released baddie or extension point. If it relies on deprecated exits, it is already a future upgrade risk.
Scenario 97. Implicit enhancements break.
After migration, implicit enhancements embedded within standard SAP programs stop executing or behave unpredictably. Business rules that previously injected custom logic during document posting or master data processing disappear without generating technical errors.
Scenario classification.
1. Complexity, critical hidden functional risk. 2. Phase, code remediation and SBAU adjustment. 3. Primary ownership, ABAP technical lead. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
Implicit enhancements depend on exact program structure. 1. Standard SAP programs were redesigned in S/4HANA. 2. Code blocks containing implicit enhancement anchors changed. 3. SBAU adjustments removed or altered enhancement positions. 4. Execution flow differences affect enhancement timing. Implicit enhancements are fragile by design.
Why this is a migration-exclusive failure.
ECC program structures differ significantly from S4. 1. S/4HANA refactors standard logic to align with new architecture. 2. Implicit enhancements are not guaranteed stable across upgrades. 3. Compatibility views do not preserve internal code structure. 4. Transformation invalidates assumptions about enhancement anchors. Migration exposes the fragility of modification-based design.
Ownership, who actually fixes it.
Correction requires structural refactoring. 1. ABAP identifies broken enhancement spots and migrates logic to supported frameworks. 2. MM validates business logic continuity after refactoring. 3. Basis ensures SBAU and SPDD adjustments are properly transported. 4. Architecture eliminates dependency on implicit enhancements moving forward.
Who gets blamed versus who owns it.
Invisible failures create confusion. 1. Blamed SAP for altering standard programs. 2. Blamed upgrade process for removing logic. 3. Actual owner enhancement design relying on implicit anchors. 4. Root cause unsupported modification strategy.
How this is actually fixed, the right way by a role.
Stabilization demands clean core compliance. 1. ABAP team refactors implicit enhancements into released baddies or enhancement spots. 2. MM team revalidates business scenarios impacted by enhancement migration. 3. Basis team controls SBAU adjustments and ensures consistency across systems. 4. Architecture team enforces elimination of implicit enhancement patterns.
What not to do, common wrong fixes.
Shortcuts increase upgrade instability. 1. Reinserting enhancement logic into modified standard code. 2. Ignoring SBAU conflict warnings. 3. Suppressing broken enhancement checks. 4. Assuming execution order remains unchanged. Implicit fixes compromise long-term upgradability.
Follow-up 1. Why are implicit enhancements more fragile than baddies?
Answer: because implicit enhancements rely on specific program line anchors. When SAP refactors internal code, those anchors may shift or disappear, breaking the enhancement silently.
Follow-up 2. How can teams identify vulnerable enhancements early?
Answer: by running custom code inventory and analyzing implicit enhancement usage before migration. ATC checks and SBAU simulations help detect structural risks.
Follow-up 3. Curveball. Why do projects still use implicit enhancements despite known risks?
Answer: because they offer quick flexibility during ECC customization. However, that flexibility becomes long-term technical debt during S4 transformation.
Exclusive pro tip.
If an enhancement depends on internal SAP program structure, it is a temporary solution. Clean core design ensures survivability beyond one upgrade cycle.
Scenario 98. Baddie implementation order changes.
After migration, certain business validations execute in a different sequence than in ECC. Custom baddie implementations that once produced predictable results now override or conflict with each other. The logic still runs, but not in the expected order.
Scenario classification.
1. Complexity, high logic conflict risk. 2. Phase, code remediation and functional regression testing. 3. Primary ownership, ABAP technical lead. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
S/4HANA refactors enhancement frameworks internally. 1. New baddie definitions replace classic enhancement spots. 2. Multiple active implementations create execution overlap. 3. Filter-dependent baddies behave differently under S4 logic. 4. Internal call sequence differs from ECC program flow. Execution order is part of business logic integrity.
Why this is a migration-exclusive failure.
ECC baddie sequencing relied on legacy framework behavior. 1. S/4HANA introduces new enhancement layering. 2. Multiple implementations may execute under different conditions. 3. Transformation modifies internal invocation flow. 4. Compatibility layers do not guarantee identical execution priority. Migration exposes enhancement sequencing assumptions.
Ownership, who actually fixes it.
Stabilization requires structured enhancement governance. 1. ABAP reviews baddie implementations and defines explicit execution priorities. 2. MM validates functional impact of sequencing changes. 3. Basis ensures consistent transport and activation status. 4. Architecture establishes enhancement layering standards.
Who gets blamed versus who owns it.
Unexpected logic outcomes trigger confusion. 1. Blamed SAP for altering execution order. 2. Blamed upgrade team for missing regression tests. 3. Actual owner multiple unmanaged baddie implementations. 4. Root cause undefined enhancement governance model.
How this is actually fixed. The right way by a role.
Correction requires explicit ownership and control. 1. ABAP team consolidates overlapping baddie implementations and defines execution sequence explicitly. 2. MM team revalidates functional scenarios impacted by enhancement order. 3. Basis team ensures consistent activation and transport synchronization across systems. 4. Architecture team defines governance to prevent uncontrolled baddie proliferation.
What not to do, common wrong fixes.
Short-term adjustments introduce future instability. 1. Deactivating baddies without impact analysis. 2. Hard-coding priority logic in standard code. 3. Ignoring filter-dependent execution behavior. 4. Assuming execution order will remain stable after future upgrades. Enhancement sequencing must be governed, not assumed.
Follow-up 1. Why does execution order matter so much?
Answer: because business validations and field derivations may depend on prior logic execution. If sequencing changes, downstream validations may override or nullify earlier calculations.
Follow-up 2. How can teams prevent sequencing conflicts?
Answer: by maintaining a documented enhancement inventory and consolidating overlapping implementations into structured governance models.
Follow-up 3, curveball. Why are sequencing issues difficult to detect?
Answer: because the code still executes without technical errors. Only functional regression testing reveals subtle behavioral differences.
Exclusive pro tip.
Multiple baddie implementations without governance create silent logic wars. Consolidation and sequencing clarity are mandatory in S/4HANA.
Scenario 99. SPDD or SBAU removes critical logic.
During upgrade and conversion activities, SPDD and SBAU adjustments are performed to align custom modifications with new SAP standard objects. After go-live, certain validations or calculations no longer execute, even though no technical error is visible. Critical custom logic was overwritten or incorrectly adjusted.
Scenario classification.
1. Complexity, critical functional integrity risk. 2. Phase, code remediation and upgrade adjustment. 3. Primary ownership, ABAP technical lead. 4. Supporting basis.
Why this happens, scenario analysis and root cause.
SPDD and SBAU govern adjustment of modified SAP objects. 1. Custom modifications were embedded in standard SAP objects. 2. Upgrade resets or replaces portions of modified code. 3. Adjustment decisions were made under timeline pressure. 4. Transport inconsistencies caused partial logic loss. Modification-based design becomes fragile during upgrades.
Why this is a migration-exclusive failure.
SPDD and SBAU adjustments are unique to upgrade scenarios. 1. S/4HANA conversion involves extensive object redefinition. 2. Modified standard programs require reconciliation. 3. Transformation exposes modification-heavy landscapes. 4. Upgrade pressure increases risk of incomplete adjustments. Migration forces reconciliation between customization and standard.
Ownership, who actually fixes it.
Correction demands structured code governance. 1. ABAP reviews SPDD and SBAU logs to identify overwritten logic. 2. Basis ensures consistent transport sequencing during upgrade. 3. validates business-critical validations post-adjustment. 4. Architecture eliminates modification-based customizations.
Who gets blamed versus who owns it.
Logic loss triggers organizational tension. 1. Blamed upgrade team for incorrect adjustments. 2. Blamed SAP for overriding modifications. 3. Actual owner historical modification strategy. 4. Root cause direct modification of standard SAP objects.
How this is actually fixed. The right way by a role.
Recovery requires disciplined remediation. 1. ABAP team reconstructs overwritten logic and migrates it to supported enhancement frameworks. 2. Basis team revalidates transport sequencing and upgrade adjustment completeness. 3. team performs regression testing on impacted business transactions. 4. Architecture team enforces elimination of direct standard modifications.
What not to do, common wrong fixes.
Temporary restoration increases future upgrade risk. 1. Reinserting code directly into modified SAP programs. 2. Skipping regression testing after adjustment. 3. Ignoring SBAU conflicts to meet deadlines. 4. Postponing clean core remediation to later phases. Modification-heavy systems degrade upgrade stability.
Follow-up 1. Why is SPDD or SBAU risk higher in S4 conversion?
Answer: because S4 introduces large-scale object restructuring. Modified programs face significant internal changes, increasing the probability of overwritten custom logic.
Follow-up 2. How can teams reduce SPDD or SBAU risk proactively?
Answer: by minimizing direct modifications before migration and performing thorough custom code inventory analysis months prior to conversion.
Follow-up 3. Curveball. Why do some projects ignore modification cleanup?
Answer: because immediate functional continuity feels more urgent than structural correction. However, repeated upgrades compound instability and technical debt.
Exclusive pro tip.
If your landscape relies on direct standard modifications, migration is not just a technical event. It is a design reckoning.
Scenario 100. Z transactions break in Fiori.
After migration, custom Z transactions that functioned correctly in SAP GU I begin failing or behaving inconsistently when accessed through Fiori Launchpad. Users report missing fields, broken navigation, or authorization errors even though the backend logic appears intact.
Scenario classification.
1. Complexity, high user adoption and access risk. 2. Phase, post-go-live stabilization and Fiori rollout. 3. Primary ownership, ABAP technical lead. 4. Supporting Fiori.
Why this happens, scenario analysis and root cause.
Fiori introduces a different interaction layer. 1. Custom transactions were designed for SAP GUI rendering. 2. Fiori requires OData services and UI annotations. 3. Authorization objects differ between GUI and Fiori. 4. Navigation logic does not automatically translate to Launchpad tiles. Front-end architecture shift exposes GUI-only design.
Why this is a migration-exclusive failure.
ECC primarily relied on SAP GUI-based interaction. 1. S/4HANA promotes Fiori as strategic UI layer. 2. Custom Z transactions were not designed with UI decoupling. 3. Backend logic lacks OData exposure where required. 4. Transformation introduces role-based Fiori catalogs. Migration shifts interaction model, not just backend logic.
Ownership, who actually fixes it.
Stabilization requires front-end and backend coordination. 1. ABAP refactors Z transactions to expose required OData services. 2. Fiori configures Launchpad tiles, catalogs, and annotations. 3. MM validates functional completeness of redesigned UI. 4. Security aligns authorization roles between GUI and Fiori.
Who gets blamed versus who owns it.
UI disruption quickly affects user confidence. 1. Blamed Fiori for breaking transactions. 2. Blamed migration for removing GUI stability. 3. Actual owner Z transactions not designed for UI decoupling. 4. Root cause backend-only customization in a front-end driven system.
How this is actually fixed, the right way by a role.
Correction requires UI-aware redesign. 1. ABAP team develops or adjusts OData services to expose required functionality. 2. Fiori team configures proper tiles, catalogs, and semantic object navigation. 3. MM team validates that business processes execute consistently across UI layers. 4. Security team aligns authorization roles and Fiori catalogs for user groups.
What not to do, common wrong fixes.
Shortcuts reduce long-term maintainability. 1. Forcing users back to SAP GUI permanently. 2. Hard-coding UI adjustments in backend logic. 3. Ignoring Fiori catalog role alignment. 4. Treating Fiori issues as cosmetic rather than architectural. Front-end modernization requires structural adaptation.
Follow-up 1. Why do Z transactions work in GUI but fail in Fiori?
Answer: because GUI interacts directly with backend transactions, while Fiori relies on OData services and UI annotations. Without proper exposure and role alignment, functionality breaks at the presentation layer.
Follow-up 2. Can we keep GUI and ignore Fiori entirely?
Answer: technically possible in some cases, but it contradicts SAP's strategic direction. Over time, more processes and innovations rely on Fiori-based architecture.
Follow-up 3. Curveball. Why does UI instability affect adoption more than backend errors?
Answer: because users interact with the UI daily. Even minor interface inconsistencies erode confidence faster than backend technical adjustments.
Exclusive pro tip.
If a Z transaction is business critical, redesign it with Fiori readiness in mind. UI decoupling is not optional in S/4HANA.
Category 18 wrap-up. Customization without governance is fragility.
Extensibility in S/4HANA demands discipline. Enhancements that bypass clean core principles may survive one upgrade, but they rarely survive transformation. Migration exposes whether customization was strategic or accidental.
Transition. When historical data meets a new architecture.
Migration is not only about future transactions. It is also about historical integrity. S/4HANA introduces new valuation logic, unified journals, and extended dimensions. Historical data that once reconciled in ECC may tell a different story after conversion.
Please check description or comment section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP functional modules interviews jobs like SAP MM Consultant jobs, SAP FICO Consultant jobs, SAP SD Consultant jobs, SAP PP Consultant jobs, SAP Ariba Consultant jobs, SAP Extended Warehouse Management EWM Consultant jobs, SAP Plant Maintenance PM Consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Category 19. Data Migration and Historical Semantics.
S/4HANA consolidates financial and logistics data into new structures such as MATDOC and ACDOCA. Historical stock quantities, valuation layers, and open transactional balances must align with this architecture. Silent inconsistencies surface during reconciliation.
Scenarios covered in Category 19.
Scenario 101, historical stock cannot be reconciled. Primary owner MM data led. Supporting FI. Scenario 102, batch history incomplete. Primary owner MM data led. Supporting QM. Scenario 103, open purchase order data inconsistent. Primary owner MM data led. Supporting FI. Scenario 104, stock quantity correct but valuation wrong. Primary owner. FI cross-module. Supporting MM. Scenario 105, legacy inconsistencies surface in S4. Primary owner MM data-led. Supporting FI.
Scenario 101. Historical stock cannot be reconciled.
After migration, historical stock balances in S4HANA do not reconcile with legacy ECC reports. Quantity totals appear correct at a high level, yet detailed plant or storage location analysis reveals discrepancies. Financial valuation may align partially, but material-level breakdowns fail.
Scenario classification.
1. Complexity, critical financial and audit risk. 2. Phase, data migration validation and first financial close. 3. Primary ownership, MM data-led. 4. Supporting FI.
Why this happens, scenario analysis and root cause.
Data structure transformation alters reconciliation logic. 1. MATDOC consolidates historical movement data differently than MSEG. 2. Material ledger activation impacts valuation layers. 3. Legacy stock adjustments were not fully cleaned before migration. 4. Data migration loads opening balances without resolving historic inconsistencies. Migration surfaces historical design and data discipline gaps.
Why this is a migration-exclusive failure.
ECC reports tolerated legacy balancing shortcuts. 1. S4HANA unifies quantity and valuation data structures. 2. Universal Journal introduces stricter reconciliation visibility. 3. Transformation reevaluates historical balances under new logic. 4. Migration highlights discrepancies previously masked by reporting layers. New architecture increases transparency into historical data.
Ownership, who actually fixes it.
Reconciliation requires structured collaboration. 1. MM analyzes historical quantity inconsistencies at plant and storage location level. 2. FI validates valuation alignment and financial impact. 3. Data team reviews migration load files and opening balance logic. 4. Architecture ensures reconciliation methodology aligns with S4 data model.
Who gets blamed versus who owns it?
Historical discrepancies trigger executive concern. 1. Blamed migration team for incorrect data load. 2. Blamed S4HANA for altering balances. 3. Actual owner legacy stock inconsistencies accumulated in ECC. 4. Root cause historical adjustments never fully reconciled.
How this is actually fixed, the right way by a role.
Resolution must follow structured reconciliation. 1. MM team conducts plant level and storage location level stock reconciliation against ECC snapshots. 2. FI team reconciles inventory valuation to universal journal balances. 3. Data team reviews and corrects opening balance migration logic where required. 4. Architecture team establishes reconciliation governance before financial closing.
What not to do, common wrong fixes.
Superficial corrections compromise audit integrity. 1. Manually adjusting stock balances without documentation. 2. Ignoring minor discrepancies assuming immateriality. 3. Reloading balances without root cause analysis. 4. Closing financial periods before reconciliation completion. Reconciliation discipline protects audit credibility.
Follow-up 1. Why do quantities sometimes match but valuation does not?
Answer: because material ledger activation and universal journal logic may recalculate valuation layers differently than ECC. Quantity and value reconciliation follow distinct logic paths under S4HANA.
Follow-up 2. How early should reconciliation testing begin?
Answer: reconciliation must begin in sandbox conversion cycles using production-like data snapshots, waiting until cutover increases financial risk exposure.
Follow-up 3. Curveball. Why are historical discrepancies often politically sensitive?
Answer: because they reveal years of legacy adjustments and balancing shortcuts. Migration forces transparency that may challenge prior operational assumptions.
Exclusive pro tip.
Treat historical reconciliation as a forensic audit, not a technical checklist. S4HANA exposes what ECC allowed to accumulate silently.
Scenario 102. Batch history incomplete.
After migration, batch-managed materials show missing historical movements or incomplete genealogy chains. Quality, compliance, or traceability reports fail to display full lifecycle information. Operational stock exists, but historical visibility is fragmented.
Scenario classification.
1. Complexity, high compliance and traceability risk. 2. Phase data migration validation. 3. Primary ownership MM data-led. 4. Supporting QM.
Why this happens, scenario analysis and root cause.
Batch traceability depends on complete historical linkage. 1. Historical batch movement tables were partially archived in ECC. 2. Migration focused on open stock but not genealogy history. 3. Batch classification characteristics were inconsistently migrated. 4. Cross-plant batch relationships were not fully aligned. Traceability requires historical completeness, not just current balance.
Why this is a migration-exclusive failure.
ECC tolerated fragmented historical batch structures. 1. S4HANA centralizes batch and stock data into new structures. 2. Unified data models expose incomplete genealogy chains. 3. Migration often prioritizes open balances over historical lineage. 4. Transformation increases audit and compliance visibility. S4HANA enhances transparency into batch lifecycle data.
Ownership, who actually fixes it.
Traceability correction demands cross-functional effort. 1. MM reviews batch master data and cross-plant linkages. 2. QM validates genealogy and quality-relevant characteristics. 3. Data team audits historical batch movement migration logic. 4. Architecture defines long-term batch data governance model.
Who gets blamed versus who owns it.
Compliance visibility increases accountability. 1. Blamed migration team for incomplete data load. 2. Blamed S4HANA for missing history. 3. Actual owner historical batch archiving and ECC data discipline. 4. Root cause incomplete genealogy management before migration.
How this is actually fixed, the right way by a role.
Restoration requires controlled reconciliation. 1. team reconstructs missing batch relationships using ECC historical extracts. 2. team validates full genealogy chains for compliance-critical materials. 3. Data team corrects migration logic to include required historical movement records. 4. Architecture team defines retention policy for batch history going forward.
What not to do, common wrong fixes.
Shortcuts create regulatory exposure. 1. Recreating batch records manually without traceability. 2. Ignoring missing genealogy for non-critical materials. 3. Deleting incomplete history to hide gaps. 4. Assuming open stock suffices for compliance reporting. Incomplete traceability risks audit and regulatory penalties.
Follow-up 1. Why does batch history matter beyond inventory balance?
Answer: because regulated industries depend on full genealogy for recall management, quality audits, and compliance reporting. Missing links compromise traceability.
Follow-up 2. How can teams detect genealogy gaps early?
Answer: by executing backward and forward traceability simulations during migration testing and comparing results with ECC historical data snapshots.
Follow-up 3. Curveball. Why are batch issues often underestimated during migration?
Answer: because projects prioritize financial reconciliation over operational traceability. Yet compliance exposure may exceed financial discrepancy impact.
Exclusive pro tip.
Batch migration is not only about open stock. It is about preserving traceability continuity across system transformation.
Scenario 103. Open purchase order data inconsistent.
After migration, open purchase orders appear technically available in the system, yet quantities, delivery dates, account assignments, or GRIR balances do not reconcile with ECC snapshots. Some POs cannot be processed further, while others produce accounting inconsistencies during goods receipt or invoice posting.
Scenario classification.
1. Complexity, high operational and financial risk. 2. Phase, cutover and post-go-live stabilization. 3. Primary ownership, data-led. 4. Supporting FI.
Why this happens, scenario analysis and root cause.
Open transactional data is structurally sensitive during conversion. 1. Cutover extraction timing does not align with last transactional postings. 2. GRIR balances were not frozen consistently before migration. 3. Account assignment structures changed under S/4HANA data model. 4. Partial goods receipts and invoice history were not fully synchronized. Open documents amplify timing and structural inconsistencies.
Why this is a migration exclusive failure.
Open documents are uniquely exposed during system transformation. 1. ECC allowed transactional continuity without structural reevaluation. 2. S/4HANA conversion recalculates document relationships. 3. Universal Journal introduces stricter reconciliation visibility. 4. Transformation interrupts document lifecycle midstream. Only migration forces lifecycle interruption analysis.
Ownership, who actually fixes it.
Resolution requires cross-functional coordination. 1. Reviews open PO quantities, delivery schedules, and account assignments. 2. FI validates GRIR balances and accounting impact. 3. Data team reconciles pre-cutover and post-load document snapshots. 4. Cutover team adjusts freeze timing and transactional lock windows.
Who gets blamed versus who owns it.
Open PO inconsistencies create operational panic. 1. Blamed migration team for corrupt document load. 2. Blamed system conversion for recalculation logic. 3. Actual owner cutover timing misalignment and legacy data discipline. 4. Root cause incomplete transactional freeze strategy.
How this is actually fixed, the right way by a role.
Stabilization requires structured reconciliation. 1. team reconciles open quantities and delivery schedules against ECC cutover extracts. 2. FI team validates and adjusts GRIR balances using controlled correction postings. 3. Data team reviews migration load logic and identifies document lifecycle mismatches. 4. Cutover team redefines freeze windows to prevent transactional drift.
What not to do, common wrong fixes.
Quick operational patches increase audit exposure. 1. Deleting and recreating purchase orders without reconciliation. 2. Manually adjusting quantities without accounting alignment. 3. Posting ad hoc FI corrections without root cause documentation. 4. Ignoring minor mismatches to preserve timeline. Open document integrity protects financial and operational continuity.
Follow-up 1. Why are open POs more sensitive than closed documents?
Answer: because open documents carry incomplete lifecycle states. Goods receipt, invoice verification, and account assignment remain active, making them structurally exposed during conversion.
Follow-up 2. How can teams minimize open PO risk before cutover?
Answer: by reducing open document volume, clearing GRIR balances proactively, and aligning transactional freeze windows with extraction timing.
Follow-up 3. Curveball. Why do open document discrepancies often escalate politically?
Answer: because they immediately impact procurement operations and financial closing. Unlike historical inconsistencies, open POs disrupt live business continuity.
Exclusive pro tip.
Treat open document migration as a surgical procedure. Every incomplete lifecycle state must be validated before go live.
Scenario 104. Stock quantity correct but valuation wrong.
After migration, physical stock quantities reconcile perfectly between ECC and S/4HANA. However, inventory valuation differs at material, plant, or ledger level. Finance identifies unexplained differences in stock accounts even though operational inventory appears accurate.
Scenario classification.
1. Complexity, critical financial statement risk. 2. Phase, post-migration financial reconciliation. 3. Primary ownership, FI cross-module. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
Valuation logic transforms under S/4HANA architecture. 1. Material ledger becomes mandatory in S/4HANA. 2. Currency and valuation layers are recalculated during conversion. 3. Parallel valuation logic differs from ECC configuration. 4. Historical price differences were not fully settled before migration. Quantity integrity does not guarantee valuation integrity.
Why this is a migration exclusive failure.
ECC allowed simpler valuation visibility. 1. S/4HANA enforces universal journal integration with material ledger. 2. Parallel valuation and multi-currency layers become structurally visible. 3. Conversion recalculates valuation history under new rules. 4. Transformation exposes unresolved price and exchange differences. Migration enforces valuation transparency.
Ownership, who actually fixes it.
Financial valuation correction demands cross-module control. 1. FI analyzes valuation layers and ledger differences. 2. MM reviews material price control and stock movement history. 3. CO validates actual costing and price difference settlement. 4. Data team reconciles opening valuation balances.
Who gets blamed versus who owns it.
Valuation discrepancies raise executive concern immediately. 1. Blamed S/4HANA for recalculating inventory values. 2. Blamed migration team for incorrect load. 3. Actual owner unsettled price differences and legacy ML configuration. 4. Root cause historical valuation discipline gaps.
How this is actually fixed, the right way by a role.
Resolution requires structured valuation analysis. 1. FI team reconciles universal journal balances with material valuation tables. 2. MM team validates price control settings and historical stock movements. 3. CO team reviews actual costing runs and unsettled price differences. 4. Data team corrects opening valuation loads where discrepancies are confirmed.
What not to do, common wrong fixes.
Superficial fixes create audit risk. 1. Posting manual FI adjustments without root cause. 2. Changing price control settings mid-cycle. 3. Ignoring minor valuation differences to close books. 4. Blaming currency translation without detailed analysis. Inventory valuation must be analytically defensible.
Follow-up 1. Why does material ledger make valuation more sensitive?
Answer: because material ledger tracks multi-currency and parallel valuation layers at a granular level. Small historical inconsistencies become structurally visible under universal journal integration.
Follow-up 2. Should valuation differences always be corrected before first close?
Answer: yes. Even minor discrepancies can cascade across reporting layers. Financial statements must align with reconciled inventory balances under the new architecture.
Follow-up 3, curveball. Why do executives react more strongly to valuation than quantity issues?
Answer: because valuation directly impacts financial statements and audit credibility. Quantity differences affect operations, but valuation discrepancies challenge financial integrity.
Exclusive pro tip.
Never certify migration success based on stock quantity alone. Valuation alignment defines financial stability under S/4HANA.
Scenario 105. Legacy inconsistencies surface in S4.
After go-live, transactions begin failing or producing unexpected results even though migration technically succeeded. Investigation reveals that legacy configuration shortcuts, inconsistent master data, or historic posting workarounds that functioned in ECC are no longer tolerated in S/4HANA.
Scenario classification.
1. Complexity, high systemic stability risk. 2. Phase, post-go-live stabilization. 3. Primary ownership, data-led. 4. Supporting FI.
Why this happens, scenario analysis and root cause.
S/4HANA enforces architectural discipline more strictly than ECC. 1. Custom configuration dependencies were never standardized. 2. Master data inconsistencies accumulated over years of operations. 3. Workarounds masked structural gaps in ECC. 4. Unified data model exposes previously hidden relationships. Transformation increases structural transparency.
Why this is a migration-exclusive failure.
Steady-state ECC rarely challenges architectural shortcuts. 1. S/4HANA consolidates logistics and financial data layers. 2. Simplification items remove tolerated legacy structures. 3. Universal journal increases cross-module visibility. 4. Migration removes structural tolerance that ECC allowed. S/4HANA is less forgiving to historical technical debt.
Ownership, who actually fixes it.
Correction requires systemic governance. 1. Reviews master data discipline and configuration alignment. 2. FI validates financial integration consistency. 3. ABAP identifies legacy custom logic conflicts. 4. Architecture establishes clean core enforcement policy.
Who gets blamed versus who owns it.
Stability issues often create reactive blame cycles. 1. Blamed S/4HANA for being too restrictive. 2. Blamed project team for insufficient testing. 3. Actual owner accumulated legacy shortcuts and weak governance. 4. Root cause historical architectural drift.
How this is actually fixed, the right way by a role.
Long-term stability requires structural correction. 1. team standardizes master data governance and removes inconsistent configuration. 2. FI team aligns integration logic across valuation and posting structures. 3. ABAP team refactors legacy enhancements conflicting with clean core principles. 4. Architecture team defines and enforces post-migration design governance.
What not to do, common wrong fixes.
Temporary workarounds deepen instability. 1. Reintroducing ECC-style shortcuts. 2. Adding emergency Z logic to bypass new validations. 3. Ignoring systemic issues to protect timeline metrics. 4. Blaming platform rigidity instead of correcting design. Stability comes from discipline, not tolerance.
Follow-up 1. Why do legacy inconsistencies only appear after go-live?
Answer: because production data volume and real process combinations expose structural weaknesses not fully simulated in testing. S/4HANA enforces stricter integration logic during live operations.
Follow-up 2. How can teams proactively prevent this scenario?
Answer: by performing data quality audits, configuration rationalization, and custom code reviews months before conversion, rather than relying solely on technical readiness checks.
Exclusive pro tip.
Migration does not create new problems. It reveals existing ones. Treat post-go-live instability as architectural feedback, not platform failure.
Category 19 wrap-up. Data does not lie, it surfaces history.
S/4HANA migration does not invent inconsistencies. It exposes historical design shortcuts, valuation gaps, and master data discipline issues. If reconciliation fails, it is not a system defect. It is accumulated technical debt finally becoming visible.
Transition, when output logic gets rewrit.
One of the most underestimated shifts in S/4HANA is output management. What worked for years through ST and smart forms may silently stop triggering. Migration forces a complete rethink of how documents are generated and distributed.
Category 20, Output Management Full Replacement.
S/4HANA replaces classic output determination frameworks with BRF Plus based output management. Legacy NAST logic, condition records, and smart forms integrations may no longer behave as expected. This transformation impacts procurement, billing, and logistics document flow.
Scenarios covered in Category 20.
Scenario 106, NAST table logic invalid. Primary owner ABAP technical lead. Supporting Scenario 107 smart forms to Adobe form issues. Primary owner ABAP technical lead. Supporting basis. Scenario 108 batch output jobs fail. Primary owner basis technical lead. Supporting Scenario 109 BRF plus output performance issues. Primary owner basis technical lead. Supporting ABAP. Scenario 110 output determination missing conditions. Primary owner cross-module. Supporting ABAP.
Scenario 106, NAST table logic invalid.
After migration, purchase orders, goods movements, or billing documents are created successfully, but no output is generated. Emails are not sent, print jobs are not triggered, and message logs remain empty. The legacy NAST-based output framework no longer controls document communication.
Scenario classification.
1. Complexity, high business communication disruption. 2. Phase, post-conversion functional stabilization. 3. Primary ownership, ABAP technical lead. 4. Supporting
Why this happens, scenario analysis and root cause.
S/4HANA introduces a new output determination framework. 1. NAST-based output determination is replaced by BRF plus logic. 2. Condition records were not migrated to new output configuration. 3. Custom programs still reference legacy NAST entries. 4. Output parameter determination was not reconfigured post-migration. Legacy output assumptions no longer apply in S/4HANA.
Why this is a migration-exclusive failure.
ECC relied heavily on NAST for document messaging. 1. S/4HANA introduces new output management architecture. 2. NAST remains for compatibility but is not primary framework. 3. Conversion does not automatically redesign output rules. 4. Transformation forces explicit reconfiguration of document logic. Output redesign is mandatory, not optional.
Ownership, who actually fixes it.
Output correction requires technical and functional alignment. 1. ABAP reviews legacy NAST-based enhancements and references. 2. validates functional output requirements per document type. 3. Basis ensures output channels and communication settings are active. 4. Architecture defines standardized output governance model.
Who gets blamed versus who owns it.
Missing outputs create immediate operational pressure. 1. Blamed SAP for removing NAST. 2. Blamed system migration for breaking printing. 3. Actual owner output redesign not performed during transformation. 4. Root cause assumption that compatibility equals continuity.
How this is actually fixed, the right way by a role.
Resolution requires structured output redesign. 1. ABAP team refactors custom output logic to align with BRF Plus framework. 2. team configures new output determination rules and condition records. 3. Basis team validates communication channels such as email, print, and IDOC distribution. 4. Architecture team establishes standardized output governance across modules.
What not to do, common wrong fixes.
Temporary patches increase long-term instability. 1. Reactivating obsolete NAST logic without redesign. 2. Hard-coding output triggers in custom programs. 3. Ignoring missing outputs assuming business will adapt. 4. Duplicating output logic across multiple frameworks. Output logic must be architected, not patched.
Follow-up 1. Why does NAST still exist if it is no longer primary?
Answer: NAST remains for backward compatibility in specific scenarios, but S/4HANA promotes BRF Plus as the strategic framework. Relying on A ST long-term introduces technical debt.
Follow-up 2. Can projects defer output redesign until after go-live?
Answer: deferral creates operational disruption. Output determination must be validated before productive document flow resumes.
Follow-up 3. Curveball. Why do teams underestimate output management impact?
Answer: because output logic feels peripheral. In reality, procurement, billing, and compliance processes depend on reliable document communication.
Exclusive pro tip.
If documents are created but not communicated, business stops. Treat output redesign as mission-critical during migration.
Scenario 107. Smart forms to Adobe form issues.
After migration, document layouts display formatting errors, missing fields, or rendering failures. Some forms do not generate at all, while others produce corrupted PDFs. Legacy Smart Forms logic does not seamlessly transition to Adobe Forms under S/4HANA.
Scenario classification.
1. Complexity, high operational and customer impact. 2. Phase, post-conversion functional stabilization. 3. Primary ownership, ABAP technical-led. 4. Supporting basis.
Why this happens. Scenario analysis and root cause.
Form framework transformation changes rendering logic. 1. Smart Forms and SAP script are deprecated in strategic roadmap. 2. Adobe Forms require new interface structures and data mapping. 3. Legacy custom form exits were not redesigned. 4. Output device and PDF rendering configuration differs in S/4HANA. Form migration is not a simple technical switch.
Why this is a migration-exclusive failure.
ECC and S/4HANA use different strategic form frameworks. 1. ECC environments tolerated mixed smart forms usage. 2. S/4HANA standard output aligns with Adobe framework. 3. Conversion does not auto-convert form layouts or logic. 4. Transformation exposes hard-coded layout dependencies. Output layout redesign is mandatory under S/4HANA.
Ownership, who actually fixes it.
Form correction demands technical and infrastructure alignment. 1. ABAP redesigns form interface structures and layout logic. 2. Basis configures Adobe Document Services and rendering parameters. 3. MM or SD validates business content accuracy and compliance. 4. Architecture defines standardized form strategy.
Who gets blamed versus who owns it.
Broken document layouts trigger immediate user frustration. 1. Blamed migration team for broken forms. 2. Blamed SAP for forcing Adobe adoption. 3. Actual owner incomplete form redesign and testing. 4. Root cause assumption that layout migration is automatic.
How this is actually fixed. The right way by a role.
Resolution requires structured form redevelopment. 1. ABAP team redesigns smart forms logic into Adobe form interface structures. 2. Basis team configures and tests Adobe Document Services integration. 3. Business team validates document layout, legal text, and branding accuracy. 4. Architecture team defines long-term form governance standards.
What not to do. Common wrong fixes.
Shortcuts compromise document integrity. 1. Copying smart forms layouts without redesigning interface logic. 2. Ignoring PDF rendering configuration in basis layer. 3. Hard-coding missing fields directly into layout. 4. Allowing parallel smart forms and Adobe frameworks long-term. Form redesign must align with strategic architecture.
Follow-up 1. Why do some forms partially work while others fail completely?
Answer: because interface structures and data bindings differ per document type. Forms with minimal custom logic may render successfully, while heavily customized layouts expose structural gaps.
Follow-up 2. Should smart forms be retained for compatibility?
Answer: retaining smart forms increases technical debt. Strategic alignment with Adobe framework ensures long-term upgrade compatibility.
Follow-up 3. Curveball. Why do executives underestimate document layout risk?
Answer: because layout changes appear cosmetic. In reality, invoices, purchase orders, and delivery notes are legal documents requiring strict compliance accuracy.
Exclusive pro tip.
Document forms are legal artifacts. Treat form migration with the same rigor as financial reconciliation.
Scenario 108. Batch output jobs fail.
After migration, scheduled background jobs responsible for mass document output stop processing. Purchase orders are created, invoices posted, and delivery notes generated, but nightly output jobs either terminate, hang indefinitely, or process only partial volumes.
Scenario classification.
1. Complexity, high operational disruption risk. 2. Phase, post-go-live stabilization. 3. Primary ownership basis technical lead. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
Background processing logic changes under S/4HANA architecture. 1. Legacy batch jobs reference in a ST-based selection logic. 2. Job parallelization settings conflict with new output framework. 3. HANA execution exposes inefficient selection queries. 4. Spool or communication parameters were not adjusted post-conversion. Batch output depends on architectural alignment, not just scheduling.
Why this is a migration-exclusive failure.
ECC batch jobs were tuned for a different data model. 1. S/4HANA replaces classic output frameworks. 2. HANA runtime changes performance characteristics. 3. Parallel processing behaves differently under new architecture. 4. Conversion does not automatically redesign batch strategies. Migration invalidates historical performance assumptions.
Ownership, who actually fixes it.
Stabilization requires both infrastructure and logic review. 1. Basis reviews background job scheduling and parallelization parameters. 2. ABAP analyzes inefficient selection and output logic. 3. Validates document selection criteria and output completeness. 4. Architecture defines standardized batch processing governance.
Who gets blamed versus who owns it.
Batch failures generate operational escalation. 1. Blamed basis because jobs terminated. 2. Blamed HANA for performance instability. 3. Actual owner, legacy batch design not aligned with S/4 architecture. 4. Root cause, assumption that old scheduling logic remains valid.
How this is actually fixed, the right way by a role.
Resolution requires structured performance and logic redesign. 1. Basis team reviews and optimizes background job scheduling and parallel processing parameters. 2. ABAP team refactors inefficient selection logic and aligns it with new output framework. 3. team validates completeness of document selection after redesign. 4. Architecture team defines long-term batch processing standards.
What not to do, common wrong fixes.
Temporary patches create recurring instability. 1. Increasing job frequency without analyzing root cause. 2. Disabling parallelization blindly. 3. Restarting failed jobs without redesign. 4. Ignoring partial output assuming low business impact. Batch output stability requires architectural redesign.
Follow-up 1. Why do some batch jobs work while others fail?
Answer: because document volume, selection criteria, and runtime behavior differ. Jobs handling small volumes may succeed, while large or parallel-intensive jobs expose architectural weaknesses.
Follow-up 2. How can performance testing reduce this risk?
Answer: by executing full-volume batch simulations in performance testing environments and validating output completeness before go-live.
Follow-up 3. Curveball. Why is batch instability often underestimated?
Answer: because background jobs run outside direct user visibility. Failures may accumulate silently until document backlog impacts operations.
Exclusive pro tip.
If output depends on background jobs, treat performance validation as critical as financial reconciliation.
Scenario 109. BRF plus output performance issues.
After migrating to S/4HANA, document output determination through BRF Plus becomes noticeably slow. Purchase orders, invoices, or deliveries take longer to save, especially during peak processing hours. Users experience system lag, even though no functional errors occur.
Scenario classification.
1. Complexity, high performance, and user experience risk. 2. Phase, post-go-live performance optimization. 3. Primary ownership basis technical lead. 4. Supporting ABAP.
Why this happens, scenario analysis and root cause.
BRF Plus evaluates rules dynamically at runtime. 1. Complex decision tables with excessive conditions increase evaluation time. 2. Custom logic embedded in BRF Plus rules is inefficient. 3. High document volume amplifies runtime overhead. 4. HANA execution exposes poorly structured rule design. Performance degradation originates in rule complexity.
Why this is a migration-exclusive failure.
ECC relied on static condition techniques. 1. S/4HANA introduces dynamic rule-based output logic. 2. Conversion often replicates ECC logic without simplification. 3. Rule volume expands during redesign. 4. Migration increases runtime visibility into rule inefficiencies. Transformation shifts output logic from static to dynamic evaluation.
Ownership, who actually fixes it.
Performance tuning requires both infrastructure and logic refinement. 1. Basis monitors system runtime metrics and workload distribution. 2. ABAP reviews BRF plus rule efficiency and custom enhancements. 3. MM simplifies output conditions and removes redundant rules. 4. Architecture defines governance for rule design complexity.
Who gets blamed versus who owns it.
Slow document saving triggers immediate escalation. 1. Blamed HANA for performance degradation. 2. Blamed basis for system tuning issues. 3. Actual owner over-engineered BRF plus rule logic. 4. Root cause migration of legacy complexity without optimization.
How this is actually fixed. The right way by a role.
Optimization requires structured rule simplification. 1. Basis team analyzes runtime traces and identifies output rule bottlenecks. 2. ABAP team refactors inefficient BRF plus logic and removes redundant checks. 3. MM team simplifies decision tables and consolidates output conditions. 4. Architecture team defines rule design standards to prevent complexity growth.
What not to do, common wrong fixes.
Quick performance hacks create instability. 1. Increasing system resources without analyzing rule design. 2. Disabling complex rules without impact assessment. 3. Duplicating output logic across modules. 4. Ignoring performance degradation as temporary. Performance issues reflect design, not just hardware.
Follow-up 1. Why does performance degrade during peak hours?
Answer: because BRF Plus evaluates rules per document at runtime. High transaction volume multiplies evaluation cost, exposing inefficient rule structures.
Follow-up 2. How can teams proactively prevent BRF performance issues?
Answer: by limiting rule complexity, consolidating condition logic, and conducting load testing with production-level transaction volumes.
Follow-up 3. Curveball. Why do teams over-engineer output rules?
Answer: because flexibility is mistaken for robustness. Overly granular rule conditions increase maintenance cost and runtime overhead.
Exclusive pro tip.
In S/4HANA, output logic should be elegant, not exhaustive. Complexity multiplies at runtime.
Scenario 110. Output determination missing conditions.
After go-live, certain purchase orders, goods receipts, or invoices fail to trigger output despite being processed successfully. Some documents generate output correctly, while others do not. The issue appears inconsistent and difficult to reproduce.
Scenario classification.
1. Complexity, high operational and communication risk. 2. Phase, post-go-live functional stabilization. 3. Primary ownership MM cross-module. 4. Supporting ABAP.
Why this happens, scenario analysis and root cause.
Output determination logic depends on condition completeness. 1. BRF plus decision tables were incompletely configured. 2. Condition records were not fully migrated from ECC. 3. Document types lack assigned output determination procedures. 4. Access sequence logic does not cover all business combinations. Missing output conditions create silent communication gaps.
Why this is a migration-exclusive failure.
ECC output logic relied on stable condition techniques. 1. S/4HANA shifts output logic to BRF plus configuration. 2. Conversion does not auto-generate complete decision tables. 3. New document types may require new output procedures. 4. Migration expands condition complexity without validation. Transformation requires deliberate output redesign.
Ownership, who actually fixes it.
Resolution requires functional and technical validation. 1. MM reviews output determination procedures and condition records. 2. ABAP validates BRF plus rule assignments and logic coverage. 3. Basis confirms communication channel configuration. 4. Architecture establishes standardized output configuration governance.
Who gets blamed versus who owns it?
Missing output creates operational confusion. 1. Blamed system instability for inconsistent behavior. 2. Blamed migration project for incomplete testing. 3. Actual owner incomplete output condition configuration. 4. Root cause assumption that legacy conditions transfer automatically.
How this is actually fixed, the right way by a role.
Correction requires comprehensive condition validation. 1. MM team reviews and completes output determination procedures for all document types. 2. ABAP team validates BRF plus rule coverage and corrects decision logic gaps. 3. Basis team confirms communication channel and output device configuration. 4. Architecture team defines output configuration validation checklist for future changes.
What not to do, common wrong fixes.
Ad hoc fixes create long-term inconsistency. 1. Hard-coding output triggers in custom programs. 2. Manually triggering output per document. 3. Copying condition records without validation. 4. Ignoring inconsistent output behavior as rare edge case. Output logic must be deterministic and fully validated.
Follow-up 1. Why do some documents trigger output while others do not?
Answer: because output determination depends on condition record combinations and document attributes. Missing or incomplete rule coverage leads to selective triggering.
Follow-up 2. How can teams systematically validate output logic?
Answer: by executing structured test matrices covering document types, plants, vendors, and communication channels to ensure complete condition coverage.
Follow-up 3. Curveball. Why is output determination often tested superficially?
Answer: because teams focus on document creation, not communication behavior. Yet business continuity depends on consistent output execution.
Exclusive pro tip.
In S/4HANA, document creation is only half the process. Reliable communication defines operational success.
Category 20 wrap-up. Output is architecture, not printing.
Output management in S/4HANA is not a cosmetic change. It is a structural redesign of communication logic. When output fails, business stops. Migration demands deliberate re-architecture, not compatibility assumptions.
Transition. When technology changes but people do not.
Even if configuration, valuation, integration, and output logic stabilize, one final challenge remains: user experience. S/4HANA introduces Fiori as strategic UI. When behavior changes, resistance follows.
Category 21. Fiori and user adoption revolt.
S/4HANA shifts user interaction from classic GUI transactions to Fiori applications. Role-based tiles, embedded analytics, and simplified screens replace long-standing workflows. Migration success depends not only on system stability, but on user acceptance.
Scenarios covered in Category 21.
Scenario 111, MIGO versus Fiori behavioral differences. Primary owner MM led. Supporting Fiori. Scenario 112, missing fields in Fiori applications. Primary owner Fiori technical led. Supporting MM. Scenario 113, GUI preference creates shadow systems. Primary owner leadership governance led. Supporting MM. Scenario 114, tile versus backend authorization mismatch. Primary owner security technical led. Supporting basis. Scenario 115, Fiori performance slower than GUI. Primary owner basis technical led. Supporting Fiori.
Scenario 111. MIGO versus Fiori behavioral differences.
After migration, warehouse and procurement users notice that posting goods movements in Fiori behaves differently compared to classic MIGO. Field layout, default values, validation sequence, and navigation flow change. Transactions technically work, but user confidence drops sharply.
Scenario classification.
1. Complexity, medium adoption, and productivity risk. 2. Phase, post-go-live user stabilization. 3. Primary ownership, MM led. 4. Supporting Fiori.
Why this happens, scenario analysis and root cause.
Fiori applications are role-based and simplified by design. 1. Fiori screens are designed around business tasks, not transaction codes. 2. Field sequencing and default logic differ from MIGO. 3. Backend validations may trigger at different interaction points. 4. Custom GUI enhancements are not automatically replicated in Fiori. Behavioral change is intentional, not accidental.
Why this is a migration-exclusive failure.
ECC relied primarily on GUI-based transactions. 1. S/4HANA positions Fiori as the strategic user interface. 2. Migration often introduces Fiori without full behavioral training. 3. Custom GUI modifications do not transfer automatically. 4. Transformation changes user interaction patterns fundamentally. Migration shifts user experience, not just data models.
Ownership, who actually fixes it.
User experience stabilization requires coordination. 1. MM validates process correctness and identifies missing functional fields. 2. Fiori reviews UI configuration and field adaptation options. 3. ABAP ensures backend logic supports Fiori application requirements. 4. Leadership drives structured user training and adoption strategy.
Who gets blamed versus who owns it.
User frustration quickly escalates. 1. Blamed Fiori for being inefficient. 2. Blamed project team for incomplete rollout. 3. Actual owner inadequate change management and UI validation. 4. Root cause assumption that users will adapt automatically.
How this is actually fixed, the right way by a role.
Resolution requires controlled user enablement. 1. MM team validates process integrity and identifies critical behavioral gaps. 2. Fiori team adapts UI configurations and field controls to align with business requirements. 3. ABAP team ensures backend services fully support Fiori transaction flow. 4. Leadership team implements structured training and adoption monitoring.
What not to do, common wrong fixes.
Resistance should not be ignored. 1. Forcing users to revert permanently to GUI. 2. Rebuilding Fiori to mimic MIGO exactly. 3. Ignoring behavioral feedback as temporary resistance. 4. Allowing parallel inconsistent process flows. Adoption requires alignment, not regression.
Follow-up 1. Why do users perceive Fiori as slower even if technically optimized?
Answer: because workflow familiarity influences perceived efficiency. Even small behavioral differences disrupt muscle memory built over years of MIGO usage.
Follow-up 2. Should organizations enforce Fiori-only usage?
Answer: only after validating functional completeness and providing adequate training. Forced adoption without support creates shadow processes.
Follow-up 3. Curveball. Why is UI adoption risk often underestimated?
Answer: because migration teams focus on technical readiness. Yet system value depends on user confidence and operational continuity.
Exclusive pro tip.
If users resist Fiori, it is rarely about technology. It is about trust and behavioral disruption.
Scenario 112. Missing fields in Fiori applications.
After go live, users report that critical fields available in classic GUI transactions are missing in Fiori apps. Procurement teams cannot enter required reference data. Warehouse users cannot view specific indicators, and finance fields appear hidden or unavailable.
Scenario classification.
1. Complexity, high functional and adoption risk. 2. Phase, post-go-live stabilization. 3. Primary ownership, Fiori technical-led. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
Fiori applications are designed with role-based simplification. 1. Standard Fiori apps do not expose all GUI fields by default. 2. UI adaptation settings were not fully configured. 3. Custom fields were not extended to Fiori layer. 4. Backend OData services do not include required attributes. Simplification without validation creates functional gaps.
Why this is a migration-exclusive failure.
ECC GUI allowed unrestricted field visibility. 1. S/4HANA Fiori apps are task-oriented and controlled. 2. Custom GUI fields do not auto-appear in Fiori. 3. Migration shifts UI logic from transaction-based to role-based. 4. Transformation requires deliberate UI extension strategy. Migration changes visibility governance.
Ownership, who actually fixes it.
UI completeness requires layered coordination. 1. Fiori reviews app configuration and field extensibility options. 2. MM defines mandatory business fields per process. 3. ABAP extends backend CDS views and OData services if required. 4. Architecture ensures clean core compliant extensibility approach.
Who gets blamed versus who owns it?
Field absence creates operational frustration. 1. Blamed Fiori for incomplete design. 2. Blamed migration project for oversight. 3. Actual owner missing UI adaptation and extension validation. 4. Root cause assuming GUI parity without verification.
How this is actually fixed, the right way by a role.
Resolution requires structured UI extension. 1. Fiori team activates and configures required fields through UI adaptation and app extensibility. 2. MM team defines mandatory functional attributes for each business role. 3. ABAP team extends CDS views and OData services to expose missing backend fields. 4. Architecture team validates that extensions comply with clean core principles.
What not to do, common wrong fixes.
Improper extensions create upgrade risk. 1. Reverting all users permanently to GUI transactions. 2. Modifying standard apps directly without extension framework. 3. Hard-coding fields in UI without backend alignment. 4. Allowing inconsistent field visibility across roles. Field governance ensures sustainable extensibility.
Follow-up 1. Why do some fields exist in backend but not in Fiori?
Answer: because Fiori apps expose only fields defined in the underlying CDS and OData layers. Backend presence does not guarantee UI visibility.
Follow-up 2. How can teams systematically validate UI completeness?
Answer: by mapping every business-critical GUI field to Fiori role-based apps during testing and validating extension coverage before go live.
Follow-up 3. Curveball. Why do users escalate missing fields more aggressively than performance issues?
Answer: because missing fields block execution immediately. Performance delays frustrate, but missing fields prevent task completion entirely.
Exclusive pro tip.
Never assume GUI parity. Validate every critical field in Fiori before declaring functional readiness.
Scenario 113. GUI preference creates shadow systems.
After migration, users resist Fiori adoption and continue operating primarily in classic GUI transactions. Some departments create offline tracking sheets or side processes to avoid new workflows. Over time, reporting inconsistencies and data entry duplication begin to appear.
Scenario classification.
1. Complexity, high governance and data integrity risk. 2. Phase, post-go-live adoption phase. 3. Primary ownership, leadership, governance-led. 4. Supporting MM.
Why this happens, scenario analysis and root cause.
Behavioral resistance follows structural change. 1. Users are comfortable with long-standing GUI workflows. 2. Training and change management were insufficient. 3. Fiori apps were introduced without phased adoption strategy. 4. Parallel access to GUI allows bypassing new standards. Adoption failure is rarely technical. It is cultural.
Why this is a migration-exclusive failure.
ECC relied almost entirely on GUI interaction. 1. S/4HANA promotes role-based Fiori usage. 2. Migration introduces competing interaction models. 3. Transformation forces behavioral adaptation. 4. Shadow systems emerge when governance is weak. Transformation impacts people as much as processes.
Ownership, who actually fixes it.
Adoption stabilization requires leadership intervention. 1. Leadership defines mandatory usage policy and monitors compliance. 2. MM identifies process deviations caused by shadow workflows. 3. Fiori improves usability and resolves critical adoption blockers. 4. Change management drives structured training and feedback loops.
Who gets blamed versus who owns it.
Shadow systems create silent operational risk. 1. Blamed users for resisting change. 2. Blamed Fiori for poor design. 3. Actual owner insufficient governance and adoption planning. 4. Root cause lack of structured behavioral transition strategy.
How this is actually fixed, the right way by a role.
Resolution requires cultural and structural alignment. 1. Leadership team enforces controlled decommissioning of legacy GUI transactions where appropriate. 2. MM team monitors process compliance and identifies deviations. 3. Fiori team addresses usability concerns and optimizes application flow. 4. Change management team implements structured training and feedback governance.
What not to do, common wrong fixes.
Ignoring shadow behavior increases systemic risk. 1. Allowing unlimited parallel GUI and Fiori usage indefinitely. 2. Dismissing resistance as temporary noise. 3. Punishing users without addressing usability gaps. 4. Ignoring spreadsheet-based shadow reporting. Shadow systems undermine architectural integrity.
Follow-up 1. Why do shadow systems appear even when Fiori works technically?
Answer: because user comfort and habit influence behavior more than system capability. Without governance and training, users revert to familiar tools.
Follow-up 2. Should GUI be disabled completely?
Answer: only after validating that Fiori covers all critical business scenarios. Forced disablement without readiness increases disruption.
Follow-up 3. Curveball. Why is shadow system risk often invisible to leadership?
Answer: because shadow processes operate outside formal reporting structures. Risks accumulate silently until inconsistencies surface in audits.
Exclusive pro tip.
User adoption is governance, not preference. Transformation fails quietly when shadow systems thrive.
Scenario 114. Tile versus backend authorization mismatch.
After go live, users can see Fiori tiles on their launchpad but encounter authorization errors when executing the application. In other cases, users cannot see tiles at all despite having backend roles. Confusion escalates as business processes stall without clear ownership.
Scenario classification.
1. Complexity, high access and operational risk. 2. Phase post-go-live stabilization. 3. Primary ownership, security, authorization-led. 4. Supporting Fiori basis.
Why this happens, scenario analysis and root cause.
Fiori introduces a two-layer authorization model. 1. Fiori catalog and group assignments control tile visibility. 2. Backend roles control execution authorization. 3. Role redesign during migration was incomplete or misaligned. 4. Transport sequencing created inconsistencies across systems. Visibility and execution are governed separately in S/4HANA.
Why this is a migration-exclusive failure.
ECC relied on single-layer GUI authorization. 1. S/4HANA introduces Launchpad-based UI governance. 2. Migration requires redesign of composite roles. 3. Authorization concepts shift from transaction-based to role-based. 4. Transformation exposes incomplete security mapping. Authorization becomes architectural in S/4HANA.
Ownership, who actually fixes it.
Authorization alignment requires structured coordination. 1. Security team aligns Fiori catalogs with backend composite roles. 2. Fiori team validates Launchpad configuration and content activation. 3. Basis team ensures correct transport and system role synchronization. 4. MM team validates business process execution post-alignment.
Who gets blamed versus who owns it.
Access failures trigger immediate escalation. 1. Blamed basis because the app does not open. 2. Blamed Fiori because the tile is visible but unusable. 3. Actual owner security design misalignment during role redesign. 4. Root cause, incomplete end-to-end authorization testing.
How this is actually fixed, the right way by a role.
Resolution requires layered authorization validation. 1. Security team redesigns composite roles aligning tile catalogs with backend authorizations. 2. Fiori team validates Launchpad assignments and application mappings. 3. Basis team verifies transport synchronization and role activation. 4. MM team conducts process-based testing to confirm execution completeness.
What not to do, common wrong fixes.
Quick access fixes create audit risk. 1. Granting SAP all temporarily to bypass errors. 2. Manually adding roles without governance review. 3. Ignoring tile-level testing during regression cycles. 4. Assuming backend authorization automatically controls UI visibility. Authorization shortcuts create long-term compliance risk.
Follow-up 1. Why can users see tiles but not execute them?
Answer: because tile visibility is controlled by Fiori catalogs, while execution requires backend authorization objects. Both layers must align.
Follow-up 2. How can teams prevent this during migration?
Answer: by conducting role-based testing that validates end-to-end business execution, rather than simply checking tile presence.
Follow-up 3. Curveball. Why is SAP all considered dangerous during stabilization?
Answer: because it masks authorization design flaws and introduces compliance and segregation of duties violations.
Exclusive pro tip.
In S/4HANA, authorization design is architecture. Treat it as such before users do.
Scenario 115. Fiori performance slower than GUI.
After migration, users complain that Fiori apps feel slower than classic GUI transactions. Even simple inventory lookups or purchase order displays appear delayed. Business confidence drops as the expectation of HANA speed clashes with perceived UI lag.
Scenario classification.
1. Complexity, high performance and adoption risk. 2. Phase post-go-live stabilization. 3. Primary ownership basis performance-led. 4. Supporting Fiori ABAP.
Why this happens, scenario analysis and root cause.
Fiori performance depends on multiple architectural layers. 1. Network latency impacts browser-based applications. 2. OData services may not be optimized for large datasets. 3. Custom CDS views may lack proper indexing. 4. Front-end server sizing was underestimated during planning. HANA speed does not guarantee UI speed.
Why this is a migration-exclusive failure.
ECC GUI transactions operated directly within SAP GUI environment. 1. S/4HANA introduces browser-based Fiori architecture. 2. Performance depends on front-end server and gateway configuration. 3. Migration often underestimates UI infrastructure sizing. 4. Transformation adds layers that require optimization. Performance becomes multi-layered in S/4HANA.
Ownership, who actually fixes it.
Performance resolution requires technical alignment. 1. Basis team analyzes front-end server sizing and gateway performance. 2. ABAP team optimizes CDS views and backend query logic. 3. Fiori team reviews app design and reduces unnecessary data loads. 4. team validates business-critical transactions after tuning.
Who gets blamed versus who owns it.
Performance complaints escalate quickly. 1. Blamed HANA for being slower than promised. 2. Blamed Fiori for poor design. 3. Actual owner, infrastructure sizing and service optimization gaps. 4. Root cause, underestimating multi-layer performance architecture.
How this is actually fixed, the right way by a role.
Sustainable performance requires structured tuning. 1. Basis team performs end-to-end performance trace including gateway and front-end servers. 2. ABAP team refactors inefficient CDS views and eliminates unnecessary data retrieval. 3. Fiori team optimizes UI rendering and reduces heavy initial loads. 4. Architecture team defines performance benchmarks for role-based applications.
What not to do, common wrong fixes.
Superficial fixes create deeper problems. 1. Adding hardware without analyzing root cause. 2. Blaming HANA without reviewing OData efficiency. 3. Reverting users to GUI permanently. 4. Ignoring network latency analysis. Optimization requires diagnosis, not assumptions.
Follow-up 1. Why can HANA be fast but Fiori slow?
Answer: because database speed is only one layer. UI rendering, gateway processing, network latency, and CDS design all impact total response time.
Follow-up 2. How can performance be validated proactively?
Answer: by performing load testing on Fiori apps before go live and tracing backend service execution with realistic datasets.
Follow-up 3. Curveball. Why do performance complaints spread faster than technical issues?
Answer: because performance affects every user simultaneously. Even small delays create a perception of instability across the organization.
Exclusive pro tip.
Measure end-to-end performance, not just database speed. In S/4HANA, perception is part of architecture.
Category 21 wrap-up. Technology is easy. Adoption is hard.
Fiori resistance, authorization mismatches, performance complaints, and shadow systems all prove one thing. S/4HANA migration is not only a technical upgrade, it is a behavioral transformation. When adoption is ignored, architecture silently fractures.
Final conclusion. SAP MM migration is architecture, not upgrade.
Across 21 categories and more than 115 real-world scenarios, one pattern repeats. Every failure is rooted in assumptions carried forward from ECC. S/4HANA does not break systems randomly. It enforces discipline that ECC tolerated.
What this entire video proved.
1. Migration failures are rarely isolated configuration errors. 2. Technical simplification exposes historical design shortcuts. 3. Cross-module alignment determines financial integrity. 4. Ownership clarity prevents political blame cycles. 5. User adoption determines long-term system success.
The real message to every SAP MM consultant.
If you treat ECC to S/4HANA as a technical conversion, you will firefight endlessly. If you treat it as architectural redesign, you control the narrative. The difference between chaos and confidence is preparation.
Final pro tip.
S/4HANA does not create problems. It exposes the ones you postponed for years. The best consultants do not just fix errors. They redesign systems before they fail.
Please check description or comment section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP functional modules interviews jobs like SAP MM Consultant jobs, SAP FICO Consultant jobs, SAP SD Consultant jobs, SAP PP Consultant jobs, SAP Ariba Consultant jobs, SAP Extended Warehouse Management EWM Consultant jobs, SAP Plant Maintenance PM Consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section. These questions and answers will be helpful for freshers, 2 to 3 years experienced people and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
For more exciting tips, tricks and more importantly, for valuable insights of interviews, please share, like, and subscribe to my channel. It has a lot of valuable information about various insights of interviews. It has a wide range of real-world portfolio projects of various technologies for interviews, and it has wide range of most asked interview questions and answers of various technologies like data science, SAP, AWS, DevOps, and full-stack web development and more. That will be useful during interviews. It has a wide range of most asked interview questions and answers and real-world portfolio projects of various technologies for freshers, for 2 to 3 years, experienced candidates, and for 5 or above years, experienced candidates to test their skills by knowing most asked interview questions and make themselves ready for interviews.